Section 1 of the Heavenly Bodies, Their Nature and Habitability. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Heavenly Bodies, Their Nature and Habitability by William Miller. Introductory Observation. Preface. Nearly 35 years ago, an idea entered in a notebook occurred to me regarding plurality of worlds, which at that time I imagined went far to unsettle the prevailing belief and to decide a question subsequently much agitated. The little paper in which it was embodied, lying so long dormant, has been the germ of the present work. From a jotting on it I see I had in 1860 observed that another had in a published book struck out a similar idea, and it has since been repeated by other writers. It was then, if not previously, I presume, I became desirous to take up and examine the whole subject in all its bearings. But the incessant claims of an anxious profession altogether precluded the attempt, and it is only of recent date that I've had it in my power to effect my purpose, and to bestow upon the subject the amount of study which I found to be requisite. I may not, however, conceal from myself that many will, with justice, consider that for one who cannot appear with the knowledge and authority of an astronomer, either practical or theoretical, it is a piece of bold presumption to endeavor to handle the matters to which this volume relates. In extenuation, I can only say that the occupations of my profession are favorable to the consideration of anything which demands close inquiry, and to the formation of soundly reasoned conclusions, while I have, in the course of an experience now extending over many years, had, sometimes in the conduct of what have been causes célèbres in their day, opportunities of studying and generally of writing on questions arising out of matters of extremely diversified nature, nor have I dared to enter upon the scientific topics embraced in this book without investigating, with at least the patient care I have always, when the rush and hurry of business would permit, sought to bring to bear on questions upon the solution of which material interests have depended. Still, in gathering and dealing with the evidence, which only others have been competent to furnish, I have necessarily experienced many difficulties, and would often have been glad to have had a chance of putting the witness under interrogation. I can only trust to have made unfamiliar subjects clear to the general apprehension, and that any opinions expressed will be found sufficiently supported. At the same time, considering that these pages embrace so much of what to most people is new, it may not be unreasonable to expect, unless there have been failure to use the proper means for securing attention, that if they do not allure to brighter worlds, they may at least help to lead the reader into fields of research which afford some of the purest and noblest subjects of meditation. To discuss such a subject as the plurality of worlds may be viewed differently by different minds. An American astronomer of the present day, Professor Newcomb, thus writes regarding it, quote, "The question whether other planets are, as a general rule, peopled, is one of highest interest to us, not only as involving our place in creation, but as showing us what is really greatest in the universe. Many thinking people regard the discovery of evidence of life in other worlds as the great ultimate object of telescopic research." End quote. But without claiming for the subject such an undue importance, or availing myself of the time-honored custom conceded to authors of magnifying mine office, it can admit of no doubt that there is a certain amount of interest in the inquiry, and that it has awakened from time to time much attention, a fact which will be manifest from the historical résumé with which I have thought it well to commence. Perhaps the interest excited among the French may have exceeded that manifested by the more thoroughly practical people of this country. It will be seen how enthusiastically Fontenelle's work was received nigh 2 centuries ago, while to all appearance there has been among our philosophical neighbours no flagging of zealous regard for the subject, if one may judge from the fact of the very large number of editions through which Flammarion's Monde Habité and Monde Imaginaire have in a few years passed. And yet this French astronomer, in contending for plurality, seems to have contented himself as much as possible with the slender arguments previously advanced. The question, however, is one which, if it is to be settled on a solid basis, should be examined more searchingly, and my endeavor has been to consider it more fully and methodically. How far I have succeeded remains to be seen. In pondering the plurality of worlds, it speedily became apparent that a very wide range of subjects was involved, and that the idea which had occurred to me so many years before, although important, was in reality but a small point, going but a limited way towards the solution of this much vexed question. I must not, however, anticipate the conclusions to which examination has led. The investigation occasioned divergence into other kindred matters which are not embraced in this volume, unless the chapters on the sun are to be so regarded. But these chapters are truly germane to the leading inquiry, which would hardly be complete without them, for it seemed advisable at the outset of examination to enter upon a careful analysis of what had been discovered regarding the nature and constitution of that important body, as well with a view to ascertain the possibility of its own habitability, as considering it in the light of a representative member of the starry system. From the grave bearing the ascertainment of the state of the fact must have upon conclusions to be drawn regarding the remaining stars. And of very recent years so much has been learnt with regard to our luminary, especially by means of that wonderful instrument, the spectroscope, under the intelligent ingenuity with which it has been employed, that the knowledge now attained almost wholly upsets, or at least supersedes, what was formerly believed, and certainly furnishes us with a more exact acquaintance with a star so comparatively near. The material so acquired enabled me to deliver in Edinburgh 2 lectures on the sun, and while they embraced rather more than was strictly necessary to their due place in discussing the plurality of worlds, it has appeared to me that the facts stated are in themselves of much interest, and are more likely to be generally read when presented in this shape than if the reader had been referred to them as scattered over more scientific and formal works in which they might be found. But in the view of looking at the sun as representing and illustrating the stars generally, it was well to carry with us a fuller notion of the leading circumstances connected with it, and therefore that they should be reproduced here with such little additions and adaptations as seemed suitable, keeping always in view that the study of the sun thus made was to lead up to the consideration of its condition as a residence for life. I have indeed regarded it as a fortunate circumstance that at the time of the preparation of these lectures I had seen no work affording in a systematic manner, and up to date, the information which recent discoveries had brought to light, so that although the investigation was thus rendered troublesome, it served to make it more thorough. Mr. Proctor's Sun, Ruler, etc. of the planetary system, somehow I had not previously seen, and it was dated so far back as 1870, since which time a good deal has been revealed. Professor Young subsequently, 1882, published in the International Scientific Series his interesting work entitled The Sun, which it may be well to keep in view does not in all points accord with the opinions of Mr. Lockyer, by whose researches I had been largely guided. In dealing with life on Earth, I have been led into a more extensive consideration of evolution than I had originally intended, or was perhaps required by its relative importance. But some of its advocates have sought to demonstrate their propositions and to overwhelm their antagonists by the force of dogmatic and rather arrogant assertion, so that it is well quietly to see, so far as needful for present purposes, whether their hypothesis can really be supported or no. Upon this and other points I must leave the further discussion to more competent hands. W.M. George Square, Edinburgh, March 1883. The Sun, a representative star. The solar system forms a minute part of the great galaxy called the Milky Way, a galaxy covering so vast a portion of space that it has been said by a French writer that light, on the calculation, slightly erroneous, of its travelling at the rate of 186,000 miles a second, or upwards of 16,000 millions of miles a day, takes 15,000 years to pass from its one extremity to its other. The galaxy was estimated by Sir William Herschel to enclose in its main portion not less than 18 millions, and probably altogether will not number less than 20 millions of stars. And yet the Milky Way is only one of many. It may be thousands of similar galaxies which, separated from each other by tremendous gulfs, occupy the boundless universe and are so remote that even their distant sheen is invisible to the naked eye, and only in part can be brought to sight by means of the most powerful telescopes. Note: Professor Newcomb is disposed only to allow from 30 to 50 millions of stars altogether. Arago, in place of reckoning, like Flammarion, 15,000 years for the milky flight of light, puts it down at only 3,000, while Dr. Dick, founding on Sir William Herschel's calculations, is content with 1,640, and Lardner suggests 20,000. But astronomers disagree even more than doctors do, and in their estimates vary to an extent far exceeding the notorious divergences of competing builders. When one compares a dozen authorities on any point, it is hard to tell which to believe. Fortunately, the difference of a few millions, more or less, does not materially affect either person or pocket, and equally fortunate is it that astronomical calculations are long and life is short, so that astronomers are occasionally, it is a pleasing relief to find, courteously inclined to borrow. End of footnote. Some idea of the enormous numbers of stars thus filling the heavens may be got by a single computation, for were the 20 millions of stars of the Milky Way to be passed in review before us at the distance of the sun, nearer would be undesirable, and even at so great a distance many would, from the potency of their rays of heat and light, be unendurable by us. And were they, large and small, to move on incessantly in close procession at the rate of only 1 per minute across the sun's disk, equal to a possible average motion of nearly 60 millions of miles in the hour, or 1,000,000 times quicker than the fastest railway train, it would take them about 37 years to march past. Our sun is also a star, as these stars are also all suns, and it is not a little strange to think we have a star brought so comparatively near that it appears to us as a huge globe, and can now be made the subject of close ocular inspection. For, excepting the moon, it is sometimes, or when Mars, Venus, and Mercury are not each approaching conjunction with the earth, the nearest heavenly body. The sun therefore offers itself, and very steadily too, for our examination. And by aid of the means which inventive genius has, especially of late years, devised, examination has been rendered very complete. We have now possessed ourselves of a knowledge of its nature and characteristics, and of many facts previously unknown or obscure, so that the study of the bright luminary of day becomes profoundly interesting, and it is the more so, seeing that in giving a short account of the sun, as it is now proposed to do, it will bring us, by reason of their similarity, into immediate acquaintance with the whole universe of stars. In treating of the sun, it is convenient to deal with it in the two divisions which were originally the subject of separate discourse. The second division, in portraying its constitution, more thoroughly answers to inquiry as to the nature of the stars, the constitution of which is presumably similar. But the facts contained in the first division will materially contribute to the formation of a notion regarding other particulars which should go to complete our conjectural acquaintance with them. For in magnitude, motions, light, and heat there must be, with both individual and generic differences, undoubted general similarity, while the matter of distance is, in its vastness, a point equally applicable to their relations. The enormous immensity of the scale upon which everything connected with our luminary has been designed is overwhelming to our feeble powers of conception. It will be the endeavor of these pages to make some effort towards realizing, though it can only be in a faint measure, what is so impossible for even the most vivid imagination fully or adequately to apprehend or to describe. End of section 1. Read by Czandra, near Montreal, 2024. Section 2 of the Heavenly Bodies, Their Nature and Habitability. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Heavenly Bodies, Their Nature and Habitability by William Miller. The sun's magnitude, distance, motions, light and heat. Footnote. Originally delivered at Edinburgh on 21st January 1882 as a lecture, which, however, has been here considerably altered. End of footnote. By all the early pagans, the sun was regarded as a god, and was worshipped in different countries under different names, such as Baal, so repeatedly mentioned in sacred writ. Aristotle believed it to be animated. Some curious ideas were propounded by the Greeks. Thus Anaxagoras held the sun to be a mass of ignited stone larger than the Peloponnesus, which, roughly speaking, may be said to be about 70 miles square, or somewhere about equal to the half of Scotland south of the Firth of Forth. And this minute fraction of the reality was doubtless regarded by the Greeks as indicating a heavenly body of immense size. Another, Anaximenes, maintained that instead of being, as it appeared to be, a globe, it was flat or thin like a leaf, while Anaximander imagined it to be a chariot of fire, the fire escaping through a circular aperture or hole in the chariot. Zeno supposed the sun to consist of a fire larger than the earth, while still another, Epicurus, represented the sun as a terrestrial mass pierced through like pumice stone and in a state of incandescence. Also, that the sun was kindled in the morning and was in the evening extinguished in the waters of the ocean, into which it seemed to the Greeks, from their geographical position, to fall. Of a different kind, but perhaps to be put alongside of those dreams of unenlightened philosophers, was the opinion of an Englishman, the Reverend Tobias Swindon, who so recently as 1727 published a book in which he set forth reasons for holding the sun to be the local place of hell. Footnote. This curious and rare old book was translated into French, Recherche sur la nature de l'enfer et du lieu où il est situé, traduit de l'anglais par Jean Bron. Swindon, considering hell to be a place of real fire, held that from its nature, size, position, etc., it is adapted to receive the fallen angels and the wicked. Only the French edition is to be found in the Advocate's Library. End of footnote. But a more common, though as we shall speedily be convinced, a less justifiable idea has, I suspect, been to consider it the abode of the blessed. The invention of the telescope in the beginning of the 17th century put an end to such absurd notions as those to which the Greeks gave birth, and brought to man a more accurate knowledge of the heavenly bodies than he had previously possessed, but still led to great diversity and error of opinion regarding the nature of the sun, and it is a circumstance not unworthy of remark that Sir Isaac Newton, with the limited means of research which in his time were within command, but with the giant intellect he possessed, arrived at conclusions which, although only partially correct, have been considered to approximate those which astronomers of the present day, with vastly extended means of investigation, have at last come to hold. Before, however, entering upon a consideration of the constitution of the sun, it is well to make ourselves somewhat acquainted with its size, its distance, its motions, its light, and its heat. Magnitude of the sun. A good many years ago, visitors to London seldom missed going to Leicester Square to see the great globe which was there erected as a model of the earth. I suppose it was probably from 40 to 50 feet in diameter, or as large as a good-sized house. Upon it were delineated the features of the world, its oceans, mountains, rivers, and lands, and I confess that, small as this model comparatively was, it gave me, on walking round it, a better notion of the great planet on which we dwell than I had ever previously experienced. Now, a model of the sun on the same scale would need to be hewn out of a mountain a mile high and a mile thick, for it would require to be a mile in diameter. Placed beside the Leicester Square globe, we should obtain an idea of the comparative size of our great luminary. Perhaps it may be well, still further, to gain an idea of the sun's bulk by first trying to realize the size of this earth. If we could soar on seraph's wings to a height of some hundreds of miles above the earth, the grandeur of its proportions would vaguely fill our sight, but the altitudes within our reach by balloon or mountain ascent would give little notion, and we must seek it in a better way, and it may be had thus. Footnote. The greatest altitude ever attained in a balloon was on occasion of an ascent from Paris on 15th April 1875, when the aeronauts reached a height of 8 miles, but from the extreme rarity of the atmosphere at that great elevation, 2 of them died, so that for scientific purposes it was recommended that thenceforth no ascent higher than 4 miles should be made. But these very lofty ascents by no means afford correspondingly good or satisfactory views. Mount Etna is 10,900 feet, or rather more than 2 miles high, and an extensive prospect must be had from its summit, but it only commands about 1/4000th part of the Earth's surface, which covers 200 million square miles, so that to see the whole world we should require to have it studded at equal distance with 4,000 mountains of similar height, and to ascend them all. End of footnote. The circumference of the Earth is, we know, about 24,000 miles. Should we construct a continuous railway round it and dispatch over it an express train at ordinary express speed, it would take, at 1,000 miles a day, 24 days to make the circuit. That is, constantly traveling night and day by express train, we should be able to dash round the world in somewhat less than a month. This will give some conception of the magnitude of the world upon which we live. Its diameter is 7,916, in round numbers, 8,000 miles, so that if we could bore it and construct a tunnel through to the other side and lay it with rails, we should emerge again to daylight at the Antipodes, say in New Zealand, by express in about 8 days. The Earth, therefore, is in size by no means contemptible, and to us pygmy inhabitants it is very huge. But the Sun is a body hitherto reckoned to be about 355,000 times the mass or weight of the Earth, while, seeing its substance is only about 1/4 of the Earth's density, its real size or volume is correspondingly greater, and is, as hitherto reckoned, 1,348,000 times the volume of the Earth. Now, we can scarcely realize a body 1,000 times greater than the Earth, but here we have one which is no less than nearly 1.5 million times greater, although its distance is so vast that it appears to us as a comparatively small globe, no larger than the Moon, and it only looms large to us when we see it as it rises or sets, resting on the top of a distant hill. The diameter of the Sun, however, in place of being like the Earth, 8,000 miles, is 882,646 miles. Footnote. Young, 866,400 miles. Professor Young bases this and other relative calculations on the more recent estimates of the solar parallax. I have retained the previous estimates and made my calculations on their basis, the actual size and distance of the Sun not being yet authoritatively ascertained. The difference is about 1/54th between the two sets of calculations, but this amount does not materially affect my illustrations. End of footnote. And its circumference is nearly 2,650,000 miles, or 111.5 times that of our world. An express train, therefore, going 1,000 miles a day would take 7 years and 3 months to travel round the Sun. Another method to adopt is to think of the Sun as equal to 70 million times that of the Moon. Conceive, if we can, what would be its apparent size were it brought as near to us as the Moon. Imagine a majestic body moving before us in the firmament in bulk 70 million times, and in diameter 220 times larger than the Moon. These facts may give us some idea, but it may be realized in another way. Assuming the volume of the Sun at the above-mentioned 1,348,000 times that of the Earth, it would require so many globes, each of the size of the Earth, to make up a body equal to the Sun. Now suppose we were in imagination to take these 1,348,000 globes and put them in a line from the Sun out into space. They would extend to upwards of 10,600,000,000,000 miles. Now, as the Sun lies 93 million miles from us, were these globes laid side by side in a straight line, they would extend to about 114 times the distance we are from the Sun, or to nearly 4 times the distance from the Sun of the faraway planet Neptune, which, hugely greater than the Earth, is invisible to the unassisted eye, a distance so great that an express train starting from the Sun would take upwards of 29,000 years to reach the last of the line of globes. It is only in some such way we can approximately realize the enormous mass of matter, or the vastness of the gigantic body of the Sun, which is more than 600, or as Dr. Young states, at 750 times greater than that of all the planets, satellites, and comets of the solar system put together. Indeed, so small is the Earth, in comparison with the Sun, that Professor Tate says, quote, "The Earth, as seen from the Sun, appears very much less than the planet Jupiter, or even Mars, as seen by us. That is, that it would present no visible disk to the naked eye, and that to an observer at such a distance as that of the Sun, it would require a telescope of some little magnifying power to show it as a disk at all." End quote. On the other hand, we would run away with a very false notion if we supposed that the Sun is the largest body in space. On the contrary, it is believed on good ground to be a comparatively small star in the great universe. At all events, it is not among the largest, and the greater number of the stars, in all probability, are quite as large. Indeed, many of the fixed stars may be enormously larger. Mr. Proctor estimates Alpha Centauri, the nearest star, must be in diameter more than half as large again as the Sun, and its volume about 5 times his bulk. Dr. Dick, taking an observation of Sir William Herschel for his basis, calculates that the star Vega, Alpha Lyrae, the third in distance from us, a brilliant star of the first magnitude in the constellation of the Harp, is about 38 times the diameter of the Sun, and that its solid contents are 54,872 times those of the Sun, a magnitude, he truly enough says, quote, "altogether overpowering to the human imagination." End quote. Mr. Grant, however, bringing out an even larger sum, attributes the result to an erroneous determination of the apparent diameter of the star. Yet it is probable that Vega is greatly larger than the Sun, though how much larger may be a matter of opinion. But Sirius, which is farther removed than Vega, undoubtedly seems by consensus of opinion to be vastly larger than the Sun, although in this, as in so many other things, astronomers differ widely in their estimates. For Sir John Herschel estimates the volume of Sirius to be 8,000 times that of the Sun, while Mr. Proctor, on what he conceives a better calculation of the distance of Sirius, though apparently by no means stating with any assurance, gives the bulk at only 4,860 times, large enough certainly, but perhaps by no means approaching the size of some of the brilliant but vastly farther distant stars. Suppose, however, that either Vega or Sirius be only 1,000 times larger than the Sun, their magnitude is beyond our conception, while in all likelihood there are stars much larger, perhaps, even than 54,000 times that of our Sun, stars so large as to exercise control over far distant systems and worlds, magnitudes which cannot be even faintly apprehended by our finite powers. Such a star may be Alcyone, which is said, but not universally admitted, to be the central orb of a great star system of which the Sun and his planets form a part. Footnote. Newcomb, page 208, states that for the most part the stars with a decided parallax are not of conspicuous magnitude, which indicates that those of conspicuous magnitude must be vastly larger. End of footnote. Having acquired an idea, however faint, of its size, we may pass to consider the prodigious distance of the Sun. Here it is necessary to start with a knowledge of what the distance actually is in figures. It is a problem very far from being easy of solution. Quote, "In the time of Copernicus, it was supposed that the Sun's distance could not exceed 5 millions of miles, and indeed there are many who thought that estimate very extravagant. From a review of the observations of Tycho Brahe, Kepler, however, concluded the error was actually in the opposite direction, and that the estimate must be raised to at least 13 millions. In 1670, Cassini showed that these numbers were altogether inconsistent with the facts, and gave as his conclusion 85 millions. Footnote. Conflict between Science and Religion, page 173. Huygens estimated the distance to be 25,086 semi-diameters of the Earth, or 99 millions of miles. Newcomb, page 173. See also Halley's mention of the various early computations. Ferguson's Astronomy, page 449. End of footnote. 85 millions was also erroneous because short of the true distance. 50 years ago, children were taught at school that the distance was 95 millions. Now, any schoolboy will probably affirm it to be 91 millions. Footnote. In Guillemant's Heavens, the distance is stated to be 91,430,000 miles, 1876 edition, page 14. End of footnote. But it turns out that every schoolboy is wrong, and that the real distance is different and rather greater. And this leads to the consideration of how the distance is determined. There are various methods as to which see Professor Forbes on the Transit of Venus, Chapter 2, also The Sun by Dr. Young, page 25. But the one which obtains most favor is that which arises out of the observation of the transits of the planet Venus, or its passing across the face of the Sun. These transits occur in pairs 8 years apart, and with 122 years between the pairs. The last transit took place on 8th December 1874, and the next will be in December 1882. Footnote. This lecture was delivered previous to the last transit, which, although the weather in Britain generally was unfavourable, has been seen elsewhere to great advantage, and excellent results from the observation are fully anticipated. End of footnote. And the next succeeding one will not be till 7th June 2004, that is, 122 years afterwards. Nor is a transit visible in all parts of the world. It is only seen, at least in its completeness, over a strip or belt of the world varying in position on each different occasion. It was first predicted by Kepler for the year 1631, but was not seen because that particular transit was not visible in Europe. A young English curate named Horrocks, devoted to astronomical pursuits, thereafter calculated a transit for Sunday, 24th November, 1639, the precise hour having been unknown, and there was even an uncertainty as to the day. After an anxious, protracted vigil, interrupted on the Sunday by the requirements of clerical duty, so that the young enthusiast had alternately to rush off to service, doubtless hastily and abstractedly performed, and to rush back excitedly to observe and watch, and nearly baffled by the occurrence of clouds, which, however, fortunately withdrew in sufficient time, he was gratified for the first time in the world's history by observing the transit. His observations, though of a very rude kind, were important both in relation to Venus herself and as to the Sun's distance, although it does not appear that he himself observed with this view, and it is to Dr. Halley we are indebted for the suggestion of making the transits a means of measuring the distance of the Sun. His dissertation on the subject, together with Ferguson's observations thereon, and various other relative papers, including account of Horrocks' observation, will be found in Ferguson's Astronomy, pages 434 to 501. Halley's suggestion was the more interesting that it bore reference to an event which would not happen for 70 years thereafter, and therefore long after he should be in his grave. The next transit took place in 1761, and the one following in 1769. On both these occasions, several European states sent out expeditions to those parts of the world where observations could be made to most advantage. One of these expeditions was under command of the famous Captain Cook to the islands of the Pacific Ocean. Great discussion followed on the observations then effected, showing much want of accordance in results, the computations of distance varying from 88 to 109 millions of miles, or no less than 21 millions of miles difference between the highest and the lowest. The celebrated mathematician Encke therefore devoted attention to the subject and revised the calculations in 1822-24, announcing his result to be 95,274,000 miles, and this was held to be the true distance for a long time. Others subsequently computed the distance differently, but Leverrier at last made it 91,759,000, and Airy and Stone 91,400,000. 91 or 91.5 millions was therefore popularly assumed to be, in round numbers, the correct quantity. But astronomers were far from being satisfied, and waited impatiently for the next transit of Venus to enable them to make their calculation more exact. They had to wait a long time, for Venus, with feminine inflexibility, would not go out of her way 1 second to please the most impatient astronomer. term he ever so wisely. The next transit did not happen till 1874. By this time, the means of observation had attained to vastly greater perfection than at the time of the previous transits, and all the civilized powers, recognizing the importance of ensuring absolute accuracy in observing the transit then to take place, provided expeditions to the different parts of the world where the transit would be seen. Books were published on the subject, including one by Mr. Proctor and a smaller one by Professor George Forbes. That by Mr. Proctor, who had previously published a series of papers on the subject in his book called The Universe and the Coming Transits, entered pretty fully into the history of the previous observations, and into a detail of the places and mode of observation, and is a model of beautiful illustration. That by Professor Forbes, more of a handbook, after explaining the object of the observation and the different means to be used for attaining results, so as to be checks on each other, gave an account of the various expeditions then to be undertaken by the different countries. The British government, besides making use of existing observations, selected special stations at Alexandria in Egypt, Kerguelen's Island in the southern Indian Ocean, the Sandwich Islands, Rodriguez, and New Zealand, 2 being situated in Kerguelen's Island, 3 in the Sandwich Islands, and 2 in Egypt, where there was also a private one at Thebes, by Colonel Campbell of Blythswood. The sum of £15,000 was originally voted by Parliament in aid, but how much more was subsequently voted, I do not know. Over and above, Lord Lindsay undertook a station at the Mauritius, provided with appliances for utilizing all the different modes of observation, including about 50 chronometers, and Professor Forbes says it was perhaps the most completely equipped expedition which had ever been undertaken by a private individual in the interests of astronomy. But without detailing the various other expeditions, I may simply say that the Germans sent out or stationed 5 or 6, the Russians 46, the French 8, the Americans 8, the Italians 3, and the Dutch 1. In all, the transit was to be viewed from about 75 stations, and the expense of the whole was estimated to amount to between £150,000 and £200,000. The preparations were great for an observation which would scarcely last 4 hours, being the time Venus took to cross the sun. But the observations then made were only the beginning of the inquiry. They afforded materials merely, for after they had been duly noted they fell to be compared, and results deduced, and the number of calculations requiring to be made was so vast that it literally took years to overtake them. I have seen the number of calculations estimated, which was something astonishing, but unfortunately did not note it down at the time. It would have shown that the facts of astronomy are only obtained not merely by means of much observation, both careful and minute, but by an after process of immense extent of calculation, and by the exercise of great skill, knowledge, and ingenuity, involving patient and laborious working, while they are very costly. Apart from their utility, they are of great interest to those who understand about them. The result of all was to ascertain that previous calculations were in error. The sun was considerably more distant from us than the last calculations had given. The British observers completed their calculations, except what fell to be deduced from the photographic records, in the year 1876, and estimated the sun's mean distance to be 93,300,000 miles, or nearly 2 millions more than the immediately previous estimate, and more than was anticipated. But I believe there has been as yet no final result arrived at by a collection and comparison of the observations and calculations of all countries. Another method of determination has been recently adopted by observation of Mars when in opposition, and for this end Mr. Gill, Her Majesty's astronomer, Cape of Good Hope, proceeded to the Island of Ascension in 1877. He has now published, in a reprint from the Memoirs of the Royal Astronomical Society, an account of his observations with this, quote, "Definitive result of the present investigation, mean horizontal equatorial parallax of the Sun, 8 degrees 78 minutes, with the probable error plus or minus 0.012, which result, combined with the most modern determination of the value of the equatorial radius of the Earth, namely listings, equals 3,962.79 miles, gives for the mean distance of the Earth from the Sun 93,080,000 miles." End quote. Dr. Young, referring to these labors, but before the issue of the final publication from which I've quoted, says, quote, "So far as can be judged from the work thus far published, this determination must be conceded the precedence over all others in respect to its probable freedom from constant and systematic errors and from theoretical difficulties." End of quote. Dr. Young, still writing in the same predicament, collecting all the evidence at present attainable, arrives at a distance of 92,885,000 miles with a probable error of 225,000 miles. Newcomb estimates it to be between 92,200,000 and 92,700,000 miles. The distance of the Earth from the Sun is not always the same because its orbit is elliptical, not circular, and it also varies from year to year through a very long cycle or period of time, so that the difference between the two extremes is no less than 11,300,000 miles, and the difference of heat at the two extremes is as 19 to 26. Quote, "So slow, however," says Ansted, "is the change in eccentricity that although it is now diminishing, and has been so for a long time, it will continue to do so for nearly 24,000 years without being reduced to a minimum. The actual distance of the Sun from the Earth changes every day, and owing to certain changes that take place in its movements, also occupying a long cycle, extending, however, over 25,686 years only, it happens that occasionally, as at present, the Earth is nearer to the Sun in the northern hemisphere during winter than during summer, by about 3 millions of miles. Nearly 10,000 years ago, the Earth was nearest the Sun in summer and farthest in winter, and the eccentricity was greater than it is now. This difference was certainly sufficient to produce a far more excessive climate, that is, a climate much hotter in summer and cooler in winter. As much as 210,000 years ago, the difference was nearly a maximum in every way. Then perhaps was one of the glacial periods of geologists, for then the winter was nearly a month longer than the summer, as well as much colder than it is now." End quote. But assuming the mean or average distance of the Sun at the present time to be 93 million, let us endeavor to realize what this means. And in the first place, we must start by seeing how long it takes to count up a million. Supposing then we could count 200 per minute and did so for 10 hours a day, it would require above 8 days to count a million. To count up 93 millions would therefore occupy at the same rate no less than 2 years, 3 months. From this, we acquire some idea of what an enormous figure 93 millions comes to be. We must, however, try and realize this 93 millions in miles. Now, the velocity at which light travels has been variously computed at different times, and is still subject of investigation. A considerable sum, £1,000, was recently appropriated by the United States of America for the construction of apparatus to compute it. But the latest calculation is, I think, that by Dr. Huggins, who estimates that the rate at which light travels is 185,000 miles per second, and yet the distance is so great that light takes 8 minutes, or rather more, to reach us from the Sun, traveling at this inconceivable rate of speed. Yet truly this helps us but a very short way to realize or comprehend the immense distance, because we have no idea, and can form none, of a speed of 185,000 miles per second. Bearing in mind, however, that there are 480 seconds in 8 minutes, this enormous distance of 185,000 miles must be traveled 480 times over, it is really 500 times, before the light reaches the Earth. Again, the Moon is distant from the Earth about 240,000 miles, and the Sun is removed from us about 390 times the distance of the Moon. Neither, however, can this calculation enable us to comprehend the vast distance, the immense gulf which separates us from our great luminary. As little as we can comprehend the distance by being told that a cannonball discharged from a cannon would, it has been said, take 350 years to reach the Sun. But suppose we adopt our former method of estimating, that is, according to time taken in railway traveling. Now, were a railway laid from the Earth to the Sun by which we could travel to it at the rate of 1,000 miles per day, it would occupy no less than 255 years to perform the journey. so that had Charles I, on the day of his accession to the throne of Great Britain, commenced a journey upon this imaginary railway, he could now only have just arrived at the other terminus, the sun. Or, if some adventurous hero were to begin it now, he would not reach the sun till the year 2135, and he could not get back here, provided the sun would let him, till the year 2390. Traveling by special express train for 255 years would, however, be costly. Might we not try to walk the distance? Suppose, then, some remarkably good pedestrian, endowed with a body incapable of fatigue or decay, were to start on the journey and accomplish 30 miles a day. It would take him no less than 8,415 years. And suppose he did enjoy the somewhat needful Sunday rest, he would not accomplish the journey in under 9,617 years. That is nearly 10,000 years, the odd 383 years being neither here nor there in an expedition of such duration. Of course, I'm supposing a road, laid down all the way as straight as a Roman road, or as many of the roads are in France to this day, and like them, planted with an everlasting row of green shady trees on each side of the highway, and supplied at least at the end of every day's journey with a comfortable hotel furnished with an abundance of the good things of this life, and conducted by a very obliging and accommodating landlord, willing to take drafts on the sun in payment of his bill, and with here and there a tailor and shoemaker's shop to replace what was worn out by the way. The journey would indeed be a remarkably striking one, perhaps striking in a double sense, for the road would be rendered as lively as a city under bombardment, and a good deal more appalling by the constant passage of huge flying bodies, and by coming in sight of terrific globes dashing nearer and nearer with furious and ever-increasing speed, of the moon, of Venus, of Mercury, whizzing with annihilating rush across the sky, Venus and Mercury glowing with a scorching reflection of light and heat from the sun, and comets flashing past with far-extending tail, and then, as the brave traveller, who we shall suppose is protected from all evil consequences, came near the sun itself, what an awful form it would assume, glowing as with millions of tremendous furnaces, and darting out its huge red flickering flames with a frightful rapidity, as if to lick up and suck everything in. He would, though scared and stupefied, be powerless to escape, and only be drawn on by an irresistible but horrible fascination, till unconsciously he touched the fiery willow leaves, the burning waves of the sun, and should be at once ejected as an audacious, prying, interloping trespasser, and sent back on his weary course to earth again, a wiser and a sadder man. The thought of this dreadful walk of 10,000 years will give some idea of the prodigious distance away at which our immense luminary day after day rises in the east, and turns his giant face upon us, benevolently beaming with light and heat and vivifying power. Were the earth itself to lose that centrifugal force which keeps it from obeying the attraction of the sun, and were thus under the influence of the law of gravity to be drawn into the parent orb, it would take little more than 60 days to perform its journey to the great parent orb. But long ere these 2 eventful months were over, we should all have perished upon the face of the earth, while the earth, proceeding on with its freight of dead, would plunge into the sun and be instantaneously swallowed up and lost, like a fragment of coal tossed into a huge smelting furnace. Yet, far as it is removed from the earth, the sun itself, with its surrounding planetary system, is still more inconceivably removed from even the nearest fixed star. The ascertainment, however, of the distances of even the nearest fixed stars is scarcely less difficult than the estimate of their magnitudes. Footnote. For the modes of measuring the distance of the stars, see Sir J. Herschel's outlines. The Astronomer Royal thus informs us as to the method taken by Bessel to ascertain the distance of 61 Cygni, by observations commenced in August 1837 at Königsberg. Quote, I mentioned another way in which the distances of the stars may be ascertained, a method which is free from all those defects of which I have spoken. This method is by the observation of 2 stars, of which one is believed to be very much nearer to the sun than the other, for then we may assume that the distant star will have no sensible change of place from parallax, depending on the position of the earth in its orbit, and then, in observing the stars from the various parts of the Earth's orbit, we can compare the apparent place of that star which we believe to be the nearer with the place of the other. Practically, this is of importance. The refraction, precession, mutation, and aberration are sensibly the same, and there is no uncertainty whatever from the computation of the various quantities which cast so much uncertainty on the results derived from other observations. This is the method pursued by Bessel in determining the distance of the star 61 Cygni. He measured the angular distance of this star from two small stars near it by means of an instrument called the heliometer, well known on the continent, but of which there was at that time no specimen in England. With this he determined the parallax of the star 61 Cygni to be 1/3 of a second. That amounts to the same as saying that the distance is 600,000 times greater than the distance of the Earth from the Sun. It is deserving of attention that 61 Cygni is a double star, but we know from long observation that the two stars partake of the same motions, and probably are a connected system like the Earth and Moon, and therefore we speak of them and of their distance as if they were only one star." End quote. 6 Lectures on Astronomy at Ipswich by George Biddle Airy, Astronomer Royal, 4th edition, page 170. End of footnote. It has been, at least approximately, made in the case of a few, the nearest of all being, as already mentioned, the star Alpha Centauri. This star is calculated to be upwards of 200,000 times more distant than the Sun is from the Earth, its light taking 3 years, 8 months to reach us. In miles, the distance is 19,653,690,000,000, tens of thousands of millions, more or less. But we can only faintly realize a figure so vast when it is added that an express train, traveling 1,000 miles a day, would take upwards of 50 millions of years to reach this, our nearest starry neighbor. Yet the succeeding star is more than twice as far away. The following table of distances has been furnished by Flammarion, corresponding with that of Guillemin. Alpha of the Centaur, number of radii of terrestrial orbit, 211,330. Time the light travels to us, 3 years, 8 months. Alpha of the Swan, number of the radii of terrestrial orbit, 550,920. Time light travels to us, 9.5 years. Vega, Alpha of Lyra, number of radii of terrestrial orbit, 1,330,700. Time light travels to us, 21 years. Sirius, Alpha of the Great Dog, 1,375,000. Time light travels to us, 22 years. Alpha of the Great Bear, 1,550,800 radii of terrestrial orbit. Time light travels to us, 25 years. Arcturus, Alpha of Bootes, 1,622,800 radii of terrestrial orbit. Time light travels to us, 26 years. Pole Star, 3,078,600 radii of terrestrial orbit. Time light travels to us, 50 years. The Goat, Alpha of Auriga, 4,484,000 radii of terrestrial orbit. Time light travels to us, 72 years. These may not correspond with the figures of other astronomers, and indeed their calculations differ considerably, as may be seen by comparing with Newcomb. Footnote: Newcomb's Astronomy, page 536. Mr. Proctor observes on the above list that recent measurement reduces the distance of 61 Cygni and of Sirius, but that, with the single exception perhaps of Alpha Centauri, the stars are at distances beyond our present means of measurement. Guillemin's Heavens, page 292, editorial note. End of footnote. But they suffice to give an idea of the enormous spaces by which one star is removed from another. There are stars in the Milky Way which are some 1,000 times as far removed as Alpha Centauri, and Herschel believed his telescope revealed the light of stars which took 2 millions of years to reach us, so that if he was right, these stars are 600,000 times as distant as the nearest star. One is overwhelmed with the thought. but we require to take along with the distances the conception of the sun's motions. End of section 2. Read by Czandra, near Montreal, 2024. Section 3 of the Heavenly Bodies, Their Nature and Habitability. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Heavenly Bodies, Their Nature and Habitability by William Miller. The Sun's Magnitude, Distance, Motions, Light, and Heat, Part 2. The Sun does not in reality revolve on its axis so fast as the Earth, but its bulk is so greatly larger that the actual motion at the surface or circumference is nearly 4 times faster. Were the Earth to move at its surface as rapidly as the Sun moves at its surface, we should see the Sun, Moon, and stars perceptibly sailing through the heavens. But besides its diurnal motion on its axis, the Sun is also moving through space, carrying along with it the Earth and all the other planets. And it does so with a prodigious velocity of well nigh 500,000 of miles a day, or about 150 million miles in a year. And yet, at a speed which we cannot apprehend, it would occupy the Sun from 120,000 to 130,000 years to reach the nearest fixed star, were that star in its course, and would wait its arrival. The Sun is believed to be moving in a tremendous orbit of its own round some great central sun, which, as already mentioned, has been rightly or wrongly supposed to be Alcyone in the Pleiades, dragging us all with it in its course. Yet although moving at this inconceivable rate of 150 million miles in a year, it is calculated to take 18,200,000 years to make the circuit, so that since the days of Adam it has only performed the 3,000th part of its progress round that distant centre, and how often it has made the circuit no one can tell, or perhaps in this life ever will. Doubtless it has been many times. While all the other stars are in motion too, revolving in great orbits of their own, never jarring or jostling each other, and perhaps all in turn are revolving round a great chief centre, yet in some cases these orbits, if they are orbits, must be so immense that the course of the stars appears to be in a straight line, and some are moving, at such a rate that the gravitation of all the known stars cannot stop them until they shall have passed through and beyond the visible universe. The most remarkable of these, so far as we know, is Groombridge, 1830, it having the largest apparent motion of any star." The motion of this star is so rapid that, "it would pass from the Earth to the Sun in about 5 days, so that its velocity probably exceeds 200 miles per second." Some stars are receding from us, and others are approaching us. See a list in Newcomb, page 458. But the star which is approaching us most directly is Alpha Cygni, which is coming at the rate of about 40 miles per second, and in a period of between 100,000 and 300,000 years will, "pass by our system at something like 1/100th of its present distance, and will for several thousand years be many times nearer and brighter than any star is now." These facts give rise to a curious thought. For keeping in mind that every individual star is at a different distance from us, some vastly farther off than others, so that their light arrives at Earth in different periods of time, while each star is in rapid motion, and is moving in a separate course, the conclusion is forced upon us that when we look upon the face of the sky we see not really a true picture of what at the exact moment surrounds us, for the light of one star having taken 1,000 years to come to us, the star itself is now in a different place from where it was when its light left it, and the light of another having taken 5,000 years is still farther removed from where it was when the light left it, and thus what we actually see differs from what it would be did the light reach us instantaneously, and we then saw the stars just where they respectively are in the heavens. Little as we usually think regarding the magnitude and distance of the Sun, I fear we as little apprehend, though we can more easily realize, its power and its importance to us. "The Sun's rays," says Sir John Herschel, are the ultimate source of almost every motion which takes place on the surface of the earth. By its heat are produced all winds, and those disturbances in the electric equilibrium of the atmosphere which give rise to the phenomena of lightning, and probably also to those of terrestrial magnetism and the aurora. By their vivifying action, vegetables are enabled to draw support from inorganic matter, and become in their turn the support of animals and of man, and the sources of those great deposits of dynamical efficiency which are laid up for human use in our coal strata. By them, the waters of the sea are made to circulate in vapor through the air and irrigate the land, producing springs and rivers. By them are produced all disturbances of the chemical equilibrium of the elements of nature, which by a series of compositions and decompositions give rise to new products and originate a transfer of materials." End quote. Herschel's Outlines of Astronomy, 8th edition, page 259. These, however, are only some of the uses of the sun to us, but the fact is that all life upon the earth is, under God, dependent upon the light and heat which we derive from it, so carefully adjusted and adapted that were they either considerably increased or considerably diminished, we should be either scorched or chilled out of existence, and the means of supporting life would likewise perish. Let us then consider for a little the light and heat derived from the sun. The sun's light, and first with regard to that benign and glorious light with which the parent sun gilds the earth, cheering us from day to day, a blessing so freely bestowed that we think not of it except when it is cut off from us, and a mysterious thing it is too, for it travels, as we've seen, at the enormous speed of 185,000 miles per second. And yet it is only a series of vibrations or waves, dancing to and fro at the rate of about 450 billions of times in a single second. A rapidity of action which is truly as incomprehensible as are the figures by which it is expressed. The ascertainment of the intensity of the sunlight has long been a subject of experimental investigation, and among popular books will be found treated in Guillemin's Sun, Chapter 1, and Young's Sun, Chapter 8, to which I would refer. The comparison has been made chiefly with the light of candles. In 1725, Bouquet, a French astronomer and philosopher, made certain experiments, and taking his calculations as a basis, Guillemin estimates the light of the sun at the zenith, that is, when directly overhead, with a clear sky, to be equal to 75,200 times that of a candle placed at the distance of 3 1/4 feet from the object illuminated. Dr. Wollaston, an English philosopher, made it to be rather less, or equal to about 68,000 times at similar distance. With such a basis of calculation, the number of candles placed on a plane surface facing the earth at the sun's distance, so as to give a light equal to that of the sun, has been computed, but is altogether beyond apprehension. M. Becquerel, another French natural philosopher, made experiments on the limelight, on the light arising from the burning of magnesium wire, and the electric light, and upon the footing of the estimate made of the power of candlelight by Bouguer and Wollaston, Guillemin deduced that the sun's light is equal to 75 times that of the electric light at 3 1/4 feet distance. With more powerful batteries, other experimenters are said to have produced electric light than which the light of the sun was only 2½ times greater, which, if correct, was a near approach to daylight. It must, however, be borne in mind that the sunlight is most intense at noon, when the sun is in the zenith. At sunrise, it was found at Paris on the 20th of June, the height of summer, the light was 1,300 times less than when the sun was in the zenith, and that as the sun rose higher and higher in the heavens, the light proportionally got stronger and stronger. The light of the sun has also been compared with that of the moon and of the stars. Bouguer concluded the light of the sun to be 300,000 times that of the moon, Wollaston as much as 801,072 times, Professor Bond of Cambridge 470,000 times, Zollner 619,000 times as much light as the full moon, a result which Newcomb thinks is probably quite near the truth. Huygens, the celebrated Dutch philosopher of the 17th century, estimated the light of the sun to be equal to 765 millions of times that of Sirius, the most brilliant star in the sky. though in our hazy climate we do not see it glowing with the intensity with which it may be seen in the clearer southern atmosphere of the Riviera. But Wollaston's calculation, made at a long after period, and doubtless with much better means, was much greater, for he estimated the light of the sun to be 20,000 millions of times that of Sirius. Footnote. Great reliance on these computations, however, in the nature of the case cannot be placed. Sir John Herschel and Mr. Bond estimated the light of Sirius at less. End of footnote. And yet, if Sirius were unfortunately brought as near to us as is the sun, its light would be equal to 94 suns similar to our own, a blaze of light by which we should immediately be blinded. The distance of Sirius from us is, however, so enormously great, 7 times that of the nearest star, that, assuming Wollaston's calculation to be correct, it would require the sky to be set, and it would be a gorgeous illumination, with 20,000 millions of visible stars, each with all the brilliance of Sirius, to light us up as fully as we are lighted by the sun. These facts show that there are stars which yield a much greater light than the sun. Sirius is a particularly bright star. Sir John Herschel has estimated the intensity of its light to be equal to the light of nearly 200 stars of the 6th magnitude. But it is comparatively near, and some of the brilliant stars which are much further removed may shine with a far more exceeding splendor. The sun's heat. From the light of the sun, it is an easy transition to pass to consider its heat, for all light produces or carries with it heat. Dr. Lardner, in his treatise on heat, does indeed say that moonlight is an exception, because in whatever degree moonlight can be concentrated by the most powerful burning glasses, it, quote, has never yet been found to affect the most sensible thermometer, end quote. But his book is dated 1833, and doubtless expressed the result of experiments made during upwards of 130 years previously. Subsequent inquiries upset the view, for Professor Piazzi-Smith, who experimented on the top of the peak of Tenerife, Professor Forbes, and Melloni, an Italian, all have detected, though in minute degree, some amount of heat in the moon's rays, while Lord Rosse, using a powerful reflecting telescope, was able to say that the light reflected from the moon can be felt, and he estimated that this heat is the 1/900,000th part of that radiated from the sun. The light emanating from all the stars, or from space, has been calculated by M. Guillemin, and the statement is surprising, to afford the Earth as much heat as is equal to about 5/6 of the heat we derive from the sun. This estimate is founded upon investigations by M. Pouillet, another Frenchman, for it is chiefly to French philosophers we are indebted for investigations on this subject, who found the temperature of interplanetary space to be about 140 degrees centigrade below freezing point, a statement which it seems difficult to reconcile with Guillemin's calculation. The heat received from individual stars has likewise been estimated, and necessarily is minute. That from Arcturus was found to be, quote, equal to the radiation of a Leslie cube of boiling water at a distance of 383 yards, end quote. But we do not by a long way receive from the sun all the heat it emanates. Professor Tate tells us, quote, that the quantity of heat which the whole earth gets from the sun is of the order of something less than the 2,000 millionth part of that which the sun gives out, end quote. Guillemin states the same thing, quote, the heat intercepted by the earth is only 1/2,150,000,000th part of the entire solar radiation, end quote. Further, Sir John Herschel informs us that the heat received by the Earth in a given area is as to the heat on an equal given area in the sun only about 92,000th part, or, as he has elsewhere said, I presume meaning much the same thing, quote, the temperature, that is to say the degree or intensity of the heat at the actual surface of the sun, is more than 90,000 times greater than the intensity of sunshine here on our globe at noon and under the equator, end quote. Putting these facts or calculations together, the amazing amount of heat which exists in and is constantly proceeding from the sun must be something inconceivable, and from early times philosophers have set to work to estimate its intensity and measure its power. Recently, M. Pouillet has invented an instrument, and others have done the same, to measure the solar heat as received by the Earth, called the perheliometer. In one of the most recent works on astronomy, though in parts somewhat sketchy, that by M. Rambosson, laureate of the Institute of France, there are given some of the different opinions which have been held on the subject of the sun's temperature, from which it appears that so great is the disagreement of philosophers that the heat of the sun has been variously estimated at from 1461 degrees up to 10,000,000 degrees, the highest calculation being 6,000 times that of the lowest, from which it is very evident that no great reliance can be placed upon any such estimates, although the progress of science tends to greater certainty. However, even the lowest of these computations states an amount of heat far beyond our experience. Footnote, quote, Secchi originally contended for a temperature of about 18,000,000 degrees Fahrenheit, though he afterwards lowered his estimate to about 250,000 degrees. Ericsson puts the figure at 4,000,000 degrees or 5,000,000 degrees. Zöllner, Spörer, and Lane name temperatures ranging from 50,000 degrees to 100,000 degrees Fahrenheit, while Pouillet, Vicaire, and Deville have put it as low as between 3,000 degrees and 10,000 degrees Fahrenheit. The intensest artificial heat may perhaps reach 4,000 degrees Fahrenheit. End quote. Young's Sun, page 265. End footnote. Endeavor has indeed been made to realize the amount of heat by comparing it with temperatures which can be reached on Earth. Thus it has been estimated by one man that the heat emitted from the sun, which is greatly less than that contained in it, is 1,000 degrees hotter than what is necessary to melt iron. And Sir William Thomson has said it is from 15 to 45 times greater than that developed in the furnace of a locomotive, while he considers the sun's radiation to be equivalent to about 7,000 horsepower per square foot of his surface. While such figures may be mentioned, all we can understand is that the heat is something inconceivably tremendous. The more common methods of computation or comparison, however, are by estimating by its power on ice, by the amount of coal it would be necessary to burn to make its equivalent, by its capacity for boiling, and the like. Computations, as with ice, seem to be a favorite method. For example, Sir John Herschel considers the heat, if it could be concentrated, sufficient to melt a cylinder of ice 45 miles in diameter, continuously darted into the sun with the velocity of light without diminishing the intensity of the sun's heat. Dr. Young says it would in a second of time melt a column of ice 2¼ miles in diameter, spanning the inconceivable abyss between the earth and the sun, and in 7 seconds it would dissipate the whole in vapor. Pouillet describes the heat as sufficient to melt in 1 minute a layer of ice 11.8 meters, nearly 40 feet thickness, or in 1 day 16,992 meters, or 4¼ leagues. That is, were the sun suddenly girt with ice of adequate depth, the power of its heat would in 1 day melt through a belt of ice 13 miles thick. Professor Tyndall estimates this heat as equal to boiling 2,900,000 millions of cubic kilometers, or, as it is elsewhere stated, 700 million cubic miles of water at the temperature of ice. Tyndall also says, quote, expressed in another way, the heat emitted by the sun is equal to that which would be produced by the combustion of a seam of coal 27 kilometers, 16.65 miles thick. End quote. Sir John Herschel puts it that to maintain the heat calculated by Sir William Thomson, it would require 13,500 pounds for every square yard of the sun. That is 6 tons of coal to be burnt each hour on each square yard of the sun. But I only mention these estimates, which really it is impossible for us to realize, in order to furnish some idea, vague and general it must be, of the vast heat existing in and emanating from the sun, even after allowing the largest deduction for overestimates. It is an amount, whichever calculation we choose, with which we have nothing on earth, fortunately, to compare. For, quote, if the sun were to come as near us as the moon, the solid earth would melt like wax. End quote. The experiments and observations made by some of the French philosophers led them to conclude that the solar heat does not exceed 3,000 degrees centigrade, and probably is from 2,500 to 2,800 degrees. In other words, 12 or 14 times the heat necessary to make water boil. These are lower estimates than others and seem to be unreliable. Rossetti finds, says Dr. Young, quote, 18,000 degrees Fahrenheit as the effective temperature of the sun, a result which, all things considered, seems to the writer more reasonable and better founded than any of the earlier estimates. Rossetti considers that this is also pretty nearly the actual temperature of the upper layers of the photosphere. End quote. But really, after all, no more can be said on this subject than that philosophers widely disagree as to the extent or degree of heat, but all agree that it is something far exceeding anything we have experience of here, or which we can possibly realize. I do not enter upon the power of the sun's heat further than to mention that when the sun's rays are collected and concentrated by means of a burning glass, the heat exceeds that of a powerful furnace, and is sufficient to melt gold and convert it into vapor. It is also a curious fact to be stated in the same connection that the heat may be transmitted through a burning glass of ice, so as, without melting the ice itself, to set on fire what is placed in the focus. How this awful heat is produced or maintained is a question which has not yet been solved. Sir John Herschel says, quote, the great mystery is to conceive how so enormous a conflagration, if such it be, can be kept up. Every discovery in chemical science here leaves us completely at a loss, or rather seems to remove further the prospect of probable explanation. End quote. Quote, it is quite certain, says Dr. Young, that it is not a case of mere combustion. If the sun were made of solid coal burning in pure oxygen, it could only last about 6,000 years. End quote. Various theories have been propounded, and one of them, by M. Mathieu Williams in Fuel of the Sun, who, discarding a supposition that it is maintained by a bombardment of aerolites, suggests the ingenious explanation that the sun, traveling through space with a velocity of about 400 to 500,000 miles a day, is fed by the air through which it passes, which he calculates would be equal to fresh fuel at the rate of 165 millions of tons per second. In other words, that the sun is an immense fire fed by fuel. But if I might hazard an observation, I think this view is untenable, because first, it would imply the sun is fed only upon the side or part or half which is in advance. The other half or back part would be unfed, or at least meagerly fed while in rear. And as the sun takes nearly a month to perform its revolution on its axis, each part of its surface would in succession be unfed for nearly half a month. Second, its condition would necessarily be dependent upon the quality of the atmosphere or space through which it passed, in some places densely laden with matter, in others lightly, so that it would burn unsteadily. Third, the probability is that the matter of the system moves with the sun or system, so that its material would soon be burnt out. Fourth, that no appearances in the shape of a trail of smoke or otherwise justify the conclusion. There may be better scientific reason, and indeed any form of maintenance by combustion seems now to be given up, and the view generally entertained appears rather to be that first suggested by Helmholtz, that the great heat is engendered by the tremendous pressure and contraction which the force of gravity should produce, and this is also the view taken by Dr. Young, the latest authority, who, however, allows that a fraction of the heat may result from the falling in of meteors. It is not doubted that the heat of the sun is diminishing, but it is comforting to think that, according to Father Secchi of Rome, the diminution is, quote, almost imperceptible, not exceeding 1 degree in 4,000 years, end quote. The rate, however, is a point upon which it is not possible to form any correct opinion. Professor Tate says, quote, the sun cannot possibly cool more than a single degree centigrade in 7 years. It may be, on the highest estimate we can take, 1 degree in 7,000 years. The data are very uncertain, but we may say that these are the limits between which it must lie, end quote. But, taking the highest estimate of 7,000 and the temperature of the sun to be now 18,000 degrees, and it may be vastly more, the conclusion would be that in 126 million years the sun will cool down to zero. Dr. Young, saying that Newcomb allows it only 10 million years to continue to afford sufficient heat to support life, will not himself allow the possibility of 60 millions of years. Indeed, he would assign a total existence for the solar system from its birth to its death of only 30 millions of years, a fraction merely of the periods which others have assigned. The sun's heat, however, might be maintained for a short season longer than it would otherwise be by the falling into it of the planets, a supposition not impossible, for from time to time, though so rarely that, as according to Humboldt, only 20 have been recorded as seen in 2,000 years, there have been instances of stars observed suddenly to blaze out, as if on fire, one of the most remarkable of which was that of a star in the constellation Corona Borealis, which on 12th May 1866 burst out for a period of 12 days from the appearance of a star of the 9th magnitude to that of the 2nd, and then returned to its former magnitude. And there have not been found wanting those who have expressed the opinion that such a blazing out might be occasioned by the violent precipitation of some great mass, perhaps of a planet, upon the star. Footnote: Schellen's Spectrum Analysis, page 523. See also mention of the star in Cassiopeia and the star Alpha Argus in Professor Nichols' Solar System, page 189. End footnote. Indeed, it is now considered, although the period it may take may be very long protracted, that the existence of a luminiferous ether in the realms of space, united to other causes, must offer such a resistance to the planets as will in course of time cause them to fall into the sun, just as the aerolites or falling stars flying through space are arrested by the Earth at the rate of 7.5 millions per day. Professor Tate calculates that if the Earth were to fall into the sun, the heat thus generated would be equal to the heat given out by the sun in about 91 years. Sir William Thomson makes it 95 years and calculates the additional duration which the collapse of the other planets would ensure. Jupiter, falling in, would, from its immensely greater bulk, add 32,254 years, while all the planets together would only effect a prolongation of the sun's beams for 45,604 years. But after all, the sun must in time be reduced to a black body like that of the companion of Sirius, which is almost indiscernible from the faintness of its light, and ultimately to that of the satellites or companion of the star Procyon, which from its darkness has not yet been seen. Mr. Cowley Miller, contemplating speculations of this nature, observes, quote, "When the last of the planets is swallowed up, the sun's energies will rapidly die out, and a deep and deathly gloom gather around nature's grave. Looking into the ages of a future eternity, we can see nothing but a cold and burnt-out mass remaining of that glorious orb which went forth in the morning of time, joyful as a bridegroom from his chamber, and rejoicing as a strong man to run a race." End quote. End of section 3. Read by Czandra. Rigaud, Quebec, 2024.
The Heavenly Bodies, Their Nature and Habitability by William Miller. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Randy Boyum. The Heavenly Bodies, Their Nature and Habitability by William Miller. The Constitution of the Sun, Its Spots and Prominences. Principal Leach of Queen's College, Canada, in a popular work called God's Glory in the Heavens, published in 1863, 18 years ago, expressing an idea which, at that time and for 90 years previously, had prevailed among astronomers, thus describes our subject. The sun may then be conceived as composed of a dark central body, encompassed by successive envelopes or shells, suspended at different heights in the atmosphere, the uppermost being the one which forms the luminous disk of the sun. A Chinese ivory ball, composed of carved concentric shells, represents very well the structure of the sun and the nature of the spots. Upon this dark central body, the supposed inhabitants of the sun were imagined to dwell imprisoned within this tremendous oven, enveloped by a vast surrounding canopy of cloud and fire, which would forever exclude the view of all outside the sun. Its poor denizens we might fairly conceive, if not undergoing the daily torment of continuous suffocation, would, without some marvelous means of refrigeration, be unceasingly suffering the horrid pangs of recasting or stewing alive. We are, however, saved the pain of realizing and sympathizing with so frightful a condition by the knowledge to which we have now attained. During these 18 years, astronomers, with the enormously increased means of investigation at their disposal, and especially by the use of the spectroscope, have been vigorously prosecuting their inquiries, with gigantic strides have succeeded in unveiling many mysteries, and have intelligently and patiently achieved that apparently difficult task of throwing light upon the sun. Nay, we are not content with having our eyes filled with the sun, but we must have our ears too. For within the last few months attempt, it seems, has been made by Professor Graham Bell, under the guidance of M. Janssen, a famous French astronomer, by employment of the photophone, and that with sufficient encouragement, it is said, to justify hope of ultimate success, to explore the noises supposed to accompany the vast movements of matter taking place in the solar surface. Perhaps, in Great Britain at least, Mr. Norman Lockyer is the astronomer who has, by his unwearied labors, most largely contributed to acquaintance with our great luminary. Among the foreign astronomers, we are indebted to the late Father Secchi of Yom, M. Janssen, and others, some of whose names I shall have occasion to mention. Philosophers, owing to the limited means of observation formerly had, have, till recent years, widely differed regarding the constitution of the sun. Some maintained, like Professor Leach, that its interior is or contains a more or less solid body, cool and habitable. Others that the sun is entirely gaseous. The former opinion is now abandoned, and the latter proposition, that it is gaseous, is what is now generally held as the result of more accurate scientific investigation to be its true explanation or description. This, then, is now considered to be the general formation of the sun. 1. The interior or portion which lies below or within what is called the photosphere or surface and is entirely invisible to us. 2. The photosphere or luminous face of the sun. 3. Above this, the chromosphere or denser portion of the sun's atmosphere. And 4. Above the chromosphere, extending to a great height, the corona, or thinner or more attenuated atmosphere. Let us consider these different divisions in their order. 1. The interior of the sun. Though invisible, there is every reason to believe it to be composed of gaseous vapors in a state of incandescence, burning with inconceivable heat. And this conclusion is supported by the well-ascertained fact that the density of the sun is so much less than that of the earth as to be only 1.5 times that of water. So that, says Sir John Herschel, it must consist in reality of far lighter materials, especially when we consider the force under which its central parts must be condensed. This consideration renders it highly probable that intense heat prevails in its interior, by which its elasticity is reinforced and rendered capable of resisting this almost inconceivable pressure without collapsing into smaller dimensions. M. Fay, a French astronomer, regards the interior of the sun as consisting of the original nebula from which our whole system has been slowly condensed in a state of dissociation, that is, at such an intense heat that chemical combinations are impossible. Father Secchi, late director of the observatory at Yom, who has largely contributed to our knowledge of the sun by his observations on this, to him, a favorite subject, says, "When the sun at the epoch of its formation has reached a volume about equivalent to that which it now possesses, its temperature would have been at least 500 millions degrees. And, moreover, we know by experiments that even now its surface temperature amounts to several millions degrees. That of the interior is probably higher still. We must conclude from these facts that the sun cannot be composed of a solid mass. Nor, enormous as may be the pressure existent in this mass, it cannot possibly, so to speak, be in a liquid state. Whence we are necessarily led to the supposition that it is gaseous, notwithstanding its extreme condensation." M. Delaunay, another French astronomer, holds that the sun is a gaseous mass with a very elevated temperature, which prevents the elementary substances that enter into its composition from consolidating. M. Rambosson, laureate of the Institute of France, says, "For my own part, after comparing the various solutions that have been proposed, I must pronounce for the gaseous nature of the sun." Professor Young, holding it probable that the sun's core is gaseous, observes, "Nothing could be remoter from the truth than to imagine that a mass of gas under such conditions of temperature and pressure as he had described would resemble our air in its obvious characteristics. It would be denser than water, and since, as Maxwell and others have shown, the viscosity of a gas increases fast with rising temperature, it is probable that it would resist motion, something like a mass of pitch or putty. Such is the concurrence of opinion, and the fact appears to be pretty universally admitted or proved that the heat in its intensity is in the center. Mr. Lockyer observing that there is proof that the deeper we go, the hotter we get, and the coolness, comparative of course, is to be found in the exterior or crust. It is to this comparative coolness, this which to us would be an inappreciable diminution of inconceivably fervent heat, the sun owes. 2. The photosphere, its shining cover. M. Fay, Mr. Lockyer observes, looks upon the photosphere as the surface at which the heat is so acted upon by the cold of space as to allow chemical combinations and solid and liquid particles to exist. It is from this photosphere or shining skin of the sun we derive our light and our heat, and its appearance when examined by the telescope is very remarkable. Observation of it has been made, as stated by Arago, from time to time. It had been remarked by the Bavarian Jesuit Scheiner, a contemporary of Galileo, that the entire surface of the solar body was constantly covered with light and dark streaks of slender dimensions. A century and a half later, 1774, Francis Wollaston, an English astronomer, said, "The sun is frequently dotted, perhaps always is," and Sir William Herschel in 1795 wrote, "The sun appears to be irregular like the skin of an orange." About 20 years ago, Mr. Nasmyth, an English astronomer, examining with more care, observed upon the sun what, from their shape and elongated form, he designated willow leaves, a name by which this peculiar mottling has generally been known since. It has been likened, however, by other observers to slashed blades of straw and to grains of rice, although only visible under a powerful telescope. These so-called willow leaves are necessarily of great size, having been estimated to be not less than 1,000 miles long by from 200 to 300 miles broad. They have been said by some, though it is doubted or disputed by others, to interlace each other like the cross-hatching in a drawing or engraving. The leaves themselves are luminous. The spaces between them, being by contrast dark or less luminous, have been called pores or openings. The leaves have thus been described by Sir John Herschel. According to his, Mr. Nasmyth's, observations made with a very fine telescope of his own making, the bright surface of the sun consists of separate, insulated, individual objects, or things all nearly or exactly of one certain definite size and shape, which is more like that of a willow leaf, as he describes them, than anything else. These leaves or scales are not arranged in any order as those on a butterfly's wing are, but lie crossing one another in all directions, like what are called spills in the game of spillikins, except at the borders of a spot where they point, for the most part, inwards towards the middle of the spot, presenting much the sort of appearance that the small leaves of some water plants or seaweeds do at the edge of a deep hole of clear water. The exceedingly definite shape of these objects, their exact similarity to one another, and the way in which they lie across and athwart each other, except where they form a sort of bridge across a spot, in which case they seem to affect a common direction, that, namely, of the bridge itself. All these characters seem quite repugnant to the notion of their being of a vaporous, a cloudy, or a fluid nature. Nothing remains but to consider them as separate and independent sheets, flakes, or scales having some sort of solidity. And these flakes, be they what they may, and whatever may be said about the dashing of meteoric stones into the sun's atmosphere, etc., are evidently the immediate sources of the solar light, and Giat Bud Sir John makes this singular addition: we cannot refuse to regard them as organisms of some peculiar and amazing kind, and though it would be too daring to speak of such organization as partaking of the nature of life, yet we do know that vital action is competent to develop both heat, light, and electricity. The views relative to the supposed willow leaves have, however, now undergone a change. Mr. Lockyer, in his recent work on stargazing, published 1875, concludes, as the result of the work of many careful observers since Mr. Nasmyth's discovery, that the appearance of mottling is due to dome-like masses, and these dome-like masses are not improbably produced by the upward and downward currents, to which I shall afterwards refer. Indeed, it has been a great subject of controversy, whether this surface or photosphere is solid, liquid, or gaseous. The result of the most recent investigations seems to be the establishment of the position that it is gaseous. Nor do I think this is at all inconsistent with the idea of a certain cloudy and even firm consistency or crystallization, as it were, into shapes more or less resembling the form of willow leaves. Our own clouds, which are not subjected to the same enormous pressure, often assume forms having an apparent solidity or compactness dependent for their shapes upon the currents existing in the atmosphere in which they are suspended. But the surface of the sun is subject to the pressure of an atmosphere which, we shall presently see, is several 100,000 miles high, and this pressure, combined with the contraction occasioned to a metallic gas by exposure to a certain amount of, comparatively speaking, cooler influence, may cause the luminous matter to assume given forms, such as that of the willow leaf. There are, however, breaks in the willow leaf system, for by means of the telescope it is seen that there are here and there upon it, but constantly varying in number, extent, and place, what have been termed spots. I shall deal with them more specifically afterwards. Meantime, I may just say generally that these are huge cavities or holes or irregular wells in the photosphere. On the other hand, there are raised portions which may be considered to be mountains of light and are called faculae. These mountains or ridges always exist round the edges or borders of a spot, but are found all over the sun while the spots are not. They form the most intensely brilliant parts and may be of all magnitudes, says Mr. Lockyer, from hardly visible, softly gleaming, narrow tracts 1,000 miles long to continuous, complicated, and heapy ridges 40,000 miles and more in length and 1,000 to 4,000 miles broad. The height of these ridges no one, so far as I have noticed, seems to have estimated, unless it be Dr. Dick, who speaks of them as several hundred miles above the level. But they would require to be of greater height to be even seen as ridges. They have been attributed to uprushes from the interior of the sun, and if so, may be somewhat akin to the uprush of molten lava from a volcano, although probably not possessed of the same degree of viscous solidity. They have been observed to undergo a melting or disappearing action, and under the influences existing on the sun's surface in time may form portions of the willow leaf system, thus becoming feeders of it. This curious operation is described by Mr. Lockyer, who, in observing a tongue of facula stretching halfway into a spot, at first extremely brilliant, but afterwards losing this brilliancy, says, "At the same time it seemed to me to be giving out, as it were, at its end, and a portion of the umbra between it and the penumbra appeared to be veiled with a stratus cloud evolved out of it. After a time, large, very dim willow leaves seemed to be forming, condensing, on the following portion of the cloudy mass, so that at first you got a very brilliant mass of what appeared to be facula, gradually melting away into the umbra, and then the umbra condensing into willow leaves." 3. The chromosphere. Surrounding the photosphere like an envelope, the spectroscope has revealed the existence of what was considered by Arago and other astronomers to be clouds, and which some thought shone by reflected light. Mr. Lockyer, who was the first or an early observer of certain lines produced by it on the spectroscope, says, "Wherever he looked he found these newly discovered lines, showing that for some 5,000 miles in height all round the sun there was an envelope, of which the prominences were but the higher waves. This envelope I named the chromosphere, as it is the region in which all the variously colored effects are seen in total eclipses, and because I considered it of importance to distinguish between its discontinuous spectrum and the continuous one of the photosphere. Apparently this envelope as a rule bounds the convection currents of the sun, and does not exactly or at all places rest on the photosphere or surface of the sun, but lies, like our clouds, a little above it, leaving hollows between, which are, Mr. Lockyer says, doubtless filled with dense vapors. Father Secchi fancies, apparently, that the space of separation extends to as much as 40,000 miles. But this view does not seem to be concurred in by other astronomers, and is opposed by Mr. Lockyer. The chromosphere itself, though largely consisting of hydrogen gas, is pervaded by the vapors of various metals. It is not of uniform thickness, and its thickness seems to depend on the prominences or eruptions from below, to which I shall afterwards advert. 4. The corona. Above the chromosphere is a luminous atmosphere only visible during total eclipses, called the corona. It is thus described by Mr. Lockyer. A total eclipse of the sun is at once one of the grandest and most awe-inspiring sights it is possible for man to witness. All nature conspires to make it strange and unearthly. Soon the stars burst out, and surrounding the dark moon on all sides is seen a glorious halo, generally of a silver-white light. This is called the corona. It is slightly radiated in structure and extends sometimes beyond the moon to a distance equal to her diameter. Besides this, rays of light, called aigrets, diverge from the moon's edge and appear to be shining through the light of the corona. In some eclipses, parts of the corona have reached to a much greater distance from the moon's edge than in others. It is supposed that the corona is the sun's atmosphere, which is not seen when the sun itself is visible, owing to the overpowering light of the latter. But the speculation regarding the corona has been great. Up to the year 1842, it was firmly believed to be an appendage of the moon and indicated the height of its supposed atmosphere, an opinion which was, Mr. Lockyer mentions, not banished from men's minds till 1860. Thereafter the idea prevailed, and apparently was at one time entertained by Mr. Lockyer himself, that it owed its origin to the Earth's atmosphere. The subject strongly interested astronomers and became a special question for determination by observation in succeeding eclipses, in which all the aids to consideration were had recourse to, particularly during the eclipses of 1869, 1870, and 1871, especially mentioned in Mr. Lockyer's Solar Physics, published in 1874, and also in subsequent eclipses. The methods taken embraced drawings of the appearances as seen by the naked eye, spectroscopic and polariscopic observations, and photography. The observations by these different methods differed, but the representations obtained by means of photography during the eclipse of 1871 seemed to establish beyond any doubt the solar nature of most, if not all, of the corona recorded on the plates. The eclipse of 1875 established this conclusively. Dr. Janssen, well known for his previous observations, watched it carefully and ascertained that the corona was in reality an atmosphere of the sun radiating by itself. Read by Randy Boyum, Denver, Colorado, January 1st, 2025. Section 5 of The Heavenly Bodies, Their Nature and Habitability by William Miller. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Randy Boyum. The Heavenly Bodies, Their Nature and Habitability by William Miller. A curious appearance, perhaps due to an ocular deception, but observed by different persons on different occasions, has been not merely that of a flickering or wavering, but even of a rotary motion, the corona seeming to move in every conceivable way and direction. One man in 1788 said it seemed to be endued with a rapid rotary motion, which caused it to resemble a firework turning round its center. Another, in 1860, similarly described it as a thing that was going round and round like a firework. It is, however, very clear that the corona assumes different shapes and appearances and magnitudes at different times, and especially in being at times broken here and there by rifts. One cannot wonder, therefore, that some people have suggested that the corona was nothing but a permanent solar aurora. It has, however, now been authoritatively established that this corona is in reality an attenuated atmosphere of the sun. But opinions have greatly differed as to the height above to which it extends, the most extravagant opinion ascribing to it 2 or 3 millions of miles in height. Opinions have also differed and fluctuated from time to time in regard to the composition and pressure of the atmosphere. The color or appearance of the corona has been variously described. Dr. Lardner, referring to the observations of Mr. Hind and Mr. Dawes, says, "Its color seemed to be that of tarnished silver, brightest next the moon's limb, and gradually fading to a distance equal to 1/3 of her diameter, where it became confounded with the general tint of the heavens." Gilliman describes it as sometimes of a pearly or silvery white, sometimes yellowish, and even red. Father Fauro, writing to Father Secchi, says, "The color was beyond the power of any artist to paint. All observers agree that it resembled mother of pearl or pure unpolished silver, but far more beautiful and more intensely brilliant. The opinion entertained not many years ago was that the chromosphere is low and of simple composition, subject to a small pressure, and that the envelope of the sun's atmosphere consists solely of hydrogen. All of this is now changed, and there has been a discovery of two new substances in the solar atmosphere. One of these was at one time thought to be vapor of iron, but this opinion was abandoned, and the view was retained that it is the vapor or gas of a substance unknown on the Earth, a gas which seems to pervade the sun's atmosphere from the lowest depths to the greatest elevation. It is denoted by the line in the spectrum number 1474. The other substance discovered is the gas of an also unknown constituent and designated as the line D3. It exists only at the lower altitudes. Both these gases, however, have recently been thought by Mr. Proctor to be a form of hydrogen, though differing from the ordinary forms of that gas as known to us. But this is only a supposition which remains to be, if possible, proved. Hydrogen proper was formerly supposed to be the lightest of all gases or substances, but the unknown gas 1474 is discovered existing still lighter, for it rises high above the utmost limit of hydrogen in the solar atmosphere and forms the outer envelope, extending to at least 500,000 miles high, and probably, could it be detected, and without doubt occasionally, a good deal higher, but at a height of 10,000 times higher than the atmosphere of the Earth, which has commonly been believed to extend only to a height of 50 miles, although a much greater elevation has been assigned to it by some. The line of extreme limit of hydrogen proper in the sun's atmosphere is thought to be about 300,000 miles high, but at this height it exists as a layer of cool gas. Below this again is a layer of incandescent hydrogen gas, that is, gas at a white heat, mixed with vapors of various metals and of other substances. The hydrogen rests on a layer of the unknown element D3, and it again on the chromosphere, which extends 5,000 miles above the sun, and is of a composite character, while the chromosphere, in its undersurface more or less pervaded by hollows, rests separately, probably by some space on the photosphere. Arid the photosphere reposes, if such a term can be applied to a scene of constant fiery activity, on the gaseous matter below, thus floating like a crust on the atmosphere of the sun, by which, on both sides, it is enveloped. Mr. Lockyer describes this succession of elements on the sun in these words: traveling down from X, which gives us the 1474 line, and exists at the extremest, the most utterly distant parts of the corona, right down through the solar atmosphere to the bottom of the deepest spot, we shall pass very much through the different substances in this order. Beginning with the 1474 element, we pass through the sub-incandescent hydrogen. Deeper still, we get to the incandescent hydrogen. Then we go through the D3 element. Then we get into regions where the lines are generally mixed rather more together, but from which magnesium and sodium are generally ejected more frequently and higher than any other material. Then we get into the more doubtful zone of barium and nickel, sometimes sodium being thrown up, sometimes barium, sometimes nickel. And then we come lower down into what may be called, so far as we shall ever be able to investigate the sun, the very bowels of our central orb, where we are certain to get iron, and we may get many other materials. Although the corona extends to high above the sun, it must by no means be thought that it resembles in its upper portions the atmosphere of our earth in density. The corona, it is said, must be hundreds of times lighter than hydrogen. The great comet of 1843 passed at the rate of 350 miles per second, through at least 300,000 miles of it, without visible damage or retardation, whereas shooting stars are instantly and completely vaporized by encountering our atmosphere at a height of 50 or 100 miles. The existence and non-existence of substances in the sun which are known to us on Earth, have been discovered by means of the spectroscope, and different observers have made different lists or tables. But all are agreed that hydrogen, sodium, iron, calcium, magnesium, and nickel are there. As to other substances, opinions differ, but there is, at all events, a general accord that gold, silver, mercury, tin, and lead, all metals having a great specific gravity, with some other substances existing in the earth, are wanting. What have been so discovered all exist, in consequence of the frightful heat, in a state of vapor. The absence of the heavy metals may, I think, be explained on the supposition, according to the nebular hypothesis, that they may find their place in the outer planets. Recently, oxygen has been discovered by Professor Henry Draper. The existence of nitrogen is not yet with certainty ascertained. Professor Newcomb regards the discovery of oxygen as the most important advance in spectrum analysis since Lockyer and Janssen discovered the spectrum of the solar protuberances. With this enormous atmosphere, laden too with so many metallic vapors, joined to the immense attraction or force of gravity exerted by the huge body of the sun, the pressure on the photosphere must be excessive, and to that enormous pressure may be due, as experiment would seem to prove, the brilliancy of the sun's light. While below the photosphere, the pressure must maintain, if it do not produce, the inconceivable heat which fills the vast gaseous cavity forming the interior of the sun. We are now perhaps in a position to approach the consideration of the spots and prominences on the sun, both of which, like everything else connected with the investigation of our great luminary, have, by reason of diversity of opinion, been the subjects of much discussion. The solar spots. The spots on the sun are not usually visible to the naked or unassisted eye. It is to Galileo, the wonderful Italian, the discovery of them is commonly, and apparently with truth, attributed. M. Arago, no doubt, disputes this position, and dates observation back to the time of Virgil, citing cases of observations from the year 321 downwards to 1607 of spots which, on some occasions, were supposed to have been the planets Mercury or Venus crossing the sun's disk. Such observations without telescopic aid, however, can hardly be regarded as having been of much value, and the first real observation was truly made by Galileo, who, in 1610, soon after he had invented his telescope, and even with the very small power he had, at first succeeded in producing, observed, and informed others of the spots on the sun's disk, and from their motion inferred, as one named John Fabricius is said by Arago to have first done, the revolution of the sun upon its axis. The honor of the telescopic discovery was indeed contested by the Jesuit father Scheiner, professor of mathematics at Ingolstadt, but he did not in reality observe them for a year later. Galileo, in a work published by him in March 1613, called History and Explanation of the Solar Spots, settled the controversy between him and Scheiner and his other opponents, while he at the same time first published his views in favor of the Copernican system, a publication which soon brought him into trouble with the ecclesiastical powers of Italy. Galileo's opinion with regard to the spots was that they are matter in or near the sun of the nature of cloud, and are not permanent, that they are black or dark to appearance in the center, but are in reality as bright as the moon. Scheiner, on the other hand, held them to be similar to planetary moons or comets, and that some might be as far from the sun as the moon, Venus, or Mercury, on the Ptolemaic system. They are not, he thought, on the sun, but, although thin, were as dense as the moon. Towards the close of the century, Fontenelle, in his once popular but superficial work on the plurality of worlds, states, and seems to countenance, the absurd notion that the sun is of melted gold, which appears to boil over continually, and by force of its motion casts up the spots as scum or dross to its surface, where it is consumed. Dr. Wilson of Glasgow, in 1774, showed that the spots are cavities, or what he terms excavations, in a luminous envelope surrounding the sun, which, according to his view, was a dark globe. Surrounding the dark spot, there always is a lighter portion, which has been called the penumbra, and Wilson inferred that the penumbra were the sloping sides of the well, at the bottom of which is the black spot. The justice of which deduction, Skirchley says, concurred in by Gilliman, all subsequent research has confirmed. In 1769, Wilson also calculated, according to mathematical principles, that the depth of one spot was equal to the Earth's radius, or 4,000 miles. But generally he assigned a depth of from 2,000 to 4,000 miles. Matthew Williams, however, considers 1 or 200,000 miles as not an unreasonable estimate of the depth of some of the largest sunspots. But this is likely to be as extravagant an estimate as the other is inadequate. A very common opinion, held up till recent times, as we have seen, and one conceived by Dr. Wilson, and shared in by Sir William Herschel, and more recently by the late Professor Nichol of Glasgow, and others, was that the sun is a solid body, and the spots are cavities or displacements in the shining envelope, through which we see the solid body, or nucleus, the cavities being occasioned by the working of some sort of elastic vapor which is generated within the dark globe. The French philosopher Lalande suggests that the spots might be eminences in the nature of mountains actually laid bare. The idea that a spot was disclosure of the assumed solid body of the sun was rather countenanced by the observations of Mr. Dawes in 1851, who supposed he had found the blacker portions of spots merely to be an inferior or lower stratum of very feebly luminous or illuminated matter, which he has called the cloudy stratum, which again in its turn is frequently seen to be pierced with a smaller and usually much more rounded aperture, which would seem at length to afford a view of the real solar surface of most intense blackness. All these and other opinions were formed during the time when the sun could only be examined by means of the telescope, which, even using the finest instrument under the most favorable atmospheric conditions, only enables us to observe the various phenomena as we should do with the naked eye at a distance of 180,000 miles. But the invention of the spectroscope, among its other wonders, has at last, after patient investigation and consideration, and not without the broaching of discordant theories, settled, according to Lockyer, that the spots are occasioned by a downrush from the upper and cooler solar atmosphere of the metallic vapors with which it is loaded through the photosphere to the hotter regions below. A spot, accordingly, is just, in the words of Mr. Lockyer, a place in which principally the vapors of sodium, barium, iron, and magnesium occupy a lower level than they do ordinarily in the atmosphere. It is the seat of a downrush or downsinking, sometimes having the appearance of being formed in a whirlpool, and the greater darkness of a spot is due to the general absorption of the atmosphere, thicker here than elsewhere, as the spot is a cavity. This result of investigation has accounted also for the fact of the gradations of darkness observed in spots, the darker portions being those which are deepest and probably most densely laden with metallic fumes. Such is the simple explanation of solar spots, but there are various circumstances connected with them. 1. In the first place, a spot is often of tremendous size. Gilliman says, in 1779, William Herschel saw a spot which was not less than 50,000 miles in diameter. Those shown in Figure 30 from a drawing by Captain Davis show what enormous dimensions some spots sometimes attain. The largest of them, which has, however, a double nucleus, was not less than 187,000 miles in its greatest length. Its superficies, including the penumbra, was about 25 billion square miles. If these spots are, as we shall see further on, great rents in the luminous envelope of the sun, of what an immense capacity these enormous gulfs, these gigantic abysses, must be. Our entire globe would appear in their depths no larger than a fragment of rock rolled into the crater of a volcano. With such dimensions as these, its spots must sometimes be visible to the naked eye. Arago mentions spots seen equal to 10 times the diameter of the Earth. Dr. Young says that the largest spot yet recorded was observed in 1858. It had a breadth of 143,000 miles and covered about 1/36th of the whole surface of the Sun. Mr. Proctor also mentions the sizes of various spots, stating the largest to have been 143,500 miles. Williams, referring to the great spot observed in 1839, above mentioned by Gilliman, says worlds of the size of ours might be poured by hundreds into such a cavity, like peas in a basin. 2. The spots which advance from east to west sometimes preserve nearly the same form for many days together, but as a rule they are always changing their aspect, are formed and closed with tremendous velocity. And it not unfrequently happens, says Schellen in his work on spectrum analysis, that the appearance of a group of spots is so entirely changed from one day to another that it can no longer be recognized in the new form it has assumed. When near to each other, says Arago, the nuclei appear to have a certain tendency to unite together. They usually enlarge till the moment when their union is effected. I have little doubt that this tendency is the result of gravitation between two or more comparatively solid bodies of vapor, which the nuclei must be. Sir John Herschel says, when watched from day to day, or even from hour to hour, they appear to enlarge or contract, to change their forms, and at length to disappear altogether, or to break out anew in parts of the surface where none were before. In such cases of disappearance, the central dark spot always contracts into a point and vanishes before the border. Spots have been observed whose lineal diameter has been upwards of 45,000 miles, and even, if some records are to be trusted, of very much greater extent. That such a spot should close up in 6 weeks' time, for they seldom last much longer, its borders must approach at the rate of more than 1,000 miles a day. The appearances of a spot breaking up into smaller fractions are described by Francis Wollaston in 1774 as similar to those which happened when, after having hurled a mass of ice upon the surface of a frozen pond, the different fragments into which it divides slide off in all sorts of directions, a description which Gilliman says must not be taken too literally. Dr. Long saw a spot not much less in diameter than our Earth break into two, the parts separating from one another with prodigious velocity. The rate of separation or union, however, has been calculated. Gilliman says, according to the recent observations of M. Chicornac, small spots are precipitated into larger ones with a velocity which sometimes attains to 599 yards per second. An exactitude of measurement even to half a yard not a little surprising, although it in reality means a rapidity of 20 miles per minute, equal to 28,800 miles in a day, or 30 times the speed of a flying railway train. The same author mentions 2 cases of spots, which M. Langmuir estimated receded from each other with a velocity of 121 yards per second, equal to about 5,800 miles per day. 3. A third circumstance is that the spots are only to be found in 2 zones or belts near to the equator of the Sun. They are never observed at the poles of the Sun, which, I may incidentally mention, are not thought to be much colder than the region of the Sun's equator. The equator itself is generally clear of spots, as may be noticed by examining Carrington's plates of observations. 4. But a much more singular circumstance is that the spots are found to travel round the Sun or accompany it in its rotation on its axis at different rates of speed, dependent on their proximity to or distance from the Sun's equator. The nearer they are to the equator, they travel the more rapidly. This observed fact has explained the difference of observations as to the period of the Sun's rotation, which, having been computed by watching the period of revolution of the spots, has varied greatly. It would also evidence a great want of coherence in the photosphere of the Sun, and probably, though Mr. Lockyer thinks not, in its whole body, supposing the Sun to be entirely gaseous and no solid nucleus within. The fact was discovered by Mr. Carrington, who spent 7 years and a half in watching with painstaking minuteness the appearances of the Sun, and the result of his labors on this point was, according to Mr. Lockyer, that he found the rotation of the Sun at the equator is in 30.86 days, or nearly 31 days, while at or 50 degrees north or south latitude, the highest points at which spots have been observed, the rotation takes place in 28.36 days, or in about 28 days, 8 hours. 5. Another peculiarity of the spots arises out of the influence exerted on the Sun by the relative position, the approach or retirement of the planets, and by their conjunctions, and especially by the movements of the planets Mercury, Venus, and Jupiter. In order to obtain grounds for this conclusion, says Mr. Lockyer, the Kew observers have laboriously measured the area of all the sunspots observed by Carrington from 1854 to 1860, and they find as the result of their inquiries that a spot has a tendency to break out at that portion of the Sun which is nearest to the planet Venus. As the Sun rotates, carrying the newly born spot farther away from this planet, the spot grows larger, attaining its maximum at the point farthest from Venus, and decreasing again on its approaching this planet. Here we speak of Venus as it appears to be the most influential of all the planets in this respect. Jupiter appears also to have much influence, and more recently it has been shown that Mercury has an influence of the same nature, although more difficult to discuss on account of his rapid motion. Should, therefore, any two of these planets, or still better, should all three be acting together at the same place upon the Sun, we may expect a very large amount of spots, which will attain their maximum at that portion of the Sun most remote from these planets. It follows as a corollary that the more planets come in conjunction, the greater will be the number of spots or disturbance of the Sun. Mr. Williams states the mean gravitation of Jupiter upon the Sun to be 13 times that of the Earth, of Venus about 2 times, and of Saturn a little above equal, while that of the other planets, Uranus and Neptune, is considerably less than that of the Earth. 6. After the statement of these facts, you will, no doubt, be prepared for another, that the number of spots during successive years seems to run a course, or what is termed a cycle, increasing gradually to a maximum or largest number, and diminishing again to a minimum or the smallest number, and so on. Looking to the regularity of the planetary motions, to which the fact must, I think, be mainly ascribed, we should naturally expect this result. And to the consideration of this question the attention of astronomers has been, and is still being directed. Mr. Lockyer mentions that Herr Schwab of Dessau has now for about 40 years been engaged, without intermission, in registering the number of spots which appear on the Sun's surface, and the result of his labors has been to declare for a period or cycle of 10 years. In other words, that the same series of spots are formed and present themselves after a lapse of 10 years. This conclusion, it is only right to say, has been disputed on the ground that it does not, as alleged, tally with recorded observations, and it cannot be positively affirmed that we are yet in a position to lay down authoritatively a law on the subject, or rather to fix the precise period of time, although it is commonly reckoned to be 10 or 11 years. As all the planets, and even the distant ones, which are the larger bodies, exert an influence more or less, and as their relative positions and conjunctions are intricately varying, it is probable, I think, that there may be a general law giving a 10 or 11 years period due to the positions of Mercury, Venus, the Earth, and Jupiter, or perhaps according with Jupiter's period of revolution, which occupies 11 years 314 days, subject to displacement by the disturbances occasioned by the changing positions of the other planets, whose influence, however, individually is greatly smaller, though conjointly, as has been the case during the last 3 years, it becomes important. Indeed, it is considered that the 11 years period is part of a larger cycle of 33 years, while some have stated another period of maximum spot development of about 56 years. corresponding to the epoch at which Jupiter and Saturn come into conjunction. The fact, however, is a very weighty one, and, as I shall immediately show, we dwellers upon the earth are deeply interested in it. In the meantime, I must take up an equally interesting topic: the solar prominences. They are only visible during a total eclipse, and they are of a regular form and of lake red color. They were at first supposed to belong to the atmosphere of the moon, but that they are appearances in the solar atmosphere is now regarded as beyond question. The first recorded observation of these red flames was made at Bern in 1706. They were again noticed in 1715 and on subsequent occasions, but they were particularly watched during the eclipse of 1842. M. Bailey, one of the observers, thus describes them: "They had the appearance of mountains of a prodigious elevation. Their color was red, tinged with lilac or purple. Perhaps the color of the peach blossom would more nearly represent it. They somewhat resemble the snowy tops of the Alpine mountains when colored by the rising or setting sun." Another writer compared the appearance to a box of ebony garnished with rubies, and another observed them change from white to red and from red to violet, and then back again through the reverse order. The rapid changes they underwent was a feature of the observation of this eclipse. In 1851 they were again watched, and for the first time photographed, although photography does not appear capable of furnishing views of the sun as distinct and clear as can be got by the eye itself. One of the prominences then observed was so brilliant as to be visible to the naked eye, but it would occupy too much space to describe the appearances during this and subsequent eclipses. By that of 1860, when photography was better applied, it was established that there was a continuous envelope, the chromosphere, surrounding the sun, and that the prominences were merely local heapings up of the envelope, and were accordingly attached to the sun, a fact previously conjectured, if not proved, by Mr. Grant in his History of Physical Astronomy. These observations led to the discovery that it was possible to photograph the prominences while they were invisible to the eye, and even while the sun is not under eclipse. Mr. Lockyer in 1866 ingeniously suggested the possibility of observing the prominences when there is no eclipse of the sun, and after working with a spectroscopic instrument of insufficient power, was, on 16th October 1868, put in possession by means of a government grant of a better one. 4 days after he was enabled, he tells us, to examine the prominences while the sun was shining in all the glory that an English autumn permits, and with the result of discovering the existence of that for which he was looking, bright lines in the spectroscopic image. An eclipse had happened in August of the same year, and had been watched in India by M. Janssen, the French astronomer. He also observed the bright lines, and being struck with the brilliancy of the red flames, he was led to consider it might be possible to see them, the spectroscopic image, without an eclipse. He tried it the next day, and was rewarded by the sight, and for 17 days afterwards with similar success. Although he had the good fortune to be in point of time earlier than Mr. Lockyer, who had first suggested the possibility of the examination, yet his communication to Paris was not received till Mr. Lockyer had published his independent discovery. The scientific importances of these concurring observations was this, that they settled, at least in great measure, the problem of what do these flames or prominences consist. It had been previously thought that the prominences were not due to burning vapor, and that they might be particles of solid matter at a red glowing heat suspended in the atmosphere. The question being whether the particles in the photosphere itself might not be likened to a white-hot poker, and those in the atmosphere to merely a red-hot one. The bright lines now discovered upset this idea, and showed that the prominences were truly burning gas. But I shall best convey a description of the observation in Mr. Lockyer's own words. 3 beautifully colored lines of light were visible. 2 of them, corresponding to C and F in the solar spectrum, showed that the famous red flames were composed, in part at least, of incandescent hydrogen gas. that hydrogen gas was present in the atmosphere of the Sun in volumes beside which the size of the Earth is as nothing, welling up in what may be almost considered tongues of flame to a height of 70,000 and 80,000 miles, now running out into strange shapes and branches, now parting from the lower surface and floating cloud-like in the higher regions. Besides these two lines which settled the question as to hydrogen, another line was observed near D3, which, strangely enough, had no dark line in the solar spectrum corresponding with it. I soon found that by sweeping the slit of the spectroscope along the Sun's edge and over the prominences, it was quite easy to determine their outline, the length of the bright line visible giving the height of that part of the prominence on the slit at the time. M. Jansen's observations were nearly similar, and he declares, as a result of his investigations, that the prominences are the seats of movements of which no terrestrial phenomena can give any idea. Masses of matter many hundred times larger than the Earth changing both place and form in the space of a few minutes. The rapidity of the changes and the height to which the prominences have reached, or been blown or driven, has been matter of repeated observation. For example, a prominence 40,000 miles high was subjected to such forces as in 10 minutes to leave scarcely a vestige of it, the changes being apparently greatest in the higher and rarer atmosphere. Professor Respighi, an Italian astronomer who has devoted himself with enormous labor to the observation of the solar prominences, states that he never found a prominence sensibly higher than 150,000 miles, and he has furnished a table of the comparative heights, from which it appears that out of 1,363 prominences, 1,154 did not rise higher than from 25,000 to 50,000 miles, and only 5 exceeded 125,000 miles. Dr. Young says he has seen in all perhaps 3 or 4 which exceeded 150,000 miles, and Secchi has recorded one of 300,000 miles. On 7th of October, 1880, the writer observed one which attained the hitherto unprecedented height of over 350,000 miles. Most astronomers divide the prominences into 2 classes, eruptive and nebulous. But Respighi, from the extent of his observations, is inclined to subdivide much further. They are evidently due to a welling up of hydrogen and other vapors or gases from the hotter regions below, and have been ascribed by some to electricity, by others to heat, and by others to explosions. Whatever be their cause, they are thus the counterparts of the spots, which are due, as already stated, to the down rush of metallic vapors from the cooler heights above. Indeed, so closely connected is this action, which may, I presume, be somewhat likened to that which goes on in the ocean between the poles of the earth and the equator, that, as a rule, when we get the bright line indication of an uprush, we get an absorption line, indicating downrush, by the side of it, often moved towards the red, which shows that we have relative cooler hydrogen descending from above the disturbed part, but at times the index line in many cases disappears altogether. That is, we have no longer relatively cooler hydrogen. The whole of the superincumbent hydrogen has been heated to the same temperature as that of the newly ejected material, which is as hot, or at times hotter, than the photosphere. The prominences rise with immense rapidity, an ordinary rate being 40 miles per second, but often vastly more rapid. Conceive this if we can. Williams says, it must be an enormous volley, millions of cubic miles of a furiously explosive mixture, consisting chiefly of the elements of water. It must be a continuous explosion of such mighty force and magnitude that beggars the imagination in its efforts to picture its action and results. We know the deafening report which accompanies the explosion of a soap bubble when filled with these gases accurately mixed in proportions to form water. What would be the crash if the cupola of St. Paul's were filled in like manner and exploded? What if 100 worlds, all charged with the material of this horrid ruin, were fired successively in one long, bellowing train, combining their propulsive efforts like the contiguous grains of powder in a gun? But not only do the prominences rise with such inconceivable fury and velocity, but they change their form in the most marvelous manner. One of the most extraordinary effects witnessed by man was one which happened on 7th September 1871 and has been described by Professor Young. Just at noon, the writer had been examining with the telespectroscope an enormous protuberance or hydrogen cloud on the eastern limb of the sun, a long, low, quiet-looking cloud, not very dense or brilliant, nor in any way remarkable except for its size, floating above the chromosphere with its lower surface at a height of some 15,000 miles, but was connected to it, as is usually the case, by 3 or 4 vertical columns brighter and more active than the rest. It was about 100,000 miles long by 54,000 high. On viewing it again in less than half an hour, he found the whole thing had been literally blown to shreds by some inconceivable uprush from beneath, and the air was filled with flying debris. When he first looked, some of them had already reached a height of nearly 100,000 miles, and while he watched them, they rose with a motion almost perceptible to the eye, until in 10 minutes the uppermost were more than 200,000 miles above the solar surface. As the filaments rose, they gradually faded away like a dissolving cloud, and at 15, only a few filmy wisps, with some brighter streamers low down near the chromosphere, remained to mark the place. End of section 5. Read by Randy Boyum, Denver, Colorado, April 1st, 2025. Section 6 of The Heavenly Bodies, Their Nature and Habitability by William Miller. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Randy Boyum. The Heavenly Bodies, Their Nature and Habitability by William Miller. Section 6. What a wonderfully fascinating spectacle the sun would present to us on some planet, were there one, near enough to enable us, without being burnt up, to witness such explosions, and perhaps to hear their terrific sound. How inexpressibly beautiful, but how awful would such appearances be! How overwhelmingly grand, but fear-inspiring, would we feel those prodigiously colossal manifestations of the innate forces of nature exerted in play without an effort, and unconscious of their tremendous power, a power controllable only by the Creator from whom it was received. How trivial beside them would seem the most magnificent pyrotechnical displays of the creature man. Professor Young, who says the velocity often exceeds 100 miles a second, and sometimes, though rarely, reaches 200 miles, calculated the uprush he described as just mentioned to be at the rate of 166 miles per second. But let us think for a moment what this terrific rush of 166 miles per second means. It is close upon 600,000 miles per hour. We have all seen and started back from an express train whizzing past us at the rate of 40 miles per hour and know what that means. Yet supposing at 60 miles per hour, nearly the highest speed, the rapidity of the solar uprush of furious flame was 10,000 times greater. We cannot take it in, strain our imagination as we may. The downrush which creates a spot is probably not so rapid, but it must bear some proportion to the uprush. We have seen that the spots form and close at the rate of 1,000 miles a day, but the sun is swept by cyclones with which we have nothing on earth to compare, for the solar wind is calculated to speed at the rate of 120 miles per second, while the greatest hurricane on earth has only blown at the rate of 100 to 120 miles per hour. And it is not the mere speed of rush upwards or downwards or along the surface of the sun which is to be regarded, Nor is it a rush confined to spots or to faculae, for probably every willow leaf is hissing with the light and heat which wells up through it to the surface, and every interstice, every pore or space between the leaves is whistling with the downrush of hot metallic vapor seeking to regain its home in the regions below. Remember, too, what a frightful element it is which is being tossed up and down, back and forth, the element of fire, of heat and light beyond our faintest conception. What a tempestuous burning ocean must be forever boiling and seething and tossing, blown and hurled with irresistible fury into waves perhaps higher than our loftiest mountains, sublimely grand amidst an uproar which would appall the shuddering heart of the stoutest demon of the fiery lake. M. Flannemarion, in a popular work alluding to the solar spots, says, "We may be led to the belief that these are insignificant movements carried on the sun's surface and of small extent. It is not so. They are daily and very important phenomena. Some of them have been known to measure 80,000 miles. That is to say, they are 10 times larger than the earth. Our globe, falling into most of them, would be lost as in a well. Besides being of this size, they are also the seat of various actions and prodigious phenomena. They are not formed suddenly as a whole, but increase to the limit they attain, and afterwards diminish. Some only last a few weeks, others months. Now the movements with which they are animated, either for their increase or diminution, or in their internal action, are sometimes of unheard-of rapidity. Lately, astronomers have followed a dazzling meteor passing through a group of spots with a velocity of 2,000 French leagues per minute. In other parts, they have watched circular whirlwinds dragging into their commotion large spots like the earth, and swallowing them up in abysses with fearful velocity. Sometimes are seen the crests of stormy waves extending over parts of the penumbra, and rising on the white surface of the sun as a still whiter or brighter substance, doubtless projected in their ebullition by interior forces. There have, besides, been seen immense bridges of fiery substances cast suddenly over a black spot, crossing it from one end to the other like an arch of luminous strice, which sometimes is dissipated and falls down into the abyss of lower whirlpools. This body which each day pours out over our heads such a pure and calm light is the seat of powerful actions and prodigious movements, of which our tempests, hurricanes, and waterspouts give us but a slight idea. For these gigantic disturbances are not performed, as here, in an atmosphere of a few leagues thickness and over a few leagues area, but in proportions as vast as its atmosphere, which rises thousands of leagues above its surface, and as its volume, which exceeds 1,450,000 times that of our globe. Now, do not suppose that these disturbances in the sun are immaterial to us dwellers upon earth, for every movement in the sun is fraught with influence upon the earth. The greater the action, the greater the heat evolved. The goodness or the badness of our seasons is dependent upon the extent of the sun's convulsion. Mr. Proctor, in one of his many books, Other Worlds Than Ours, published in 1870, after stating certain of the effects of what he terms the magnetic action in the sun upon the earth, and referring particularly to a magnetic storm in the sun observed on 1st September 1859, which sharply disturbed the self-registering magnetic instruments of the Kew Observatory, interrupted telegraphic communications, and in some cases set the telegraphic offices on fire, while auroras appeared both in the northern and southern hemispheres during the night which followed, and the whole frame of earth seemed to thrill responsively to the disturbance, says, "No disturbance can affect the solar photosphere without affecting our Earth to a greater or lesser degree. But if our Earth, then also the other planets, Mercury and Venus, so much nearer the Sun than we are, surely respond even more swiftly and more distinctly to the solar magnetic influences. But beyond our Earth and beyond the orbit of moonless Mars, the magnetic impulses speed with the velocity of light. The vast globe of Jupiter is thrilled from pole to pole as the magnetic wave rolls in upon it. Then Saturn feels the shock, and then the vast distances, beyond which lie Uranus and Neptune, are swept by the ever-lessening yet ever-widening disturbance wave. The influence thus poetically but truly ascribed by Mr. Proctor to the Sun was an opinion broached so early as 1614 by Baptiste Ballerios, an Italian mathematician, and was revived by Sir William Herschel, but for want of meteorological observations, he and others were obliged to take the prices of wheat as the basis, a very rough one, of comparison and deduction, and it was not surprising that very opposite conclusions were formed by eminent philosophers. While Herschel himself did not escape ridicule for his speculations, a writer in the Edinburgh Review thus delivering himself: "To the speculations of the doctor on the nature of the sun, we have many similar objections, but they are all eclipsed by the grand absurdity which he has there committed in his hasty and erroneous theory concerning the influence of the solar spots on the price of grain. Since the publication of Gulliver's Voyage to Laputa, nothing so ridiculous has ever been offered to the world." It is only right, however, to say that Mr. Carrington does not seem to attach importance to calculations based on price of grain, because social and political causes affect prices to an extent sufficient to destroy their value for the purpose for which he, Herschel, selected them. But the subject has of late years been more fully investigated, and the results form a new chapter in meteorology not to be found even in recent books on this branch of science. Mr. Meldrum, a distinguished meteorologist who lives in the torrid zone, says Mr. Lockyer, tells us that the whole question of cyclones is a question of solar activity, and that if we write down in one column the number of cyclones in any given year, and in another column the number of sunspots in any given year, that there will be a strict relation between them: many sunspots, many hurricanes; a few sunspots, few hurricanes. Only this morning I have received a letter from Dr. Stewart, who tells me that Mr. Meldrum has since found that what is true of the storms which devastate the Indian Ocean is true of the storms which devastate the West Indies. And on referring to the storms of the Indian Ocean, Mr. Meldrum points out that at those years where we have been quietly mapping the sunspot maxima, the harbors were filled with wrecks, vessels coming in disabled from every part of the great Indian Ocean. Now that is surely something worth considering, because if we can manage to get at these things, to associate them in some way with solar activity so that there can be no mistake about it, the power of prediction, that power which would be the most useful one in meteorology, if we could only get at it, would be within our grasp. Observation has likewise been directed to the correspondence of particular solar paroxysms with particular storms upon Earth, and it has been stated that the one follows the other after the lapse of about 2 hours of time. The rainfall has similarly been found, according to tabulated statements, to be obedient to the same influences. But there is a difference of opinion as to whether the terrestrial phenomena are most violent when the spots are at their maxima or at their minima. Professor Balfour Stewart holds that there is greatest solar activity when the spots are greatest, which, so far as I can pretend to judge, really appears to coincide with observation, and that this activity is greatest when the planets are in conjunction, or when they are nearest the sun, is most likely. Indeed, a Dr. Knapp of Chicago has published, in 1879, a pamphlet reprinted in Edinburgh called Coming Disasters on the Earth, 1881 to 1885, resulting from the perihelia of the planets. For, taking Dr. Knapp's dates, Jupiter attained its perihelion in October 1880, Mars in May 1881, Neptune was due in end of 1881, Uranus will reach its perihelion in spring of 1882, and Saturn in autumn of 1885. Besides, in 1881 and 1882, Jupiter, Saturn, and Neptune have been and are and will be almost in conjunction, so that their combined influence on the Sun is great. Such an event as 4 of the largest planets being in perihelia within so brief a space of time as 5 years is a combination which is said not to have happened for 2,000 years, and serious results, storms, floods, earthquakes, and extremes of heat and cold, producing famines and plagues, might, the pamphlet said, be expected. And in proof, Dr. Knapp details a correspondence between such perihelia in former years and famines, pestilences, and other disasters on earth, although he does not seem to trace them up to observed disturbances in the Sun. The severe and changeable weather we have, unfortunately, experienced during the last 2 or 3 years, embracing days of the greatest cold that ever was known in the British Isles, certainly seems to support the conclusion of its direct connection with solar perturbation arising out of the position of the planets. Indeed, what could be more convincing than the storms which have visited us during the last few months, the latest only last night, when Neptune has been attaining his perihelion? We can well imagine that this distant planet, conscious of his wanderings from his great parent, and agitated by his near approach, nearer than he has been for 165 years, the period of his revolution, and distracted by the tugs of his big brothers Jupiter and Saturn, stoiters and staggers in his course, and doubtless is drawn many millions of miles nearer to us than he would wish, or than would otherwise be, while all the 3, Jupiter, Saturn, and Neptune, are having a long pull, a strong pull, and a pull altogether upon their susceptible father, the Sun, who, fancying the time has come in which to gather his erring offspring to himself in a devouring embrace, is, with intenser light flashing from his eyes, opening his soft but treacherous heart to receive the guilty truants, and, excited by the animating thought, into a tumult of boisterous emotion, sends a tremor of terror thrilling to us and to all the trembling worlds of his system. It is confirmatory of this view to know that the Sun has been lately filled with spots. Some days ago, Mr. William Southern, FKAS, writing from Leamington to the Daily Post on 23 November 1881, says, "It will doubtless interest many of your readers possessing telescopes of even small aperture to know that just now the Sun is full of interest on account of the remarkable number of spots visible. On Monday last I counted 20. A group very much resembling the configuration of the constellation Ursa Major, Great Bear, occupied a position a little north of the solar equator and about midway between the eastern and western limbs." Mr. Southern refers in his letter to the 11 years cycle, but makes no allusion to the more important fact of the planetary conjunction and perihelia. The whole subject, however, of the connection between solar spots and terrestrial weather has been for some time matter of investigation and discussion, although apparently little attention seems to have been directed to the planetary influences now affecting us. I can only refer to it thus generally in the expectation that ere long someone qualified to deal with the matter will give us full enlightenment. Meantime, I may just observe that looking to the position of the major planets, our farmers and our sailors may for some time to come, possibly even for a few years to come, continue to experience unfavorable and perhaps stormy weather. But when this severe and trying period shall have passed, it is satisfactory to think that probably it may not again occur in the world's history, till the next similar conjunction, perhaps after another long 2,000 years, shall have run their eventful course. It is not a little curious to find that the ancient Chaldeans had an astro-meteorological period consisting of 12 solar years in which they conceived the phenomena of weather to recur. To a somewhat similar opinion the moderns are now inclining, but doubtless on better scientific grounds. As already stated, the cycle of sunspots has been supposed to be a period of 10 or 11 years, and may possibly be, in accordance with Jupiter's revolution, more nearly the Chaldean period of 12 years. It is therefore most important for us to obtain a true knowledge of the law of succession of these solar disturbances, because we should then obtain a clue to so far unveiling the mysteries of nature and obtaining a foreknowledge of those terrestrial changes which may enable us to foresee, to some extent, like Joseph divinely inspired, a 7 years plenty or a 7 years famine. Imagination has indeed been already sufficiently lively in attributing to solar activity such consequences as the American Secession War and our periodic commercial crises, but more reliable and practical deductions are being made. For, as we all know, our mariners have greatly benefited by the forecasts of storms which our American brethren so kindly and so frequently telegraph to Europe. When our knowledge shall have become more complete and exact, meteorology may have attained a higher place, and will confer greater benefits upon man. Looking to all that has been now stated regarding the sun, yet without entering at present on the question, it would require some confidence to affirm that the sun is the abode of life. But let us suppose it possible, and let us imagine, with a free indulgence in poetical license, some being akin to man carried to the sun's surface. One of the first effects he would experience would be to find every shred of clothing burnt off his body long ere he entered the sun's atmosphere. Well, that would not signify much. There would be little fear of any cold shiver supervening. Matters far more alarming would at once confound him. Every drop of blood would be instantaneously evaporated. Dried, parched, scorched to a living cinder, he would most resemble a bit of unburnable asbestos, with, however, we must suppose, in order that he might comprehend his position, all his senses intact, and, among others, those of feeling, hearing, and also sight, which the glare of the sun, even encountered 90 millions of miles off, takes away. Suppose this remarkable, imperishable, glowing, red being, this desiccated, burning, curled-up cinder, suffering torture inconceivable, steps upon the photosphere of the sun, and with a yell of agony, if a yell could be uttered, and, if uttered, could be heard, sits down upon a hot willow leaf larger than Great Britain. In torment beyond conception, he looks around. There is not a living being of any sort with whom to fraternize in woe. A terrible solitude of devouring anguish environs the place. He looks up through a blaze of light. A comet on lightning wings is rushing and flashing past. Meteors in millions are gleaming and bursting and falling in fiery showers, fast and close and furious. There is not a particle of blue sky on which to rest his parched and blinded eyes. He looks around, and there is not a green tree or even a green blade of grass to refresh his frenzied gaze. There is not a drop of cold water to allay the feverish rage of his unquenchable thirst. There is not a cool cave or grotto into which to retreat from the dazzling glare, or from the overpowering conflagration into which every element of the sun is thrown. There are mountains indeed, and mountains of gigantic height, but they are masses of incandescent metal. Rather are they phantom mountains of thick, fervent vapor, heated to a degree with which we have nothing on earth to compare. There are rivers indeed, or what seem to be so, but they are to appearance torrents of liquid metallic fire, not little sputtering, crackling streams, but pouring heavily ocean-wide in steaming, heaving, burning, tossing, angry, fearful waves, rolling over precipitous heights to awful hollows, and thundering with the roar of 10,000 hurling avalanches, with the horrid din of which, and of the loud tumultuous hissing of violent currents of wrathful gases, tearing from their beds, bursting, blazing, and twisting as they mingle to fight in fierce raging conflict, and darting in colossal tongues of red flame 100,000 miles up, With almost the swiftness of light, the bewildered ear is rent. And now a frightful, fiery, tempestuous tornado sweeps across his leaf with appalling vehemence. He is turned over and over, vainly clutching and clinging to ghostly shapes, and rolls, bruised and crushed he knows not where. Everything around him he fancies grating and crackling, tearing and separating, and he feels his leaf is blown like a feather, and with the speed of an express is flung forward 10,000 miles, and tossed now up, now down, amid a crowd of others shaking and crushing for room, till at last he finds it suspended over a vast, yawning, horrible gulf. In consternation, clinging to some burning barrier, he looks down the dreadful aperture, and sees a seething mass of impetuous, scorching clouds, boiling and swirling and pouring to the bottom, and down, down, far down, into the depths below. He fancies he descries a glowing, metallic-looking mass, which he imagines to be the great body of the sun. Recoiling in fright, his leaf trembles under him, and, terror-struck, he looks up and finds he is again in motion, for a hurricane overwhelms the closing chasm, and he is being driven and sent spinning forward and forward, or rather, backward and backward, to where he was, and all round about other gigantic glowing leaves like his own are impelled and wheeled as by some prodigious whirlwind, and amidst the noise of a titanic conflict, clashing and crashing, they rush in wildest frenzy to embrace. Stunned by the awful shock, our living cinder is suddenly shot high into the air and escapes from his terrific ordeal unconscious. Such, could it be witnessed and experienced, might be the scene upon the sun. Fortunately, we have nothing like it upon earth. But to all this distant turmoil, which is death to all life upon the sun itself, we owe the condition of our little planet, and its beautiful adaptation to receive organic life, and among and above all the being man, to whom has been accorded not merely organic life, but the gift of intelligence and reason, and that which dignifies him beyond every other of the creatures upon earth, a soul, destined to live on and forever on, when sun and moon and land and sea shall be no more. End of section 6. Read by Randy Boyum, Denver, Colorado. April 5th, 2025.
Section 7 of the Heavenly Bodies, Their Nature and Habitability. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Carissa Arango. The Heavenly Bodies, Their Nature and Habitability by William Miller. Are heavenly bodies habitable, or the plurality of worlds considered? When on a clear night, we walk out into the open field, and lifting our eyes to the azure vault, behold 1,000 flickering stars scintillating above us, and know that, excepting a very few which are planets of our system, these are all vastly larger than the great globe on which we dwell. And when we reflect that for every shining orb which thus indicates its existence, the telescope reveals to us millions more invisible to the unassisted eye, and that beyond the reach of all present, and perhaps of all future telescopic power, the universe is filled with other and like orbs, stretching in clusters and vast galaxies in every direction around, to the limitless verge of infinity. And when we conjoin with this grand thought, the consciousness that all about this earth we see life prevailing in every conceivable shape, the tendency is not unnatural mentally to conjure up the conception of numerous and diversified animal and vegetable forms in each of these myriad stars, and, in dreamy reverie, to think that upon each sparkling ball there are beings, active and intelligent, peopling and enlivening its every zone. Nay, while the distances, the magnitudes, the velocities, the periods of the heavenly bodies, or some of them, are ascertained by specific means, with mathematical nicety, to a mile, to a ton, to a fraction of a second of time, but with results so vast that, knowing it all, our imagination refuses to realize figures so precise but so immense, yet where by no application of the exact sciences, by no disposition of X and Y, can there be demonstration of life, or even a single unit of being in any one of those lustrous spheres. That same imagination, no longer inert, seizes the bit, becomes ungovernable, and rushes off with us, and not only endues each globe with life, but pictures to our glowing vision populations of men of like forms and like passions with ourselves, engaged in all the pursuits of earth, and passing through all the phases of existence, from infancy to age, from ignorance to erudition, exhibiting here the old tale of true and tender and passionate love, toiling there amid the din and bustle and anxieties of the overgrown city, or busily engaged from day to day in the hum and rattle of the noisy mill, or speeding with rich and varied cargo on the broad ocean, impelled by towering mast and swelling sail, or by the clanking engine and revolving wheel, or earnestly and skillfully peering at the wonders of the heavens, aided by every mechanical power known to ourselves, and estimating by instruments of observation of rare delicacy their form, their distance, and their nature, or deigning in the secret chamber to raise to the ever-listening ear of the Most High the penitential prayer, or in the hallowed temple an assembled throng of thousand voices, lifting in exalted strain the melodious, measured hymn of grateful and adoring praise. The thought is captivating, and here, if anywhere, amid all the marvels of astronomy, romance may fairly have its mission and can afford to revel with exuberant delight. But our business is now, with calm consideration, to inquire on proper grounds whether imagination thus stirred has been rightly or wrongly directed, and taking into view all the facts which philosophical investigation has brought to light, to form a sound and rational conclusion. Yet ere we proceed to do so, it will be advisable, as briefly as possible, to glance at the views which from time to time have been entertained, and at the controversy which has been waged on this large, most interesting, and as I doubt not it will be found, this most instructive subject. We shall then be in a position more thoroughly to comprehend and more easily to examine the various reasons which have in times past been assigned in favor of plurality, and from such examination to pass to consider in detail all the circumstances which bear upon the question, and especially those which influence determination regarding the various members of the solar system. End of section 7.
Section 8 of the Heavenly Bodies, Their Nature and Habitability. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Heavenly Bodies, Their Nature and Habitability by William Miller. Historical Résumé. Views of Philosophers, Part 1. Joseph Jérôme Lalande, director of the Observatory of Paris, and the author of a treatise in 3/4 volumes, which for a century was the standard work on astronomy, thus expounds the conceptions of the ancients regarding our subject, and the history of opinion to the time of Fontenelle. Quote, I have remarked in the 20th book of my Astronomy that in every period of time it has been believed that the planets were inhabited on account of their resemblance to the Earth. The idea of the plurality of worlds is expressed in the Orphics, those ancient Grecian poems attributed to Orpheus. Proclus has preserved some verses in which we find that the writer of the Orphics places mountains, men, and cities in the moon. The Pythagoreans, such as Philolaus, Hicetas, Heraclides, taught that the stars were all worlds. Several ancient philosophers even admitted an infinity of worlds beyond the reach of our sight. Epicurus, Lucretius, and all the Epicureans were of the same opinion, and Metrodorus thought it as absurd to imagine but one world in the immensity of space as to say that only one ear of corn could grow in a great extent of country. Zeno of Eleusis, Anaximenes, Anaximander, Leucippus, Democritus asserted the same thing. In short, there were some philosophers who, although they did not consider the rest of the planets inhabited, placed inhabitants in the moon. Such were Anaxagoras, Xenophanes, Lucian, Plutarch, Eusebius, Stobaeus, We may see a long list of the ancients who have treated of the subject in Fabricius, and in the Mémoires de Bonamy, Académie des Inscriptions, tome 9. Hivelos appeared as firmly persuaded of this opinion in 1647, when he talked of the difference between the inhabitants of the two hemispheres of the moon. He calls them selenitae, and examines at length all the phenomena observed on their planet after the example of Kepler. It was maintained at Oxford, in certain themes which are mentioned in the News of the Republic of Letters, June 1764, that the system of Pythagoras on the inhabitants of the moon was well founded. 2 years afterwards, Fontenelle discussed the subject in his agreeable work. There are further details of the different astronomical opinions at the end of Gregory's book. For the objections, we may refer to Riccioli, Almagestum, tome 1. In 1686, the Plurality of Worlds was adorned by Fontenelle with all the beauties of which a philosophical work was susceptible." End quote. Historically, these notices are interesting, and the subject will be found more fully treated in Flammarion's Monde Habité. But as adding to the real consideration of the subject, they are of no value. To the ancients, lacking the telescope, the heavens were in reality a sealed book, and as they had no means of knowing what the stars are, and in writing of them only originated conceptions, often strange and fantastic, which they had no means of verifying, their speculations regarding the habitability were merely the dreams of philosophers who knew nothing. Nor, indeed, were the earlier modern astronomers much better placed. They did know something more of the heavenly bodies, and formed more accurate suppositions regarding both their nature and their motions. But the science which they practiced was in its nonage, and could afford no proper data from which to draw legitimate conclusions. Indeed, the little learning they had was then, according to the saying, though in a different sense from that in which it's commonly used, a dangerous thing. For Campoli, in 1615, wrote to Galileo, quote, "Put a great reserve on what you say, for when you establish a certain resemblance between the terrestrial globe and the lunar globe, another person immediately exaggerates it, and says you suppose that there are men inhabiting the moon, and this other person soon begins to inquire how they can possibly have descended from Adam, or come out of the Ark of Noah, with no end of other extravagances of which you have never dreamt." End quote. From which it would seem that to suggest the habitability of other planets was then likely to excite ridicule, while not improbably it might be found to be a perilous heresy. During this infancy of astronomical science, various writers appear to have touched upon our subject, or to have expressed an opinion, nor had knowledge greatly increased when Fontenelle published his Conversations on the Plurality of Worlds, a book which has ever since identified his name with the question. Whatever may have been the merits or demerits of the work, it was for many long years read, credited, and honored. It is indeed somewhat amusing to notice the attention it obtained, the panegyrics with which it was the fashion to commend it. Lalande says, quote, "Whenever I have entered into a conversation with any sensible woman on astronomy, I've always found that she had read Fontenelle's Plurality of Worlds, and that his book had excited her curiosity on the subject. As it has been so much read already, it must continue to engage attention." End quote. Then, mentioning the numerous editions through which it had passed in various countries, he quotes a sentence from Voltaire, declaring that he considered it one of the best books that ever was written. In a biographical notice of the author, prefixed to a French edition of Fontenelle's works, it is also stated that it had a prodigious success, and as the ladies adored Fontenelle, whose bon mots and smart repartees enlivened the salons of Paris, one is not surprised to learn from it that, quote, "Les femmes surtout le lurent avec empressement, et c'est encore, 1825, celui de tous les ouvrages de Fontenelle qui est le plus généralement connu." End quote. Sir David Brewster, writing long after in referring to this singular work, says, quote, "It excited a high degree of interest, both from the nature of the subject and in the vivacity and humour with which it was written. It was read with unexampled avidity, and was speedily circulated through every part of Europe. Wherever it was read, it was admired." End quote. The plan adopted by Fontenelle, as expressed in his preface, was to discourse of philosophy, but not directly in a philosophical manner, and to raise it to such a pitch that it shall not be too dry and insipid a subject to please gentlemen, nor too mean and trifling to entertain scholars." In other words, it was intended to be the beau ideal of popular philosophical treatment of the age in which it appeared. On perusing it, however, one cannot help feeling surprised, not merely at the feeble shallowness of its reasonings, but at the marvellous scantiness of its astronomical facts, the few elementary points inaccurately stated as historical truths, and enclosed within a cloud of a long exploded system of vortices projected by Descartes, who was then a living philosopher, are chopped up into spoon meat and diluted by all the verbosities and digressions, the compliments and the badinage, the doubts and the resolution of doubts of concocted conversation, while into this diluted mixture a few indeterminate crumbs of argument are from time to time dropped, and lie soaking in empty inconclusiveness, till indeed it is difficult to extract precisely even the author's real views upon his great theme. Apparently, however, his opinions were these. Holding the sun to be a place not to be inhabited, he says the moon is inhabited because she's like the earth, but being also unlike, her inhabitants are of a different order. The other planets, for moons in those days were called planets, are inhabited because they are like the moon. The fixed stars are like the sun and therefore not inhabited, but they have each a planetary system, the members of which must be inhabited. But comets, being reckoned as planets coming from other systems, are likewise inhabited. Very curious speculations are indulged in with regard to the Milky Way, which is supposed to be nothing but, "an infinity of small stars not to be seen by our eyes, because they're so very little, and they are sewn so thick one by another that they seem to be continued whiteness," and so near, "that the people in one world may talk and shake hands with those of another. At least, I believe," the author says, "the birds of one world may easily fly into the other, and that pigeons may be trained up to carry letters as they do in the Levant." With all this superficiality of statement and reasoning, it is not surprising that the existence of inhabitants is a point assumed, leaving the sage and his marchioness free to discuss with all vivacity the wonderful character and qualities of those conjectural tenants of the various hot and cold celestial orbs or dwelling places, to which, by the grace of Fontenelle, these tenants, willingly or otherwise, have been assigned a habitation. But a still stranger, though generally less known work, was shortly after written by the Dutch philosopher Christian Huygens, discoverer of the ring and one of the satellites of Saturn, and the inventor of, among other things, the pendulum in its application to clocks. For at the age of 65, Huygens spent his last days in writing the Cosmoterios, or as it is called in the English translation, the Celestial Worlds Discovered, or Conjectures Concerning the Inhabitants, Plants, and Productions of the Worlds in the Planets, and left instructions for its publication, which took place in 1698 after his death. Fontenelle's work is not now to be found in every private library, but Huygens is still more scarce. I could only see it in the library of the University of Edinburgh. Regarding this book, Sir David Brewster, a keen advocate, as we shall see, for the plurality, wrote, "The Cosmoterios is a work essentially different from that of Fontenelle. It is didactic and dispassionate, deducing by analogical reasoning a variety of views respecting the plants and animals in the planets, and the general nature and condition of their inhabitants." The work, which Humboldt, taking a juster view, describes as consisting, "of the dreams and fancies of a great man," is of so singular a character that I must, as briefly as possible, exhibit its contents and nature. After referring to the affirmations of the ancients and of later authors, that the planets and even the stars are furnished with inhabitants, and saying that, "the ingenious French author of the dialogues about the plurality of worlds had not carried the business any further," he imparts to the reader that there was room for his own conjectures, and making certain explanations regarding the bodies of the solar system, he proceeds, Having thus explained the two schemes, there's nobody, I suppose, but sees that in the first, the earth is made of the same sort with the rest of the planets, for the very position of the circles shows it, and that the other planets are round like it, and like it receive all the light they have from the sun. There's no room, since the discoveries made by telescopes, to doubt. Another thing they are like it in is that they are moved round their own axis, for since 'tis certain that Jupiter and Saturn are, who can doubt it of the others? Again, as the earth has its moon moving round it, so Jupiter and Saturn have theirs. Now, since in so many things they thus agree, what can be more probable than that in others they agree too, and that the other planets are as beautiful and as well stocked with inhabitants as the earth? Or what shadow of reason can there be why they should not? If any one should be at the dissection of a dog, and be there shown the entrails, the heart, stomach, liver, lungs, and guts, all the veins, arteries, and nerves, could such a man reasonably doubt whether there were the same contexture and variety of parts in a bullock, hog, or any other beast, though he had never chanced to see the like opening of them? I don't believe he would. Or, were we thoroughly satisfied on the nature of one of the moons round Jupiter, should not we straight conclude the same of the rest of them? So, if we could be assured, but in one comet, what it was that is the cause of that strange appearance, should we not make that a standard to judge of all others by? 'Tis therefore an argument of no small weight that is fetched from relation and likeness, and to reason from what we see and are sure of to what we cannot is no false logic. This must be our method in this treatise, wherein, from the nature and circumstances of that planet which we see before our eyes, we may guess at those that are farther distant from us." End quote. He then concludes the probability of the planets being solid like the earth and not wanting in gravity. Quote, "But now," he goes on to say, page 19, "to carry the search farther, let us see by what steps we must rise to the attaining some knowledge in the more private secrets concerning the state and furniture of these new earths. And first, how likely is it that they may be stocked with plants and animals as well as we? I suppose nobody will deny but there's somewhat more of contrivance, somewhat more of miracle in the production and growth of plants and animals than in lifeless heaps of inanimate bodies, be they ever so much larger, as mountains, rocks, or seas are. For the finger of God and the wisdom of divine providence is in them much more clearly manifested than in the other. One of the Democrituses, or Carte's scholars, may venture perhaps to give some tolerable explication of the appearances in heaven and earth, allow him but his atoms and motion. But when he comes to plants and animals, he'll find himself nonplussed, and give you no likely account of their production. For everything in them is so exactly adapted to some design, every part of them so fitted to its proper use, that they manifest an infinite wisdom and exquisite knowledge in the laws of nature and geometry, as to omit those wonders in generation we shall by and by show, and make it an absurdity even to think of their being thus haply jumbled together by a chance motion of, I don't know what, little particles. Now, should we allow the planets nothing but vast deserts, lifeless and inanimate stocks and stones, and deprive them of all those creatures that more plainly speak their divine architect, we should sink them below the earth in beauty and dignity, a thing that no reason will permit, as I said before." End quote. Now follows a paragraph characteristic of the whole book, for having built up an argument on conjecture, he forthwith assumes a conclusion to be proved, and thence goes on upon like suppositions to infer and build up more. Quote, "Well then, now we have gained the point for them, and the planets may be allowed some bodies capable of moving themselves not at all inferior to ours, for why should they? And these are animals. Now, for fear of starving these poor creatures, we must have plants, you know, and so the other point is gained. And as for their growth and nourishment, 'tis no doubt the same with ours, seeing they have the same sun to warm and enliven them as ours have." End quote. After qualifying this by stating that the plants and animals of the other planets, quote, "have indeed some difference in their shape, to distinguish the plants and animals of these countries from ours," end quote, the author concludes the planets must each have water of a kind adapted to its individual heat, and inter alia, that the plants and animals must have modes of propagation similar to those of Earth, and assuming, all this furniture and beauty the planets are stocked with, says, the planets seem to have been made in vain, without any design or end, unless there were some in them that might at the same time enjoy the fruits and adore the wise creator of them. And then he proceeds on this as a concluded basis to detail that in all things these supposed rational creatures must resemble man. One among the many curious conclusions he forms is that the inhabitants must be astronomers, and being astronomers must have all the implements and practice all the arts necessary to cultivating it, only singularly enough he dare not allow them telescopes, for fear people should be so disturbed at the ridiculous extravagancy of such an opinion as to take the measure of my other conjectures by it, and hiss them all off upon the account of this alone. Having thus to his own satisfaction, gained our point, and 'tis probable that they are as skilful astronomers as we can pretend to be, he deduces they must have hands, feet, upright carriage, senses, and faces like ourselves. In short, he, cannot without horror and impatience suffer any other figure for the habitation of a reasonable soul than our own. In other words, the inhabitants must be men, similar to ourselves, enjoying the pleasures of society, dwelling in houses, having ships, with sails, anchors, ropes, pulleys, and rudders, and perhaps they may not be without the use of the compass, too. Geometry they must have, being a science, of such singular worth and dignity, nay, would venture somewhat farther and tell us that they have our inventions of the tables of signs, logarithms, and algebra. And then he argues they must have music, physic, clothing, coaches, must dig metals out of the ground, and probably may manufacture gunpowder, be possessed of mills, engravings, paintings, and practice useful arts such as printing, glass, and clock-making. Nay, would have them making the same discoveries as ourselves, as, for example, of the circulation of the blood. Indeed, in nothing can these imagined inhabitants differ from ourselves, except possibly in shape of body, and even this difference Huygens seems to abandon, and sums up his first chapter in saying all this has been proved, but thoughtfully, considering the reader requires a breathing while, makes a pause. In the second chapter, or second part of the book, our author visits the several planets, and considers their position and the condition of their inhabitants, seems to discard the idea of the sun being inhabited, but peoples the moon, and affirms that whatever can be said of the moon may, with very little alteration, be supposed to belong to the attendants of the other planets, passes to the fixed stars, and concludes they are like our sun, attended by retinues of planets, and finishes by saying, what we allowed the planets upon the account of our enjoying it, we must likewise grant to all those planets that surround the prodigious number of suns. They must have their plants and animals, nay, and their rational ones too, and those as great admirers and as diligent observers of the heavens as ourselves, and must consequently enjoy whatsoever is subservient to and requisite for such knowledge. Such is the castle, I fear, of cards, which Huygens builds up. Truly, the inhabitants resting in it must be light, as phantasmagorial shadows painted by the magic glass. We had imagined people in dreamy thought, half-consciously conceiving such notions, but here they are, gravely realized and reduced to the pleasing assurance of print. Applying his own words in reference to suppositions of Descartes, we may well, wonder how an ingenious man could spend all that pains in making such fancies hang together, And yet we are told that the astronomer Flamsteed, a contemporary of Huygens, recommended the Cosmoterius to Dr. Plumer, Archdeacon of Rochester, who was so pleased with it that he left by his will £1,800 to found the Plumian Professorship of Astronomy and Experimental Philosophy at Cambridge. Lalande, from whom I have already quoted, expresses his views in favor of the plurality in a passage which I also quote, both for the sake of showing the grounds of the opinion he maintained, and as containing a mention of some of the eminent men who subsequently to Huygens had up to the time, 1802, he, Lalande wrote, discussed the subject. It will be seen, and perhaps in such discussions the precision of logical reasoning is not always perceptible, that Lalande proceeds to a certain extent on views of his own. Quote, "The resemblance between the Earth and the other planets," he says, "is so striking that if we allow the Earth to have been formed for habitation, we cannot deny that the planets were made for the same purpose. For if there is, in the nature of things, a connection between the Earth and the men who inhabit it, a similar connection must exist between the planets and beings who inhabit them. We see 6 planets around the Sun. The Earth is the 3rd. They all move in elliptical orbits. They all have a rotatory motion like the Earth, as well as spots, irregularities, mountains. Some of them have satellites. The Earth has 1 satellite. Jupiter is flattened like our world. In short, there is every possible resemblance between the planets and the Earth. Is it then rational to suppose the existence of living and thinking beings is confined to the Earth? From what is such a privilege derived but the grovelling minds of persons who can never rise above the objects of their immediate sensations? Lambert believed that even the comets were inhabited. Système du monde. Buffon determines the period when each planet became habitable, and when it will cease to be so from this refrigeration. Supplements in 4 volumes. What I have said of planets that turn round the Sun will naturally extend to all the planetary systems which environ the fixed stars, every star being an immovable and luminous body, having light in itself, may properly be compared with our own Sun. We must conclude that if our Sun serves to attract and lighten the planets which surround it, the fixed stars have the same use. It is thought that the Sun and fixed stars are uninhabitable because they are composed of fire. Yet M. Knight, in a work written to explain all the phenomena of nature by attraction and repulsion, endeavours to prove that the Sun and stars may be habitable worlds, and that the people in them may possibly suffer from extreme cold. M. Herschel likewise thinks the Sun is inhabited. Some timid, superstitious writers have reprobated this system as contrary to religion. They little knew how to promote the glory of their Creator. If the immensity of his works announce his power, can any idea be more calculated than this to exhibit their magnificence and sublimity? We see with the naked eye several thousands of stars. In every part of the firmament we discover with telescopes innumerable others. With more perfect telescopes we find still a multitude more. We compute from the number seen through Herschel's telescope in one region of the sky that there are 100 millions. Imagination pierces beyond the extent of vision, beholding multitudes of unknown worlds, infinitely more in number than those which are visible to our sight, and ranges unrestrained in the boundless space of creation. Our only difficulty with respect to the inhabitants of so many millions of planets is the obscurity of the final causes, which it is difficult to admit when we see into what errors the greatest philosophers have fallen. For instance, Fermat, Leibniz, Maupertuis, etc., in attempting to employ these final causes or metaphysical suppositions of imagined relation between effects that we see and the causes we assign to them, or the ends for which we believe them to exist. If the plurality of worlds be admitted without difficulty, if the planets are believed to be inhabited, it is because the Earth is considered merely as a habitation for man, from which it is inferred that were the planets uninhabited, they would be useless. But I will venture to assert that such a mode of reasoning is confined, unphilosophic, and at the same time presumptuous. What are we in comparison of the universe? Do we know the extent, the properties, the destination, and the connections of nature? Is our existence formed, as we are, of a few frail atoms, to be considered anything when we think of the greatness of the whole? Can we add to the perfection and grandeur of the universe? These ideas are expressed by Saussure, who, in speaking of a traveller to Mont Blanc, says, if during his meditations the thought of the insignificant beings that move on the face of the earth offers itself to his mind, if he compares their duration with the grand epochs of nature, how great will be his astonishment that man, occupying so small a space, existing so short a time, can ever imagine that his being is the only end for which the universe was created. From these considerations, D'Alembert, in the Encyclopedia, article World, after examining the arguments for supposing the planets inhabited, concludes by saying the subject is enveloped in total obscurity. But Buffon affirms that wherever there is a certain degree of heat, the motion produces organized beings. We need not inquire in what way, but imagine these to be the inhabitants of the planets. If that should be the case, we may conclude it highly probable that they are inhabited, notwithstanding the preceding objections." End quote. Sir William Herschel is referred to by Lalande. He had adduced in a paper on the nature and construction of the sun and fixed stars arguments in favor of the habitability of both sun and moon. But, says his biographer Holden, writing in 1881, quote, "they rest more on the metaphysical than on scientific basis, and are today justly forgotten." End quote. An observation which applies in truth to much which has been quoted from the authors already named. Laplace seems to have taken a view similar to that of Lalande, but in a less reverent, if not indeed in a sceptical spirit. Quote, "Seduced," he says, "by the illusions of sense and by self-conceit, we have considered ourselves as the center of these motions. We imagine, forsooth, that this is for us, that the stars influence our destinies. But the labors of ages have convinced us of our error, and we find ourselves in an insignificant planet, almost imperceptible in the immensity of space. Inhabitants of this peppercorn, we think ourselves the peculiar favorites of heaven, nay, the chief objects of care to a being, the maker of all," end quote, and so forth. It was to meet infidel views pointing in this direction that Dr. Chalmers in 1816 preached, and soon after published his famous astronomical discourses. Advancing in them reasons for the plurality of worlds, he goes beyond all the requirements of his argument to combat the presumption that Christianity was designed for the single benefit of this world. Whether Dr. Chalmers was warranted in suggesting a proposition which seems to pass the limits of all reasonable speculation, captivating the ear and the mind by the burning eloquence in which it was expressed, may well be questioned. But the arguments used for the actual plurality, although adding nothing to what had already been advanced, state the case perhaps better than they were ever stated previously, and on that account, were it on no other, fall to be given. They are contained in his first discourse, after referring to the magnitude of the heavenly bodies. He thus proceeds, quote, "Now, what is the fair and obvious presumption? The world in which we live is a round ball of a determined magnitude, and occupies its own place in the firmament. But when we explore the unlimited tracts of that space which is everywhere around us, we meet with other balls of equal or superior magnitude, and from which our earth would either be invisible or appear as small as any of those twinkling stars which are seen in the canopy of heaven. Why then suppose that this little spot, little at least in the immensity which surrounds it, should be the exclusive abode of life and of intelligence? What reason to think that those mightier globes which roll in other parts of creation, and which we have discovered to be worlds in magnitude, are not also worlds in use and dignity? Why should we think that the great architect of nature, supreme in wisdom, as he is in power, would call these stately mansions into existence and leave them unoccupied? When we cast our eye over the broad sea and look at the country on the other side, we see nothing but the blue land stretching obscurely over the distant horizon. We are too far away to perceive the richness of its scenery or to hear the sound of its population. Why not extend this principle to the still more distant parts of the universe? What, though, from this remote point of observation, we can see nothing but the naked roundness of yon planetary orbs? Are we, therefore, to say that there are so many vast and unpeopled solitudes? That desolation reigns in every part of the universe but ours? That the whole energy of the divine attributes is expended on one insignificant corner of these mighty works, and that to this earth alone belongs the bloom of vegetation, or the blessedness of life, or the dignity of rational and immortal existence? But this is not all. We have something more than the mere magnitude of the planets to allege in favor of the idea that they are inhabited. We know that this earth turns round upon itself, and we observe that all those celestial bodies which are accessible to such an observation have the same movement. We know that the earth performs a yearly revolution round the sun, and we can detect in all the planets which compose our system a revolution of the same kind and under the same circumstances. They have the same succession of day and night, They have the same agreeable vicissitudes of the seasons. To them light and darkness succeed each other, and the gaiety of summer is followed by the dreariness of winter. To each of them the heavens present as varied and magnificent a spectacle, and this earth, the encompassing of which would require the labor of years from one of its puny inhabitants, is but one of the lesser lights which sparkle in their firmament. To them, as well as to us, has God divided the light from the darkness, and he has called the light day, and the darkness he has called night. He has said, "Let there be light in the firmament of these heavens, to divide the day from the night, and let them be for signs, and for seasons, and for days, and for years, and let them be for lights in the firmament of heaven, to give light upon their earth." And it was so. And God has also made them great lights. To all of them he has given the sun to rule the day, and to many of them has he given moons to rule the night. To them he has made the stars also, and God has set them in the firmament of heaven to give light upon their earth, and to rule over the day and over the night, and to divide the light from the darkness. And God has seen that it was good. In all these greater arrangements of divine wisdom, we can see that God has done the same things for the accommodation of the planets that he has done for the earth which we inhabit. And shall we say that the resemblance stops here, because we are not in a situation to observe it? Shall we say that this scene of magnificence has been called into being merely for the amusement of a few astronomers? Shall we measure the counsels of heaven by the narrow impotence of the human faculties? Or conceive that silence and solitude reign throughout the mighty empire of nature, that the greater part of creation is an empty parade, and that not a worshipper of the divinity is to be found through the wide extent of yon vast and immeasurable regions? It lends a delightful confirmation to the argument when, from the growing perfection of our instruments, we can discover a new point of resemblance between our earth and the other bodies of the planetary system. It is now ascertained not merely that all of them have their day and night, and that all of them have their vicissitudes of seasons, and that some of them have their moons to rule their night and alleviate the darkness of it. We can see of one that its surface rises into inequalities, that it swells into mountains and stretches into valleys, of another that it is surrounded by an atmosphere which may support the respiration of animals, of a third that clouds are formed and suspended over it, which may minister to it all the bloom and luxuriance of vegetation, and of a fourth that a white color spreads over its northern regions as its winter advances, and that on the approach of summer this whiteness is dissipated, giving room to suppose that the element of water abounds in it, that it rises by evaporation into its atmosphere, that it freezes upon the application of cold, that it is precipitated in the form of snow, that it covers the ground with the fleecy mantle which melts away from the heat of a more vertical sun, and that other worlds bear a resemblance to our own in the same yearly round of beneficent and interesting changes. Who shall assign a limit to the discoveries of future ages? Who can prescribe to science her boundaries, or restrain the active and insatiable curiosity of man within the circle of his present acquirements? We may guess with plausibility what we cannot anticipate with confidence. The day may yet be coming when our instruments of observation shall be inconceivably more powerful. They may ascertain still more decisive points of resemblance. They may resolve the same question by the evidence of sense, which is now so abundantly convincing by the evidence of analogy. They may lay open to us the unquestionable vestiges of art and industry and intelligence. We may see summer throwing its green mantle over these mighty tracts, and we may see them left naked and colorless after the flush of vegetation has disappeared. In the progress of years or of centuries, we may trace the hand of cultivation spreading a new aspect over some portion of a planetary surface. Perhaps some large city, the metropolis of a mighty empire, may expand into a visible spot by the powers of some future telescope. Perhaps the glass of some observer in a distant age may enable him to construct the map of another world, and to lay down the surface of it in all its minute and topical varieties. Footnote. This anticipation in the case of the moon, and it may be said also in that of Mars, has been realized. End of footnote. But there is no end of conjecture, and to the men of other times we leave the full assurance of what we can assert with the highest probability, that yon planetary orbs are so many worlds, that they teem with life, and that the mighty being who presides in high authority over this scene of grandeur and astonishment has there planted the worshippers of his glory." End quote. I do not pause to examine the correctness of the learned divine's statements, which contain assumptions, or at least suppositions of fact, upon which instruments of observation more powerful have since borne their evidence or shed a light. I will not anticipate in which direction, but I may observe that underlying all this burst of noble eloquence is the idea that worlds can only be created for habitation. Farther on, he advocates the view that each of the stars may be, quote, "the token of a system as vast and as splendid as the one we inhabit. Worlds roll on these distant regions, and these worlds must be the mansions of life and of intelligence." End quote. It is not surprising that the great preacher should have been assailed for the positions he had thus taken, but, so far as I've seen, his assailants were foes unworthy of his steel, and he does not appear to have deigned to notice them. He was attacked principally upon the religious view of the question, the subject of the plurality itself being all but ignored, and scarcely discussed. One writer, Alexander Maxwell, in a book of 265 pages, an elaborate series of prosy letters, notes, and memoranda, philosophical and critical, occasioned by these discourses, setting out by disputing astronomical verities, and telling us how much he was indebted to the study of mathematics under one of the first mathematicians of the age, argued with a great want of dialectical pertinence, and with much semblance of learning to very little effect. Disputing as he does the doctrine of plurality, he advances nothing of any moment bearing on the question. After this, the subject seems to have slept for nearly 20 years. No one had ventured boldly into the arena to contend on adequate grounds for the non-plurality. End of section 8, read by Czandra, near Montreal, 2024. Section 9 of the Heavenly Bodies, Their Nature and Habitability. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Heavenly Bodies, Their Nature and Habitability by William Miller. Historical Résumé, Views of Philosophers, Part 2. In 1837, Dr. Thomas Dick, originally a minister of the Scotch Secession Church, who abandoned the clerical profession to teach, to lecture, and to write popular works, published his Celestial Scenery, descriptive mainly of the bodies composing the solar system, yet devoting a considerable portion to the enforcement of the doctrine of plurality of worlds. His books, which contain much information, can scarcely be called authoritative, but so far as I've observed, Celestial Scenery seems to have been, in point of time, the next work in which the subject is considered at any length. It enters upon the question in a novel manner, for its first office in the case of each body is to settle the number of its population, which is done by estimating the total extent of superficial area and taking as the standard of calculation the population of England, reckoned at 280 inhabitants for every square mile. Thus doing, the population of each planet and its satellites is calculated by the multiple of its square mileage. As if to make it as absurd as possible, no deduction is made for ocean, desert, or ice, and no allowance is granted for difference in size or description of the inhabitants presumed to exist upon each. The grand total, it readily may be imagined, is astonishing. The results are gathered together in a table interesting to the curious and persuasive to the credulous. Planet, Mercury, population 8,960,000,000. Venus, 53,500,000,000. Mars, 15,500,000,000. Vesta, 64,000,000. Juno, 1,786,000,000. Ceres, 2,319,962,400. Palles, 4,009,000,000. Jupiter, 6,900,000,000. 967,520,000,000. Saturn, 5,488,000,000,000. Outer ring of Saturn, inner ring of Saturn, and edges of the ring of Saturn, 8,141,963,826,080. Uranus, 1,077,568,800,000. The Moon, 4,200,000,000. Satellites of Jupiter, 26,673,000,000. Satellites of Saturn, 55,417,824,000. Satellites of Uranus, 47,500,992,000. Amount, 21,894,974,404,480. Dr. Dick cannot be blamed for the omission of the planets subsequently discovered. Neptune and his satellites, and the 150 additional planetoids besides the little moons of Mars, would with all their populations have considerably swollen the splendid total to which, without them, the enthusiastic doctor had thus, with ever-to-be-praised solicitude, attained. Elsewhere he reckons the population of the earth at a modest 800 million, and of the sun, which, though not positive on the subject, he evidently leans to holding inhabited, at 681,184,000,000,000, or equal to the inhabitants of 850,000 worlds such as our own. Indeed, it will be observed that with the single exception of the small planetoid Vesta, every one of the bodies is credited with a population greater, and in some cases many thousand times greater, than that of the earth. Even our moon receives more than 5 times the population of the planet upon which it humbly waits. The calculation is truly wonderful, but when he was so agreeably engaged, it is surprising he did not study arithmetical exactness to the extent of condescending to detail the hundreds and the units. And as there must in all cases be many in all of the planets who are under age, infants that travel half price, why, he did not both serenely estimate the units and secure that one at least should honorably ride off with an odd half. Dean Swift, with that feeling attention to the exigencies of resemblance for which he was distinguished, could scarcely have omitted the odd half, nor would Defoe. Starting with these magnificent visions of planetary population, he devotes a considerable portion of his book to the demonstration of the plurality of worlds. His arguments are these. 1. There are bodies in the planetary system of such magnitudes as to afford ample scope for myriads of inhabitants. It would be a very gloomy view of the Creator to imagine them barren and desolate. 2. There is a general similarity among the planetary bodies, tending to prove that they were all intended to subserve the same ultimate designs. They are all 1. Spherical, 2. Solid, 3. They all revolve round the sun, 4. And on their axis. They are all 5. Opaque bodies, deriving their luster from the sun, 6. Kept together by the law of gravity round the central luminary, obeying the same laws and subjected to the same influences, so that the reasonable conclusion is that the ultimate destination is the same, and that they are all replenished with inhabitants. 3. There are special arrangements indicating adaptation to the enjoyment of sensitive and intelligent beings, proving this to be the ultimate design of their creation, because they are 1. Diversified into hill and dale, 2. Environed with atmosphere, 3. Provided with means of distribution of light, heat, and color, 4. Provided with moons, 5. Adjusted by comparative density and rapidity of rotation to their respective sizes, to suit organized intelligences. On the assumption of the truth of the statements thus made, Dr. Dick argues that God has a design in view in all his arrangements, that whenever we find a contrivance exactly adapted to accomplish a given end, we may be sure that was the end to be accomplished. That we see in all the planets special contrivances calculated to promote the enjoyment of myriads of intelligent agents, and as God is possessed of infinite wisdom, to suppose them uninhabited would be unworthy of infinite wisdom, and quote, the thought would be impious, blasphemous, and absurd, end quote. A conclusion, I must observe, which may perhaps be reached very logically from the premises, provided always the premises be, as matter of fact, true. But are they so? We shall see. 4. The scenery of the heavens, as viewed from the surfaces of the larger planets and their satellites, forms a presumptive proof they are inhabited by intellectual beings, and the Reverend Doctor tells us how much grander the views obtained from these satellites are than any we poor inhabitants of earth enjoy, and concludes it is impossible to suppose that such magnificent views would be, unless there were rational beings capable of appreciating them. The proper corollary from which conclusion, I suppose, is that the inhabitants of our moon must be many degrees more intellectual than the men of earth, and still more should the favoured inhabitants of Jupiter's moons, whose views, we take it, are so transcendently more magnificent. 5. Every part of nature in this world, he says, has been destined to be the support of animated beings, and therefore it would be absurd to suppose the planets to be destitute of life. Matter was evidently formed for mind, and as God delights in conferring existence and happiness on every order of beings, it must be in accordance with our conceptions of the divine being to suppose that the planetary regions are peopled, and with beings beyond doubt possessed of rational and intellectual natures. Apart from the assertions in point of fact contained in Dr. Dick's statements, his argument, thus epitomized, is pervaded by the general assumption that the orbs must be created for habitation, which, if not implying assertion of the final cause, may be said to be the de quo quaeritur. In his Sidereal Heavens, published subsequently, after setting out in a separate chapter his view that the stars were constructed as centres of planetary systems, he enters very much on the same lines, upon a further argument for the plurality of worlds, drawn chiefly from his suppositions regarding the perfections of the infinite Creator. And he also attempts to prove his position by quotations from Scripture. One chapter is devoted to describing the inhabitants, very much on Huygens' plan of resembling them to men. It would not seem that either work produced any visible movement or evoked any fresh literature. If the slumber was broken, it was but a drowsy awakening to listen half-consciously to the Reverend Divine's cogitations, which only squared with preconceived views, for indeed the plurality was then tacitly assumed. But not long after there appeared a notable work, The Vestiges of the Natural History of Creation, wherein the unknown writer went a step farther and advanced the position that organic beings are produced or evolved in all the orbs by virtue of a general law of nature and out of an original fiat of the divine will, by which, quote, the whole train of animated beings are to be regarded as a series of advances of the principle of development, and so the author informs us, organic life presses in wherever there is room and encouragement for it, the former being always such as meet the circumstances. We have to suppose that any one of these numberless globes is either a theatre of organic being or on the way of becoming so. Inorganic matter must be presumed to be everywhere the same, with differences in the proportions of ingredients in different globes, and also some difference of conditions. He then assumes that, quote, where there is light there will be eyes, and these in other spheres will be the same in all respects as the eyes of tellurian animals, with only such differences as may be necessary to accord with minor peculiarities of condition and of situation. It is but a small stretch of the argument to suppose that one conspicuous organ of a large portion of our animal kingdom being thus universal, a parity in all the other organs, species for species, class for class, kingdom for kingdom, is highly likely, and that thus the inhabitants of all the other globes of space bear not only a general but a particular resemblance to those of our own. End quote. Taking such views, the inevitable conclusion to which this author was led was that organic beings have all, quote, come into existence by the operation of laws everywhere applicable. End quote. The literal meaning of the book was simply this, that God, having spoken once for all his will and put the wheels of nature in motion, forever afterwards restrained his hand. The author could not imagine the possibility of God exercising the creative power at each successive new form of life, and so, because the ways of him who letteth not a sparrow fall on the ground without his will were incomprehensible to the imperfect knowledge and finite powers of the feeble creature, the thought was to be regarded as taking a very mean view of him. It was, in short, ridiculous. One thing, however, is observable, that after endeavoring to trace the successive steps of change from one condition of being to the immediately higher, as if the fact of resemblance in the successions proved their descent the one from the other, or proved it to happen without the interposition of divine direction and divine power, he stops short of man at the quadrumana, and concludes by saying, quote, "Here such obscurity prevails that I must be content to leave the task to other inquirers." End quote. The author of the Vestiges was by no means the first to suggest the view of development, for he had been preceded by several writers who raised the question, but the boldness of his views and the dogmatic vigor of his style produced a sensation and an influence which probably had not been previously experienced, and he may be said, therefore, practically to have given birth to the doctrine of evolution now so popular among many naturalists, and with which we shall have afterwards more particularly to deal. The Vestiges was first published in 1844, to which was added a sequel of explanations in 1846, and it rapidly passed through 10 editions, in which there are numerous alterations and excisions, apparently indicating from time to time some slight modifications or some slight developments of its author's daring opinions. It experienced a wide criticism, and it is to be feared the answers made were not always on the correct lines. Hitherto, it will be seen, although all would not have endorsed the views of the Vestiges, the opinion of every one of those to whose writings I have adverted had been in favor of plurality. About 1853 or 1854, however, there appeared a book called The Plurality of Worlds, an essay, anonymously, though speedily, and as it proved rightly attributed to the Rev. Dr. William Whewell. Footnote. In the life and selections from the correspondence of William Whewell, Doctor of Divinity, by Mrs. Stair Douglas, 1881, there occurs this incidental acknowledgment of the authorship in a letter to Kate Marshall, dated 2nd January, 1854, page 433, quote, "There is a little, not mystery, for that I hate, but reserve to be used in talking of it as my book, for it is published without my name, and contains notions that may be startling to some persons, though I am persuaded that they tend to give us a true view of God's government of the world. I suppose, after all, you must have heard me talk of a book about the plurality of worlds which I was writing or finishing when you were here, and now the murder of the inhabitants of Jupiter is out." End quote. This life, which is nearly altogether made up of letters, is disappointing. There is no direct mention of the publication either of the essay or of the treatise, nor any mention of the reception of either by the public, notwithstanding the amount of discussion to which the essay especially gave rise. End of footnote. Master of Trinity College, Cambridge, and author of the Bridgewater Treatise, Astronomy and General Physics, considered with reference to natural theology. In the Bridgewater Treatise, while discoursing of the vastness of the universe, Dr. Whewell incidentally observed that, quote, "No one can resist the temptation to conjecture that these globes, the planets and the satellites, some of them much larger than our own, are not dead and barren, that they are, like ours, occupied with organization, life, and intelligence." End quote. But in the essay he entered the lists as a champion to combat that view, and so far as I have observed, he seems to have been the first who did so, or did so with any force of reason. Footnote. Such obiter dicta as those of John Wesley, quoted in Powell's Unity of Worlds, can hardly be considered in this collocation as offering an exception. Wesley's words, however, are remarkable. Quote, "Suppose there were millions of worlds, yet God may see in the abyss of his infinite wisdom reasons which do not appear to us, why he saw good to show his mercy to ours in preference to thousands or millions of other worlds. I speak this even upon the common supposition of the plurality of worlds, a very favorite notion with all those who deny the Christian revelation, and for this reason because it affords them a foundation for so plausible an objection to it. But the more I consider that supposition, the more I doubt of it, insomuch that if it were allowed by all the philosophers in Europe, still I could not allow it without stronger proof than any I have met with yet." End of footnote. For he discusses the whole subject fully and systematically, though not always so as to command concurrence, indeed also with all the overlading amplitude of a theologian. In the early chapters he sets out the difficulties which had originated the famous astronomical discourses of Dr. Chalmers, gives due weight to the doctor's argument, and discusses the subject. He then proceeds to point out from geology the antiquity of life upon the earth as compared with the recent creation of man, and considerations to which this fact gives rise. Thence he proceeds to the stars and planets, and argues from scientific facts against the conjecture of their being inhabited, and against even the probability of the fixed stars being, at least in every case, surrounded by planetary systems, because, among other reasons, of the large proportion of double stars. He argues from the advance of our planet to a peculiar condition and situation in a temperate zone, and the high nature and destiny of man to the earth being the special seat of God's peculiar care, and that man has been placed upon it as a preparatory stage to fit him for eternity, and that the universe is subordinate to man, while he combats the idea that the refusal to acknowledge inhabitants in other stellar bodies is adverse to the thought of the goodness, benevolence, or majesty of God. It was a thoughtful, able work, although many of the views it contains, such as the assumption that the universe was created for man, are unnecessary to the conclusion and are far from carrying conviction. It excited so much attention as within a year to run to a 4th edition. The essay stirred up discussion. Apart from the observations and comments of reviewers, he was attacked by 2 writers. One of them anonymously assailed him in a small book called The Plurality of Worlds, the positive argument from Scripture, with answers to some late objections from analogy. It was a dreary argument which may be put aside without remark. The other was from the pen of the Venerable Sir David Brewster, but the want of temper manifested in Sir David's book, called More Worlds Than One, the Creed of the Philosopher and the Hope of the Christian, disfigures it, and manifests an amount of bias which disqualified him from forming calm and sound conclusions. Viewing the essay as an elaborate attack, upon opinions consecrated by reason and revelation, having a direct tendency to ridicule and bring into contempt the grand discoveries in sidereal astronomy, he allows himself to reject the ignoble sentiments with indignation, and hints at the writer being either, a fool or a madman, writing only from a love of notoriety. On the other hand, the fantastic views of Fontenelle and Huygens receive unbounded regard, and indeed he follows to some extent in their wake, and arguing with the aid of additional scientific facts, or supposed or assumed facts, he easily takes his conclusions by adopting Huygens' method, even to the using of his very words, "it must be." The idea underlying the whole book is that all the orbs must have been made for some use, and that use must have been for the abode of rational beings, that all the stars are suns, each one of which is the center of a system of planets, and there being one planet at least in the solar system inhabited, there must be at least one in each of these assumed systems similarly inhabited. It is rather curious to find that Sir David's dogmatical assertions of astronomical fact are in some instances distinctly set aside by the later discoveries of the spectroscope and otherwise, as for example his assertion that all nebulae are resolvable into stars, that there are volcanoes in the moon, and an atmosphere surrounding it, together with his views regarding the planets and the eternity of the sun. In the overbearing spirit in which it was written, well-founded argument was not to be expected, and straining his view as he does, it may almost be said that in speculating on the plans of the Almighty, he is sometimes, to use his own words applied to the essayist, bordering on the blasphemous. While Fauvel laid himself open to attack, I cannot, however, say that Sir David Brewster was remarkably successful in his assault, even when, in common with some other writers, he is armed with words of Scripture, which he vainly wrests in support of his conclusions. A far more philosophical and valuable communication was made at the same time by Professor George Wilson in a small publication of 50 pages which he called The Chemistry of the Stars. Exception might be taken to the fanciful clothing in which some of his ideas were dressed, to his jury of chandler, stoker, sailor, and the like, and their professional remarks. But the idea which permeates the treatise is to point out the differences, actual and possible, between the earth and the other orbs of creation, and hence to reason against the plurality of worlds. The argument is exactly in the right direction, and so far as it goes, is supported by chemical facts and proofs of the most telling character. But the knowledge then possessed was more limited than it is now, and it is only much to be deplored that the talented popular chemist did not survive to carry his demonstration to a wider field, to do which no philosopher was more competent. His tract afforded, so far as I have seen, the most important support to the position taken by Whewell. On the other hand, Mr. Montague Lyon Phillips entered the lists to champion the side of plurality. His book, Worlds Beyond the Earth, is mainly occupied with the demonstration of the nebular hypothesis, but he has not been so successful in his attempt to prove the plurality. He is forced to admit that the sun, moon, and planets exist in conditions differing from those of the Earth. The chemical substances, the gases, the fluids, the atmospheres are different. And driven to admit that human beings could not exist on those other bodies, he only finds his way out of the difficulty by suggesting that these inhabitants must be differently constituted. How far this is an admissible position in the present question may afterwards appear. The Reverend Baden-Powell, in his Unity of Worlds, took up the parable, and with a show of impartiality, disclaiming controversialism, hitting both sides, he not the less turns the scale for the plurality to his own satisfaction, by quietly placing the weight of his foot in the balance. Referring to the discussions on the nebular hypothesis, he pointed out that there was no necessary connection between that hypothesis and the question of plurality, although he leans to it, and supposes a common origin for all the planets, and that all are suffused with the same material, a fact which Phillips did not admit. And discussing the views relative to the sun, moon, and planets, seems to arrive at the conclusion that they are of the same kind or character, but only differ in degree, and dismisses the geological difficulty of man's recent appearance by assuming a theory of progressive development or preparation, so that if a world is not at present inhabited, it is because it has not reached or has passed the condition of fitness for habitation. He also at great length discusses the arguments maintained on both sides from the theological point of view, maintains that it was a mistake to remove the subject from the region of inductive conjecture to that of supporting theological belief, and condemns the impropriety of attempting to solve a philosophical problem on any ground but physical analogy. In doing so, he hits both sides. Hits Sir David Brewster, who starts with the assumption that the worlds were made for the sole purpose of being inhabited, which was just begging the question, and an assumption of final causes not warranted by sound principles of reasoning. But then Whewell, in the essay, he thinks, was equally wrong in seeming to advance, for it is rather a gloss upon his argument, that the rest of creation must be supposed a waste in order to dignify man. The argument from assumed final causes was thus, he says, applied with equal force for opposite conclusions. It was likewise a mistake, which some had made, to deny the existence of inhabitants in other worlds, lest it should clash with our thoughts regarding man and revelation, and the sacrifice of the Son of God for man. All this was to disregard the proper province of theology. But though thus apparently reproving all, there is an undercurrent pervading the section, in indicating his favor for the subordination of man and the peopling of other worlds. The controversy thus raised by Whewell's essay brought some other writers into the field, but it seems to have died down and apparently was resuscitated in France in 1862 by the French astronomer Flammarion in the publication of his popular work La Pluralité des mondes habités, étude où l'on expose les conditions d'habitabilité des terres célestes discutées au point de vue de l'astronomie, de la physiologie et de la philosophie naturelle. Written, he tells us, for the purpose of demonstrating that the plurality of worlds is a doctrine, at once scientific, philosophical, and religious, of the highest importance. He followed it up in 1865 by another, Les mondes imaginaires et les mondes réels, voyage pittoresque dans le ciel et revue critique des théories humaines scientifiques et romanesques, anciennes et modernes, sur les habitants des astres. This work, which is for the most part occupied with a very detailed history of the theories, ancient and modern, regarding the inhabitants of the stars, is in this respect an enlargement of the previous book, and in the last chapter he states that the appearance of his former work was the signal for the revival of attention to the subject. It was rapidly disseminated throughout France and in Europe, and was translated into all the languages of the two continents, and was at the time he wrote in its 21st French edition. Footnote. My copies are dated 1876, and La Plurality is the 24th, the other the 14th edition. The two books run to nearly 1,000 pages, and I must confess to have done not more than glance at them. In both works, Flammarion has industriously gathered together apparently everything that has been written for or against the plurality, and whether purposely or merely cursorily, whether seriously or in jest. Probably, therefore, those desirous of making themselves fully acquainted with the whole literature of the subject may find the means of study in his pages. End of footnote. It had given birth to many books and the reproduction of others, and he catalogues over 30, principally French, published since 1862. Flammarion likewise devoted a chapter of Les Merveilles Célestes to the plurality of inhabited worlds, but it hardly appears to me that he added anything to the views which had been advanced by earlier writers, and indeed the little he does advance may be summed up in resting his view for plurality on the insignificance of this earth, the abundance of life upon it, and similarity of this planet to the others. Meantime, the English press had been almost silent. At length, in 1870, Mr. Proctor published Other Worlds Than Ours, the remark upon which by Flammarion is, aux yeux de tous ses lecteurs, l'auteur n'a évidemment qu'un tort, c'est de paraître ignorer que d'autres écrivains ont traité la même question avant lui, et de la même manière, et de ne citer que les auteurs anglais, comme si l'idée de la pluralité des mondes était née en Angleterre et n'avait été cultivée que dans cette île. End quote. Mr. Proctor, in this treatise, however, proceeds in an orderly manner to examine the conditions in which the various bodies are placed, and his views on each will best be referred to as each comes to be afterwards discussed. Mars, he believes, is the only planet unmistakably showing signs of life, and he by no means maintains life at present in any of the others. There are conditions in them inimical to life, as for example in Jupiter, which is still, quote, a glowing mass, fluid probably throughout, still bubbling and sending up continually enormous masses of cloud to be gathered into bands under the influence of the swift rotation of the giant planet. End quote. But Mr. Proctor takes the view that the worlds were created for life, and leans to the supposition that the beings which people other globes are adapted to the conditions of each, and that if not at the present time habitable, these globes may have been or may yet become so. He touches on the subject or deals with it in several others of his many works, and particularly in The Orbs Around Us, Flowers of the Sky, The Expanse of Heaven, and Our Place Among Infinities. Quote, a series of essays contrasting our little abode in space and time with the infinities around us. End quote. In the last mentioned book, he devotes a special chapter to considering a new theory of life in other worlds. Contrasting the views of Whewell and Brewster, he starts by observing that Whewell did good service in breaking the chains of old-fashioned ideas and inaugurating freedom of discussion, and while admitting that the balance of evidence was in favor of Whewell's theory, considers that Brewster's is the one which commends itself more favorably to the mind which would believe that God hath done all things well, and nothing that he hath made was made in vain. And having forced on us the belief that the support of life is the object for which the earth was created, we are thus, quote, led to regard the other orbs which, like her, circle round a central sun, as intended to be the abode of life, end quote. But there was a middle course, and pointing to the short duration of life, and especially rational life upon earth, as a mere ripple on the great ocean of time, leading to the thought that rational life was but a subordinate object of the earth's creation, that there is no ground to suppose that this particular epoch is the epoch for life everywhere, and that the probabilities are that it is only the epoch for a small proportion. The view he takes is that the planets of this and other systems are passing through stages, and the stage of life has only been reached or is occurring in a proportion of the planets. But this proportion over the whole universe will amount to millions. I have not observed that of late years any other English writer has ventured to take the matter up as a separate subject of discussion, although some have dealt with it along with other themes. Thus Dr. Phipson devotes a chapter of his Mysteries of Nature to inhabited planets, in the course of which he thus writes, quote, "To any person tolerably devoid of prejudice and slightly acquainted with the teachings of modern astronomy, it must appear absurd in the extreme to suppose that these magnificent worlds which revolve round the sun should not have been as highly endowed by the Creator as our little earth, a mere point in the universe, which constitutes so moderate a feature among them. And it may perhaps be quite as fanciful to imagine that our globe is for man the best possible of worlds. One or two prodigious difficulties arise, however, when we wish to bring forward some palpable proof of the planets being in reality inhabited by creatures at all like ourselves. Not the slightest doubt can exist as to the possibility of this, as far as certain planets are concerned, more especially Venus, Mars, and Mercury, reasoning from the little we know of their physical properties and their telescopic appearance, so similar to what our Earth must appear viewed from one of them." End quote. Dr. Phipson, however, has his doubts about the satellites, the sun, and the larger planets. How far his views are justified remains to be seen. Professor Newcomb, an American astronomer, devotes a few pages at the close of his work on astronomy to the subject. He says, quote, "When we contemplate the planets or worlds like our own, and the stars as suns, each perhaps with its retinue of attendant planets, the idea naturally suggests itself that other planets as well as this may be the abode of intelligent beings," end quote. And after alluding to the importance attached to the discovery of evidence of life in them, says, quote, "It is therefore extremely disappointing to learn that the attainment of any direct evidence of such life seems entirely hopeless, so hopeless indeed that it has almost ceased to occupy the attention of astronomers," and observes that it is quite possible that retinues of planets revolving in circular orbits may be rare exceptions rather than the rule among the stars. End quote. But granting planets, all the chances are decidedly against the idea that any considerable fraction of the heavenly bodies is fitted to be the abode of such animals as we have on earth, and that the number of those which have the requisites for supporting civilization is a very small fraction indeed of the whole. This conclusion, he says, rests on the assumption that the conditions of life are the same in other worlds as in our own, and this again on whether there be limits to adaptability on Earth, and then states that such limits do exist, and the higher the condition of life, the more restricted are the conditions, and if great changes are to occur on the surface of the globe, the higher forms of life would be destroyed. He is therefore led to the conclusion that, quote, "In view of the immense diversity of conditions which probably prevails in the universe, it would be only in a few favored spots we should expect to find any very interesting development of life." End quote. Professor Newcomb therefore adopts a view different from that of Dr. Phipson. But scientific men have been too much engaged within the last 20 years in making investigations with the spectroscope and other astronomical appliances, and thus getting at astronomical facts, to deal with what has always been regarded by astronomers as pure speculation. The discoveries made by means of spectrum analysis must necessarily have proved, and have truly proved, of greatest consequence, and they tend to lead to more certain conclusions on many points of the question involved. Mr. Proctor seems to think in one of the chapters of The Orbs Around Us that the discoveries by this analysis refute some of the arguments or positions of Mr. Whewell, but I have purposely reserved all discussion on the matters they involve to their proper place in the after pages. End of section 9, read by Czandra, near Montreal, 2024.
Section 10 of The Heavenly Bodies, Their Nature and Habitability by William Miller. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Randy Boyum. The Heavenly Bodies, Their Nature and Habitability by William Miller. Section 10. Such is a sketch of some of the leading stages in the history of the question and of the views of some of the leading writers. Those who believe in the plurality are not quite agreed regarding the nature of the inhabitants, but their general contention seems to be that these inhabitants are rational beings, and indeed it seems difficult to reconcile the theory of life in those other orbs unless upon the footing that the life is rational, that the occupants are intelligent and capable, like man, of apprehending the existence of the Creator. For to this the argument naturally leads. Some, like Huygens, have even contended for their resembling man in all respects. Others do not give their ideas this concrete form, and content themselves with simply affirming the habitability of all orbs, believing that the beings which constitute their population must vary in shape and kind in accordance with the constitution of the planets on which they severally dwell, and the varied circumstances in which they are respectively placed. While others again contend merely for the potentiality of the different orbs to receive life, and say that they, or many of them, may only yet be in a state of preparation for life, or that they have ceased to sustain it. But it will also be noticed that the arguments advanced in support of the plurality are various. They may be resolved into several propositions. 1. It is said that many passages in Scripture imply that the orbs are inhabited. In 1801, the Reverend Edward Nares, rector of Beddington, Kent, was at pains to write a whole book of 404 pages entitled Eis Beos Eis Mesiths, or an attempt to show how far the philosophical notion of a plurality of worlds is consistent or not so with the language of the Holy Scriptures, and it is only fair to say that, while it is a prolix, mild, and inconclusive work, it appears to be honest and, as far as possible, impartial, although one is much tempted to think the writing of it was labor wasted. In a very different spirit, Sir David Brewster devoted a chapter of his More Worlds Than One to the subject, and to this I would particularly refer. Without specifying the several passages in detail, I may notice a few. Thus he refers to the words of David flowing from an inspiration which no doubt revealed to him the magnitude, the distances, and the final causes of the glorious spheres which fixed his admiration, an assumption large enough indeed. When I consider the heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him, and the Son of Man that thou visitest him? Or those of Job, the heavens being spread out as a tent to dwell in, the chambers of the south, to other writers speaking of the host of heaven, a well-known synonym for the stars, to Isaiah, the Lord who created the heavens and the earth. He created it not in vain. He formed it to be inhabited, a passage which, literally taken, would imply that the earth only was formed to be inhabited. Or to the New Testament in the use of such words as worlds, the heavens, or all things. But if other similar passages of Scripture were taken literally, what shall we make of words such as these? The stars shall fall from heaven. The stars of heaven fell on the earth. Praise him, sun, and all ye stars of light. It is in vain to take such words literally, and to catch at a hidden meaning of this nature from the fervid utterances of the poet or the prophet, while it is manifest that the passages in question neither directly affirm that the stars are inhabited. And indeed it is a proposition now all but abandoned that the stars themselves are so, the contention being merely that their supposed but invisible planetary attendants are, nor can they, not one of them, sanction the deduction of such a meaning. The Bible was not given for the purpose of teaching us scientific facts, nor does it. It is only the extravagant fancy of a keen and inexact advocate which can torture undesigned expression to suit his argument in a way which will not brook the smallest investigation or criticism. It is a method of argument to be decried and dismissed. 2. It is maintained that the supposition of the orbs being inhabited redounds to the glory and manifests the wisdom of God, and the contrary supposition would be to lessen the glory and impeach the wisdom of God. But this is truly to affirm that it consists with the knowledge of those who so aver that the glory and wisdom of God can only be manifested in other orbs by peopling them, or to declare what it has not been given to man to know, wherein the glory and wisdom of God consist. It is, however, just another form of saying, 3. That the orbs were all made for the express purpose of being inhabited, and would be useless unless they were, which, besides being a begging of the question, is an assumption of the final cause, for which it cannot be pretended we have the smallest warrant. The idea in this assumption truly lies at the bottom of nearly all that has been said in support of the plurality. Looked fairly in the face, it cannot stand. For it must be acknowledged that we are all finite beings. We know very little, even of the earth on which we live, and we are apt to measure everything by our own narrow conceptions and limited experiences, and to imagine there can be nothing existing different from what we have seen or heard. But this we do know, that everywhere, so far as it comes within our observation, the great Creator has manifested his almighty power by a most wondrous diversity of gifts and operations. We find in endless multiplicity varied forms of matter, of animal, and of vegetable life in the different regions of the globe. There are no two countries or even two districts of a country alike. There are no two mountains, or valleys, or rivers, or trees alike. And passing from this earth, there is one glory of the sun, and another glory of the moon, and another glory of the stars. For one star differeth from another star in glory. Nay, even in things which are most alike is there special difference. No two men or women are alike, no two sheep are alike, for the shepherd can tell them all by name, and the ewe knows its own lamb among the largest flock. We should therefore be led rather to suppose that, while the all-wise and bountiful Creator has seen fit to bestow upon this world the gift and adornment and the glory of life as its peculiar heritage, he has, out of his immeasurable treasury, imparted to the other orbs each a separate blessing and special benefactions to which our experience does not reach, and of which our finite minds can form no conception. It may be so. We cannot tell. In this life, at least, it must, without a special revelation, be from us forever hid. Or it may be that he, in the plenitude of his sublimity, has created them without a use, and that he delights in them simply for their beauty and their perfection, and as a manifestation of his glory. It may be so. We cannot tell. But he has given to us the glowing opal and the lustrous diamond. And these may be to man in themselves useless, apart from their soft light or their brilliant radiance, and yet for this useless glitter they may to him have priceless value. And may not he who covers himself with light as with a garment, and stretches himself through varied scenes of grandeur inconceivable to infinity, like as a bride adorneth herself with her jewels, delight to crown his royal head with a universe of sparkling orbs? Or as we, finite beings, made in his image and given to share somewhat in his thoughts, can never tire of looking up to the star-studded sky and drinking unbounded pleasure from the mere contemplation of those far-off worlds, dwindled down in the distance in our puny sight to specks of light upon the firmament. Or as master spirits among men regard with complacent satisfaction the works which their own hands have designed or reared, so may he, with his all-seeing eye, to which nothing in all its grandeur or in all its loveliness is lost, behold with a majestic serenity to which we cannot soar, the stupendous fabric which his omnipotence has spread out like a curtain in all its circling wonders, where the great is perceived in all its magnitude, and the small is not obscured or hidden by the vast, created in all that amazing perfection which constitutes to our minds the matchless beauty of nature, and bend to it that approbation which, when looking on it at the first, we are told in the simple words of the inspired creation hymn, God saw that it was good. Can we not realize that these, his works, made in the fullness of that holy exaltation in which they were conceived, have throughout eternity brought to that glorious being the joy unspeakable which fills his presence and abides with him forevermore? For it is written, Thou hast created all things, and for thy pleasure they are and were created. But when the argument leads by a necessary sequence to speculations like these, we feel that we are passing beyond the region of legitimate reasoning, for we are moving into depths we cannot fathom. We can drop no anchor there. Arguments which rest on conjectures regarding final causes can lead to no result. The view, therefore, which has been propounded, must be disregarded as worthless. With this reason, there are several others which must also be cast aside as involved in it, or as just other ways of putting the same idea. Among them, the following may be placed. 4. That every part of the world is full of life. Therefore, it would be absurd to say that the other planets are destitute of life. 5. The finger of God and the wisdom of the divine government are more clearly manifested in the supposition of endowing the other orbs with life. Are we to deprive the other planets of plants and animals which, more plainly than inanimate matter, speak the divine architect? 6. That to give life alone to the earth, an insignificant body on the universe, is to subordinate all the others. 7. The earth having been made for habitation, the other orbs must be presumed to have been so too, although perhaps these other orbs, or some of them, have not yet reached the stage fitting them to receive life. 8. That life is the proper object for which these orbs were created, the use for which they were made. These propositions, after what has been said, require no comment or answer, for the reasons why the third proposition cannot be legitimately maintained apply to and cover them also. But it has been suggested, 9. That the peopling of this world solely is to suppose that the whole remaining creation was made for the gratification of man. Now, though it be evident that all things on this earth were subordinated to man created in the image of God, and that to him was given dominion over the fish of the sea, and over the fowl of the air, and over every living thing that moveth upon the earth, and that to him was also given every herb-bearing seed which is upon the face of all the earth, and every tree in which is the fruit of a tree yielding seed, to be for meat, that the earth has been adapted in many ways and adjusted in the system to which it belongs to support his life, it cannot be said that the remainder of creation has been made for him. If any opponent of the theory of plurality of worlds has advocated this idea, he has been clearly mistaken. The sun and moon and stars are in their respective ways useful to man, and that usefulness is doubtless the result of design. But to say that they were made for man would be to state a position which is unwarranted by revelation and, on the face of it, unjustifiable, were it for no other reason than this, that millions of the shining orbs are even beyond the sweep of telescope of strongest power. It was for God's pleasure, not man's pleasure, they are and were created. And to say otherwise is a mistake which does not flow out of the negation of plurality. Clearing, therefore, the atmosphere of these various positions or suggestions, the question is reduced in reality to narrow limits, and it is well before entering upon what are its real merits, we should postulate some positions which will aid us in arriving at a just determination. And, in the first place, it will not be to say that, as all things are possible with God, so God could give to each and every orb on the universe life, and life as it exists on the earth. To attain the conclusion for such plurality would require the establishment of another premise, which, as we have seen, cannot be predicated, that life is the proper object or utility of all such orbs, the design for which they were all created. The Gordian knot must not be so cut. In the second place, neither will it do to say that, even supposing the other orbs were in all respects and conditions similar to the earth, however much such a fact would prepare our minds to receive the information, that life must exist as a necessary sequence, and for this simple reason that life, whether of plants or animals, must be originated. Buffon no doubt says that wherever there is heat, there must be life, and the author of the Vestiges of Creation would have us believe that life presses in everywhere in pursuance of an original divine law. But these are mere assertions, they are not facts or admitted facts, and, as we shall afterwards see, the position is disproved by the investigations which have been made. On the other hand, in the third place, seeing that the whole doctrine of plurality is an argument of analogy derived from the fact of life upon the earth, so wherever we find a situation of matters which would be inimical to or destructive of life on earth, all presumption for life must there cease. For example, we find here that life cannot exist in fire or in ice, and hence we are entitled to conclude it cannot exist anywhere else in fire or in ice, in extreme heat or in extreme cold. In the fourth place, the demonstration that even one other world is uninhabitable destroys conclusion for all worlds being habitable, and the wider this demonstration, the more cogent will be that conclusion. These obvious propositions being stated lead directly to an inquiry into the condition of the surrounding orbs. And in approaching the subject systematically, we are not only naturally led to commence with the central luminary of our system, but by doing so it will be found largely to clear the way, and to tell most forcibly upon what remains, and thus upon the whole question. We shall combine in the next section the sun, the stars, and the supposed stellar systems. End of section 10. Read by Randy Boyum, Denver, Colorado. April 11th, 2025. Section 11 of The Heavenly Bodies, Their Nature and Habitability by William Miller. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Randy Boyum. The Heavenly Bodies, Their Nature and Habitability by William Miller. Section 11. 1. The Sun. Notwithstanding Fontenelle advocated the peopling of all the planets, he freely abandoned claim for the Sun. After Mercury, he says, on his fourth evening with the Marchioness, comes the Sun, but there is no possibility of peopling it, nor any room left for a wherefore. By the earth, which is inhabited, we judge that other bodies of the same nature may be likewise inhabited. But the sun is a body not like the earth or any of the planets. The sun is the source or fountain of light, which, though it is sent from one planet to another, and receives several alterations by the way, yet all originally proceeds from the sun. He draws from himself that precious substance which he emits from all sides, and which reflects when it meets with a solid body, and spreads from one planet to another those long and vast trains of light, which cross, strike through, and intermingle in 1,000 different fashions, and make, if I may say so, the richest tissues in the world. The sun, likewise, is placed in the center, from whence, with most convenience, he may equally distribute and animate by his heat. It is then a particular body, but what kind of body has often puzzled better heads than mine. It was thought formerly a body of pure fire, and that opinion passed current till the beginning of this age, when they perceived several spots on its surface. A little after they had discovered new planets, as we shall presently hear of, these, some said, were the spots. For those planets moving round the sun when they turned their dark half to us, must necessarily hide part of it. And had not the learned with these pretended planets made their court before to most of the princes in Europe, giving the name of this prince to one and of that prince to another planet, I believe they would have quarrelled who should be master of these spots, that they might have named them as they pleased. I cannot approve that notion. It was but the other day, says she, you were describing the moon, and called several places by the names of the most famous astronomers. I was pleased with the fancy, for since the princes have seized on the earth, it is fit the philosophers, who are as proud as the best of them, should reserve the heavens for themselves without any competitors. Oh, answered I, trouble not yourself. The philosophers make the best advantage of their territories, and if they part with the least star, it is upon very good terms. But the spots on the sun are fallen to nothing. It is now discovered that they are not planets, but clouds, streams, or dross, which rise upon the sun, sometimes in great quantity, sometimes in a less. Sometimes they are dark, sometimes clear, sometimes they continue a great while, and sometimes they disappear as long. It seems the sun is a liquid matter. Some think of melted gold, which seems to boil over continually, and by the force of its motion casts the scran or dross on its surface, where it is consumed, and others rise. Imagine then what strange bodies these are, when some of them are as big as the earth. What a vast quantity must there be of this melted gold, and what must be the extent of this great sea of light and fire, which they call the sun? Others say the sun appears through their telescopes full of mountains which vomit fire continually, and are joined together like millions of Etnas. Yet there are those who say these burning mountains are pure vision, caused by a fault in the optics. But what shall we credit if we must distrust our telescopes, to which we owe the knowledge of so many new objects? But let the sun be what it will, it cannot be at all proper for habitation. And what pity that is, for how pleasant would it be? You might then be at the center of the universe, where you would see all the planets turn regularly about you. But now we are only possessed with extravagant fancies, because we do not stand in the proper place. There is but one place in the world where the study or knowledge of the stars is easily obtained, and what pity it is there is nobody there. You forget yourself, sure, says she. Were you in the sun, you would see nothing, neither planets nor fixed stars. Does not the sun efface all? So that, could there be any inhabitants there, they might justly think themselves the only people in nature. I own my mistake, madam. I was thinking of the situation of the sun, and not of the effect of its light. I thank you for your correction, but must take the freedom to tell you that you are in error as well as myself. For were there inhabitants in the sun, they would not see it all. Either they could not bear the strength of its light, or, for want of a due distance, they could not receive it. So that, things well considered, all the people there must be stone blind, which is another reason why the sun cannot be inhabited. But let us pursue our voyage. While accepting Yontinel's conclusion, we cannot help, in the light of present knowledge, smiling at some of the ideas mentioned as then entertained regarding the sun, particularly the idea that it is composed of molten gold, the fact being that gold appears to be altogether wanting in the sun. The passage, however, may be taken as a favorable specimen of the style of discussion characterizing the book. Huygens took a different view. He said that the sun was hot and fiery, and that our bodies could not live in such a furnace, a fact beyond dispute, and that its inhabitants must be a new kind of animal, made with a noble end and purpose, a notion adopted by some modern writers who have thought that the heat difficulty was met by supposing the beings inhabiting the sun are differently constituted from man. But when Wilson, in 1774, announced the opinion that the spots on the sun were depressions on its surface, and that the black spot in the center is the nucleus or opaque body of the sun disclosed by this depression or void, a new theory was started that the supposed interior nucleus, surrounded by two strata of clouds, is inhabited, and that the inner stratum is a cool barrier interposed to protect the inhabitants from the heat and brilliancy of the other stratum or outer covering, constituting the region of light and heat. There was a difficulty, however, here because the cloud which protected from the fierce rays of the sun would exclude sight of the heavens. But this objection was conveniently overcome by according to the inhabitants the power of peeping through the holes formed by the continually changing spots. Sir William Herschel and M. Arago both lent the weight of their authority to this astounding idea. Sir David Brewster, discussing the subject in the 5th chapter of his More Worlds Than One, mentions the general grounds of these opinions and adds that the probability of the sun being inhabited is doubtless greatly increased by the simple consideration of its enormous size, admitting with Sir William Herschel that the sun may have a temperature adapted even for human constitutions. It is difficult to believe that a globe of such magnificence, 882,000 miles in diameter, upwards of 111 times the size of our Earth, and 1,384,472 times its bulk, should occupy so distinguished a place without intelligent beings to study and admire the grand arrangements which exist around them, and it would be still more difficult to believe, if it is inhabited, that a domain so extensive, so blessed with perpetual light, is not occupied by the highest order of intelligence. Powell strikes out the view that the solar heat is of peculiar nature and is conveyed, as it were, in the rays of light as a vehicle, and never becomes sensible as heat till the light is absorbed. It is therefore probable that these rays may owe their extrication from the sun to some other cause than elevation of temperature. In other words, this would mean that there is no such heat in the sun itself as to forbid existence in it. This was directly opposed to the opinion of Dr. Lardner, who said, "The sun is a vast globe invested with an ocean, or rather an atmosphere, of flame, in which the most astonishing convulsions and eruptions are continually manifested. Here is no moderated and regulated temperature, no alternations of light and darkness, no successions of seasons, no varieties of climate, no divisions of land and water. The sun is, in fact, a vast globular furnace, the heat evolved from each square foot of which is 7 times greater than the heat which issues from a square foot of the fiercest blast furnace. How utterly removed from all analogy with the earth such a globe of fire must be is apparent." With this opinion, Sir John Herschel apparently coincided in a work published by him in 1830. When alluding to the researches of De la Haye on the solar heat, he says, "This discovery is very important, as it establishes a community of nature between solar and terrestrial heat, while at the same time it leads us to regard the actual temperature of the sun as far exceeding that of any earthly flame." Dr. Dick, who disavows any decided opinion on one side or the other regarding the sun's habitability, but who is extremely unwilling to give it up, tells us, "For anything we know to the contrary or can demonstrate, the sun may be one of the most splendid and delightful regions of the universe, and scenes of magnificence and grandeur may be there displayed, far surpassing anything that is to be found in the planets which revolve around it, and its population may as far exceed in number that of other worlds, as the immense size of this globe exceeds that of all the other bodies in the system. But, on the other hand, we know too little of the nature and constitution of the sun and the plans of divine wisdom to warrant us in making any positive assertions on this point. But these speculations regarding the habitability of the sun were all given to the world during a period of ignorance of its true nature. The discoveries which have of very recent years been made, principally by aid of the spectroscope, have put us in possession of such an amount of acquaintance with the actual constitution of the sun as enables us at once to see that no room can be left to doubt that the conditions prevailing in it are utterly inimical to life. In the previous chapters on the nature and constitution of the sun, I have entered fully upon the results of recent investigations, and it is only necessary here to state briefly what these are, so far as bearing on the subject involved. They are the following. 1. The idea of the black spots disclosing an opaque interior body is altogether exploded. These spots, varying from day to day in size and shape and position, are simply temporary depressions of the photosphere or shining cover, produced by a downpour of metallic gases, and the black central spot is nothing more than the metallic mass at the bottom of the well, formed by such a downpour. 2. The sun is surrounded by layers of gases and metallic fumes or vapor to a height of at least 500,000 miles above its shining surface. These do not consist of gases capable of sustaining life. On the contrary, they are, to an enormous height, not merely partly metallic and partly hydrogen and partly gases unknown to us here, but they are incandescent or hot or burning flame. 3. The photosphere, or what might be termed the crust or shining cover of the sun, is itself gaseous, and is a mass of gigantic burning waves produced by motion of fiery currents rushing down or rushing up with a speed of thousands of miles in a second, causing continual displacement of its surface. 4. The surface is further subjected to the formation of gigantic spots or frightful chasms, causing most rapid separation and reunion of parts to an extent hardly conceivable. 5. It is also in such a state of disintegration that apparently the portion of covering at the equator moves round with a rapidity of course differing materially from the rate of revolution nearer the poles. 6. It is also swept by tornadoes of such violence as to be comparable to nothing on earth, 7,000 miles per minute having on occasions been estimated for this frightful force. 7. The sun shines in its own and not a borrowed light, and the power of light rays is enormous. 8. The heat of the photosphere of the sun has been estimated, at the lowest computation, to be many times that necessary to boil water, or even to melt iron. Putting aside as superfluous the consideration of the effect of the tremendous pressure which the power of gravity would have upon inhabitants of the sun at its surface, a point which has sometimes been made also regarding Jupiter and the other larger planets, it is therefore plainly impossible to hold that life can exist in the sun. Animals could not live. Plants, the food of animals, could not grow. Even supposing animals could possibly live in the heat, they would be continually, with tremendous vehemence, shot down or shot up through the photosphere, or blown about on its surface in one direction or another. It is evident to demonstration that life in the sun cannot be. The circumstances which have been stated would subject the thought to a reductio ad absurdum. Sir David Brewster found it difficult to believe that a globe of such dimensions could exist without being inhabited by intelligent beings. But from what has been stated, we see beyond doubt, according to all that regulates animal existence, life on that fiery body is impossible. And, with much better cause, we can use the words of Huygens and say, "We have gained a point. We not only depopulate the sun, but in doing so we depopulate a body which is at least 600 times larger than all the other bodies of the solar system put together. Not only so, but we thus deprive a star, for the sun is a true star, of life." The importance of this conclusion becomes manifest when we proceed to consider, in the next place, 2. The fixed stars. Before the discoveries made by means of the spectroscope, it was a fact admitted on all hands that the fixed stars must of necessity be self-luminous. From the immense distances at which they were situated, no reflected light could have reached us from them. Even the advocates of plurality were therefore constrained to admit that this circumstance was adverse to their habitability. Thus Powell stated, That the stars are self-luminous and therefore, it might be argued, probably consist of matter in a state of incandescence or combustion of some kind, is the strongest fact against their being inhabited. This, however, is no more than the same argument relative to the sun, and, like it, susceptible of the same answer from conjecture as to the existence of an exterior photosphere. In other words, some of the advocates of plurality believed that the fixed stars might be, as they imagined the sun is, composed of an opaque solid nucleus capable of life, surrounded by a shining envelope or photosphere. But they generally, if not universally, adopted another or further opinion to which I shall immediately advert. In the meantime, it is necessary, by a few words, to dispose of this view. Dr. Huggins, in his lecture on spectrum analysis in its application to the heavenly bodies, delivered in Manchester in November 1870, related the means taken by him and the late Dr. William Allen Miller to analyze the heavenly bodies by application of the spectroscope, aided by the telescope. He then showed the spectrum of the stars Aldebaran and Betelgeuse, pointed out what substances the spectra disclosed, and stated that we thus learnt that they were subjected to the same force as in the solar system, the force of heat, and that they emitted light in the same way as terrestrial substances emit light. They had examined some 50 of the stars, and they were found to differ from one another, but were all constructed upon the same type. All of them contained some terrestrial substances, but apparently in different proportions, and also, it might be, many other new elements entirely unknown to us. They subsequently, I believe, extended their investigations to a much larger number of stars. From another source, we learn that, while Huggins and Miller had thus been investigating about 100 of the brightest stars, Secchi, favored above his English fellow laborers by the purity of an Italian sky, had already extended his observations over more than 500 fixed stars, and gave the results to the world in 1867 in his entitled Catalogo del Stel di cui si determinate lo spettro luminoso era Osservatorio del Collegio Iamano. Since then, above 100 more stars have been added to this catalogue by this industrious astronomer, so that there exists at present a rich mass of spectrum observations of the fixed stars, which Secchi has so far provisionally arranged as to be able to group them into 4 principal types, into which all stars, with only a very few remarkable exceptions, may be classified. Those who have thus examined the stars seem to be agreed that they are in constitution similar to the sun. Like the sun, they possess an incandescent photosphere and are surrounded by a hot or incandescent vaporous atmosphere. But the substances of which their respective atmospheres are composed differ in each. In other words, while the stars all shine in consequence of their great heat and burning atmosphere, the vapor which manifests them springs from various substances, some of them known to us on Earth and some of them unknown. Dr. Schellen, whose work on spectrum analysis, 1872, is one of the most recent, and the translation of which has been edited by Dr. Huggins, says, "As the spectra of the stars bear, in general, a marked resemblance to the spectrum of the sun, being continuous and crossed by dark lines, there is every reason for applying Kirchhoff's theory also to the fixed stars, and for accepting the same explanation of these similar phenomena that we have already accepted for the sun. By the supposition that the vaporous incandescent photosphere of a star contains, or is surrounded by, heated vapors, which absorb the same rays of light which they would emit when self-luminous, we may discover from the dark lines in the stellar spectra the substances which are contained in the photosphere or atmosphere of each star." Then, after stating the results of investigation, he concludes thus: "From all these observations, it may be concluded that at least the brightest stars have a physical constitution similar to that of our sun. Their light radiates, like that of the sun, from matter in a state of intense incandescence, and passes in like manner through an atmosphere of absorptive vapors. Notwithstanding this general conformity of structure, there is yet a great difference in the constitution of individual stars. The grouping of the various elements is peculiar and characteristic for each star, and we must suppose that even these individual peculiarities are in necessary accordance with the special object of the star's existence and its adaptation to the animal life of the planetary worlds by which it is surrounded. The last observation has no necessary connection with the present branch of inquiry, and it assumes both the existence of planetary worlds and life upon them. Roscoe, in his lectures on spectrum analysis, even more clearly expresses himself thus: "We have then now arrived at a distinct understanding of the physical constitution of the fixed stars. They consist of a white-hot nucleus giving off a continuous spectrum, surrounded by an incandescent atmosphere in which exist the absorbent vapors of the particular metals. These results are interesting as bearing on Laplace's nebular theory because they show that the visible universe is mainly composed of the same elementary constituents, although certain of the stars differ from one another widely in their chemical constitution. Now we have seen that the sun exists in conditions which render life in it impossible. Of course, the accumulation of such conditions renders it all the more impossible. But it may be said each different condition is of itself sufficient to prevent even presumption of life. The stars may not be exactly alike to the sun in all these respects, but for the simple fact of the intense heat contained in them is sufficient to satisfy us of the impossibility of life, either animal or vegetable, the support of animal life, existing on any of them. Here then is a second point established. Every one of the stars which we see, and every one of the stars which the telescope brings to sight, is uninhabitable. This inevitable conclusion sweeps the firmament, saving the planets of our system, which fall to be separately and carefully considered in detail, and excepting the comets and the nebulae, both of which the spectroscope reveals are gaseous bodies. The nebulae, says Skirchley, are found to consist of incandescent gases, chiefly hydrogen, and some of the comets of a compound of carbon. Plainly, neither comets nor nebulae are habitable, and any fancy supposition that they, or at least the first mentioned, are, which formerly may have been held, has been now, I think, fairly abandoned. But afterwards we shall note a few facts regarding comets, which will show how entirely their condition is irreconcilable with the idea of their being the abodes of life. Yet the fact, now so indisputable, that the stars themselves are uninhabitable, only removes the question to another stage. Both before the application of the spectroscope to the stars and since, the view has been taken that every star is, like the sun, attended by a system of planets, so that the star exists for the sake of its planets, and these hypothetical planets exist for the sake of the life with which they are presumed to be endowed. The next point for consideration, therefore, is 3. The supposed stellar planetary systems. Ferguson, in his Astronomy, after showing that the stars are of the same nature with the sun, proceeds to say, "It is no ways probable that the Almighty, who always acts with infinite wisdom and does nothing in vain, should create so many glorious suns fit for so many important purposes, and place them at such distances from one another without proper objects near enough to be benefited by their influences. Whoever imagines they were created only to give a faint glimmering light to the inhabitants of this globe must have a very superficial knowledge of astronomy and a mean opinion of the divine wisdom, since by an infinitely less exertion of creating power the deity could have given our earth much more light by one single additional moon. Instead, then, of one sun and one world only in the universe, as the unskillful in astronomy imagine, that science discovers to us such an inconceivable number of suns, systems, and worlds dispersed through boundless space, that if our sun, with all the planets, moons, and comets belonging to it, were annihilated, they would be no more missed by an eye that could take in the whole creation than a grain of sand from the seashore." Sir David Brewster, a century later, expressed himself more dogmatically thus: "We are compelled to draw the conclusion that wherever there is a sun, a gigantic sphere, shining by its own light, and either fixed or movable in space, there must be a planetary system, and wherever there is a planetary system, there must be life and intelligence?" These are peremptory statements which are inadmissible. Besides assuming that the object of creating worlds is for life, they also assume what is erroneous, that a sun must necessarily be attended with planets. There is indeed a possibility, especially having regard to the claims of the nebular hypothesis, that at least many of the stars are surrounded by planets. But this is not to be taken for granted, for in the first place we have no knowledge that they in point of fact are so. Whether we shall ever be able to ascertain the fact by means of the inventions and discoveries of the future, we cannot tell, and the fact therefore in our present state of knowledge is not to be assumed. But this much may be said, that in all likelihood, as there are nebulae, sheets of nebular or star-forming material, which remain unconverted into stars and are nothing but huge tracts of hot gas, so there are many stars which have not reached the stage of throwing off planets, while perhaps there are many others which never will. According to the nebular hypothesis, which, as applicable to our system, seems to be placed beyond doubt, there was a time when our sun existed without a single planet circling round him. And in this condition, is it not possible that, for example, such a huge sun as Sirius may now be? It is a circumstance far from improbable. On the other hand, we know that there are great orbs in space which are dark, and therefore cannot be seen by us. And knowing, as we do, that our sun is gradually cooling, and will someday, however distant, become black, we may suppose that there are orbs no longer suns which are, if any are, attended by planets, and yet nothing can be more certain in the view of all the facts connected with the maintenance of life than that such planets are uninhabitable. Therefore, Sir David Brewster's imperative assertions are clearly wrong. End of section 11. Read by Randy Boyum, Denver, Colorado, April 21st, 2025. Section 12 of The Heavenly Bodies, Their Nature and Habitability by William Miller. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Randy Boyum. The Heavenly Bodies, Their Nature and Habitability by William Miller. Section 12. The Sun, Stars, and Supposed Stellar Systems, Part 2. But there is a further fact which has been much discussed as bearing on the impossibility that every star can be attended by planets. It is that of double or binary stars, stars which are connected by circling round each other or round a common center in regular orbits. Professor Nicol thus explains the phenomenon. "Have you ever," he says, "walked in a mood of tranquil thought along the side of a quiet river, whose waving banks reflect 1,000 currents, by the intermingling of which numerous dimples or whirlpools are produced, their easy glide only waking the river's stillness? Have you seen these dimples follow and pursue each other as if in gambol, or watched the phenomenon of the near approach of 2 or 3? Then have you witnessed the secret of the mystery of the double and triple stars. The subject of such stars, also found triple, quadruple, and multiple, is fully discussed by Sir John Herschel in his Outlines of Astronomy. But the point which is of main importance in this inquiry is the fact of the short periods in general of their common revolution. Sir John has given a table of the chief results of investigation in regard to binary stars, in one column of which the calculated duration of their revolutions is stated, and it appears that the majority are under 100 years, one being so low, according to Madler's estimate, as only 30 years. The highest reaches up to 736 years. It would seem, however, that other double stars have longer periods. Now, bearing in mind that Saturn revolves round the Sun in about 30 years, and Neptune in about 165 years, and if a planet outside Neptune be, as it is expected, discovered, its revolution will probably extend to about 320 years, it seems manifest that some, if not many, of these binary stars are nearer to each other than some of our planets are to the Sun, and none of them are removed from each other to distances many times greater than the most remote planet is from the Sun. And Sir John Herschel makes this important observation with reference to the planets supposed to revolve round these binary suns. 1. Unless closely nestled under the protecting wing of their immediate superior, the sweep of their other sun in its perihelion passage round their own might carry them off, or whirl them into orbits utterly incompatible with the conditions necessary for the existence of their inhabitants. Dr. Whewell, in his essay on Plurality, follows up this remark by observing, "A system of planets revolving around or among a pair of suns, which are at the same time revolving about one another, is so complex a scheme, so impossible to arrange in a stable manner, that the assumption of the existence of such schemes without a vestige of evidence can hardly require confutation." And then, referring to the sweep of one upon the supposed planets of the other, he says that the only safety would be in supposing them placed so close to one sun as to be out of reach of the other, and this might involve their plunging through a luminous vapor and being arrested, impeded, attracted, and lost in the central nucleus. Equally fatal, at least to inhabitants, would, I think, be the close proximity to such suns. Sir David Brewster's method of overcoming the objection is curious. He concludes from analogy that, if Madler's speculation is correct, our sun and the star Alcyone form a binary system, and therefore, since our sun is attended with planets, and one of these inhabited, we are entitled by analogy to conclude that all other binary systems have planets, at least round one of their suns, and that one of these planets is the seat of vegetable and animal life. Sir David, however, forgets that even were our sun a binary star, its revolution takes not 30, nor even 30,000 years, but 18 millions of years, and even the star nearest to us is immensely removed from the power of exercising attraction over the planets of the solar system, so that there can be no reasoning by analogy from our sun to any of the binary stars. But the matter does not rest here. For Sir John Herschel has, by taking the discovered parallax of the double star 61 Cygni, and calculating the distance between the two stars, been enabled to calculate the sum of the masses of the two stars, which on these data we find to be 0.353, the mass of our sun being 1. Thus, the mass of each of the two stars is somewhat about 1/6 of the mass of the sun, and I think it is only a reasonable conclusion that being diffused so largely as to appear a star to us at its great distance, the star is 6 times less dense. In other words, it is 6 times more vaporous than the sun, which has only the 1/4 of the density of the earth, and hence it is in a condition in which the sun is not at present, whatever it may have been when he first threw off the outermost planet. Thus it may be inferred that this double star has not yet reached, if it ever will reach, the condition of capacity for forming planets. Taking this view, the probabilities are that there are many in similar condition, and we thus arrive at a conclusion adverse to these stars having planets, not to say habitable planets, moving round them, and therefore were not made to sustain life by means of a surrounding planetary system. Now this is important not merely as respects these two individual stars making up a binary star, but as bearing upon the whole question of starry systems, if it be satisfactorily shown that some stars cannot presumably be supposed to be surrounded by planets, then a conclusion cannot be arrived at that all stars have a planetary system, and this assists to some extent, in the absence of every evidence to the contrary, to destroy the presumption for any star being so attended. But it will be said that if these stars are not now surrounded by planets, they will be. They are in a state of preparation. It may be so, we cannot tell. One very awkward preparation for the double stars would, however, seem to be that, in Professor Nichols' words, they must, on approximation, act upon each other as two wheels, so that a revolution of each around the other must immediately supervene and increase in rapidity until, by external pressure, they are forced into one, so that before they can begin to acquire the condition in which they may be enabled to throw off double planetary rings, they must come into a collision of which it would be terrible to think. Perhaps such a collision would be fatal to the formation of planets. But if otherwise, all that can be said is that at some future time they may become attended by planets. Meantime, they are not. And meantime, these stars, which are numerous, do not support life. In any view, then, what has been said goes to this, that at present some, or it may be many, stars are without planets, whether habitable or not. However, without making any positive affirmation on a point so far beyond our discovery, I have said sufficient to discredit the existence of stellar planetary systems, and for holding that in any view they cannot be universal, and that we can only deal with the subject hypothetically for the purposes and further progress of the argument. But now arises the question, assuming for the sake of argument that the stars, or many of the stars, are attended by planets, can these planets be presumed habitable? The only mode of answering or considering this question is by taking the analogy of the solar system and seeing how far, if at all, it will bear out the theory of plurality. The subject then, now for consideration, is, are the supposed stellar planets by analogy to be presumed life-bearers and inhabited by rational beings akin to man? Here we are met at the very threshold of inquiry by a very staggering fact. For the researches of the spectroscopists have revealed to us what might only previously have been matter of supposition, that the stars, while similar, or so far similar in constitution, and possessing many properties or substances in common, differ not only from each other, but from our own sun, in the gases of which they are respectively composed. This appears from the quotation I have already made from Schellen's spectrum analysis, and I would refer to the subject as treated by him, from which it will be seen that, in accordance with Father Secchi's arrangements, he groups the stars into four principal types, besides others of apparently rarer occurrence. And he proceeds to mention the colored stars, stars which are of all shades of red, green, blue, and violet, and are most conspicuous among the double stars, the number of which already exceeds 6,000, and with the phenomena of variable and new or temporary stars. Professor Roscoe has also dealt with the subject, and when referring to the investigations of Dr. Huggins and Dr. Miller into the spectra of Aldebaran and Betelgeuse, the star known as A in the constellation of Orion, makes these observations. In the first place, then, the result at which we have arrived is that the constitution of the starlight, although not identical with the light given off by the sun, is yet similar. That is to say, the light of a fixed star gives off a continuous spectrum, interspersed by dark shadows or bands, and hence the conclusion we come to is that the physical constitution of the fixed stars is similar to that of our sun, that their light also emanates from intensely white-hot matter, and passes through an atmosphere of absorbent vapors. In fact, that the stars are suns of different systems. We find, for instance, in these two particular stars to which I am now referring, the D line caused by sodium exists. The three lines which we know as B are produced by luminous vapors of magnesium. The lines of these substances exactly agree in position with the dark stellar lines, hence both sodium and magnesium are present in the atmosphere of these far distant stars. We also find in Aldebaran that two hydrogen lines, C and F, are present, but if you look at the spectrum of Orionis, we find that the hydrogen lines C and F are wanting. Hence we come to the conclusion that hydrogen is present in the atmosphere of the sun and in that of Aldebaran, but that it is wanting in that of Betelgeuse. And so we might show you that silver is not present in Aldebaran, nor seen in Orionis, but that four bright lines of calcium, also seen in the sun spectrum, are present in both stars. The lines observed in these two stars are at least 70 in number, and Mr. Huggins and Dr. Miller have found that in Aldebaran we have evidence of the presence of no less than 9 elements, namely 1. Hydrogen, giving the lines C and F. 2. The metal sodium, giving the double line D. 3. Magnesium, giving the lines B. 4. Calcium, giving 4 lines. 5. Iron, giving 4 lines and E. 6. Bismuth, giving 4 lines. Bismuth is not found in the Sun. 7. Tellurium, 4 lines. 8. Antimony is also found, 3 lines. And 9. Mercury, 4 lines. Thus, the element tellurium, whose name implies a purely earthly origin, is found in the star, although it does not exist in the Sun and is very rare in this Earth. There are only 2 stars, Betelgeuse, to which I have just referred, and another star called B Pegasi, in which the hydrogen lines are wanting. All the other stars contain hydrogen. We are thus shown that the stars differ from each other in the elements contained in them or in the gases into which they are by their heat thrown. While it is extremely likely that even where the elements are the same, the quantities of each element may vary very much, and this warrants certain deductions. For 1. It is not at all improbable that a very large number of the stars may not contain the ingredients or sufficient quantities of particular ingredients necessary to constitute a solid planet similar to the Earth. We have example in comets of planetary bodies in our solar system, which the spectroscope tells us are wholly or principally gaseous, are composed partly of matter, gaseous and self-luminous, and partly of minute particles held together by mutual attraction and gravitation, but so rare that stars are visible through the body and tail of the comet. Now, without going the length of supposing planets attached to other stars to be of a composition of such extreme tenuity as that of comets, the existence of comets shows, and the facts I shall have afterwards to state regarding certain of the members of our system confirm the thought, that it is quite possible that if stellar planets exist, there may be many of them possessed of little solidity. Perhaps none of them have sufficient density to be life-supporting, this being all the more probable in the case of stars which are themselves more gaseous, or rather possessed of less density than the Sun. 2. Supposing, on the other hand, that other stars contain elements which are calculated to give solidity to their planetary attendants, it may be that the solidity is of such a character as would be fatal to the thought of vegetation or life. We have example in meteoric stones, which are just minute planets, of bodies of hard metallic composition which are incapable of supporting vegetation. It is not improbable, therefore, that many others of the supposed stellar planets are equally hard, and are possessed of no aqueous vapor or water or other gas capable of pulverizing or of reducing them to a condition susceptible of promoting vegetable growth, and consequently they would be incapable of sustaining animal life. 3. The elements in others of the stars may be such as will not produce an atmosphere adapted for life. Here again the comets come to our aid, for Dr. Huggins' examination of a comet by the spectroscope elicited the spectrum of carbon, and carbon volatilized, it is presumed, is destructive to animal life. But we are not left to form an opinion from comets, for, as we shall afterwards see, we have an example in one at least, if not more, of the planets of our solar system of the presence of a deadly atmosphere. Meantime, it is important to bear in mind that as it is not every soil or substance in which plants will grow, so it is not every atmosphere which plants and animals can breathe. And it is the more necessary to say so, because it seems to have been taken by many for granted that if an atmosphere of any kind be found surrounding a planet, the planet must forthwith be supposed capable of maintaining life. The atmosphere which we find capable of maintaining life consists of oxygen, nitrogen, and carbonic acid in certain given proportions, varying in a slight degree in different situations, together with aqueous vapor and other ingredients to a minute and varying extent hardly to be reckoned and generally ignored. No animal can live in nitrogen, and although oxygen nourishes life, too much of it, or too long inhaling of it alone will, by the production of an excess of vital action, produce death. As Cooley says, in an atmosphere of pure oxygen gas, vital action would go on so fast as to terminate in an instant, destroyed by its excessive energy. An admixture of nitrogen is therefore needful to reduce the stimulus to a proper and healthful degree. In like manner, the minute proportion of carbonic acid must not be exceeded. A writer on colliery management says, "Let it be increased to 1/100th, and its effects begin to be felt in headache, languor, and general depression." In the case of a recent accident in England, one of the government inspectors stated that 2% of carbonic acid was most injurious and 4% would speedily kill. In like manner, it may be stated that nitric oxide gas is composed of 55.95 oxygen and 44.05 nitrogen, and animals are instantly suffocated on being immersed in it. Further, according to the experiments of Lavoisier and Seguin, a mixture containing 40 of azotic, 45 oxygen, and 15 carbonic acid destroyed animals confined in it. Such being the ingredients of life-supporting air, and such the delicacy of their proportional admixture that a deviation from it is fatal, it is easy to see that even where conditions in stars are, or may be supposed to be somewhat similar to those of the sun, and there has been produced on planets belonging to their systems an atmosphere, it by no means follows that such atmosphere is capable of supporting life, and very little variation would be effectual to destroy or would fail to sustain it. Now it is hardly possible to suppose two suns exactly alike, or two systems alike, or like our own, for there are many circumstances which will combine to produce distinctive variety of condition, and these distinctive varieties will necessarily affect the nature of the atmosphere, if any, which will be produced in the planets. Among them will mainly be the shade of difference in the composition of the individual stars, both of kind and amount, the differences of heat and light and power of the stellar rays, the distances of the several planets and their different compositions, and the various other influences to which they are subjected. In many cases there is also the difference of color of the stars, and even the combination of colors in binary systems, so that we can well suppose the chances for an atmosphere similar to our own are exceedingly slight. Probably, upon the theory of probabilities, the chance might be calculated. In many cases, too, the atmosphere may be wholly of a positively noxious gas, such as carbonic acid. We have thus seen, 1. That the sun cannot be inhabited. 2. That neither can the stars be. 3. That it is not to be assumed that the stars are surrounded by planetary systems, and that in the case of binary stars the probabilities are against it, and by displacing such systems from some stars a presumption arises against any. 4. Separately, that assuming the possibility of other planetary systems, many of the stars may not have reached the state of throwing off planets, while others may have reached the planet-bearing stage and passed to that stage when their light has burnt out, so that these planets cannot be life-supporting. 5. Supposing other planetary systems to exist, the revelations of the spectroscope are adverse to the idea of the planets of such systems being habitable, in respect, 1. That many stars may not be capable of producing solid planets. 2. That where capable of producing solid planets, the solidity may be of a character unfitted to support life, either vegetable or animal. 3. That the stars, or many of them, may be incapable of producing an atmosphere in their planets which is life-supporting, and this incapacity is to be presumed generally throughout them all, in respect of the difference of composition, situation, and other conditions subsisting between the stars and our sun. End of section 12. Read by Randy Boyum, Denver, Colorado, April 22, 2025.
Section 13 of the Heavenly Bodies, Their Nature and Habitability. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Heavenly Bodies, Their Nature and Habitability by William Miller. Life upon the Earth, Part 1. We are now brought more nearly to consider what is really the main question, as the habitability of the stars, or rather of their supposed planetary systems, is inferred, and only inferred, from analogy to the Earth and the members of the solar system. We have to ask primarily, what are the facts attendant upon life on the Earth? And then, what is the condition of each of the other planets? Do circumstances warrant conclusion for their being habitable? And from their presumable condition, what are we to infer regarding stellar planets? The Earth. And in order to consider this pretty wide subject satisfactorily, we must begin by first of all looking a little at the case or predicament of the Earth on which we dwell, which has been tenanted by rational beings for a limited period of time. For it is with the conception of rational life existing in other worlds we have truly to deal. Mr. Proctor has very justly observed, quote, "It would be difficult to show that mere life without the power which man possesses of appreciating the wonders of the universe is a more fitting final purpose in creation than the existence of lifeless but moving masses like the suns and their attendant planets, the insect or the fish, the bird or the mammal, the minutest microscopic animalcule, or the mightiest cetacean, may afford suggestive indications of what we describe as beneficent contrivance. Yet it is hard to see in what essential respect a universe of worlds beyond our own, inhabited only by such animals, would accord better with those ideas which the believers in the plurality of worlds entertain respecting the purpose of the Almighty, than a universe with none but vegetable life, or a universe with no life at all, yet replete with wonderful and wonderfully moving masses of matter. It is rational life alone to which the arguments of our Brewsters and Chalmers really relate." End quote. Now, the first observation which falls to be made in regard to the Earth is that man, the only rational being inhabiting it, has been its occupant for only a comparatively brief term. Admittedly, on all hands, he was the last being placed upon the Earth, but some have claimed for him a marvelous antiquity. 100,000, 300,000, 500,000, and even 9,000,000 years are among the periods which learned and sanguine men have assigned for the past duration of the human race, arriving at such startling enunciations only by means of conjecture based upon facts, or supposed facts, which in themselves afford no such data for computation. The antiquity theory seems to be especially favored by the evolutionists, who find it impossible to reconcile a recent date for the creation of man with the demands of Darwinism. Footnote, quote, "In the meanwhile, if any form of the doctrine of progressive development is correct, we must extend by long epochs the most liberal estimate that has yet been made of the antiquity of man." End quote. Huxley's Man's Place in Nature, page 159. End of footnote. The facts upon which those contending for antiquity have proceeded have mainly been the discovery of human implements, or what are thought to be so, or remains of a supposed age, in conjunction with the remains of animals believed by them to have become extinct at remote times, or underlying certain layers imagined to have taken enormous periods for their deposition or formation, or in other situations or circumstances regarded as indicating a vast antiquity. They will be found set forth in such books as Sir Charles Lyell's somewhat cautious work on the antiquity of man, Principal Dawson of McGill's University, Montreal, who has examined the subject at considerable length in his Origin of the World, 12th to 15th chapters, and satisfactorily disposes of these notions, thus summarizes the arguments from geology in favor of a great antiquity for man. Quote, 1. Human remains are found in caverns under very thick stalagmite crusts, and in deposits of earth which must have accumulated before these stalagmites began to form, and when the caverns were differently situated with reference to the local drainages. 2. Remains of man are found under peat bogs, which have grown so little in modern times that their antiquity on the whole must be very great. 3. Implements, presumably made by men, are found in river gravels so high above existing riverbeds that great physical changes must have occurred since they were accumulated. 4. One case is on record where a human bone is believed to have been found under a deposit of glacial age. 5. Human remains have been found under circumstances which indicate that very important changes of level have taken place since their accumulation. 6. Human remains have been found under circumstances which indicate great changes of climate as intervening between their date and that of the modern period. 7. Man is known to have existed, in Europe at least, at the same time with some quadrupeds formerly supposed to have been extinct before his introduction. 8. The implements, weapons, etc., found in the oldest of these repositories are different from those known to have been used in historic times. End of quote. The case of the antiquaries is shortly but more fully stated by one of themselves, Mr. Thomas Dunman, in a chapter of Talks About Science, published since his death. In this, his lecture on prehistoric man, he has adduced within small compass all the facts on which reliance is placed in support of great antiquity. Many of these facts, with the inferences built upon them, have from time to time been shown to be altogether unreliable. Principal Dawson, in the work above referred to, as well as in his Story of Earth and Man and his Fossil Men and Their Modern Representatives, has dealt with them. But it has been reserved for another American, Dr. James C. Southall, in works evidencing great research and erudition, systematically to demonstrate in a manner and with a force of reasoning which appears conclusive, that every one of the circumstances which have been relied upon is to be put aside. The first of these, a large volume of 600 closely printed pages called The Recent Origin of Man, published in 1875, is a very storehouse of learning and research, and to those who desire to study the subject fully it must afford the most ample information. But it was published in America and is rarely seen here. Footnote: I could only find it in one library in Edinburgh, the Antiquarian. End footnote. Probably the author had found it too bulky for popular reading, and in 1878 published in England another, The Epoch of the Mammoth, which apparently is to a great extent an epitome of the other, and is perhaps better adapted for those who do not wish to go profoundly into the subject. At all events, it affords sufficient material for such an incidental reference to it as only is needful here. It may therefore be referred to for the amount and weight of evidence brought forward in support of the triumphant stand this American gentleman has made against the doctrines which have been in some quarters so confidently maintained. I will only mention a few of his demonstrations. Thus he has shown that those animals supposed to have been extinct at immensely remote epochs have all lived down to a recent or historical period, that the stalagmite, supposed to take thousands or millions of years to produce a few feet, forms in favorable circumstances with rapidity. Footnote: It may be stated, but it is by no means necessary to the question, that the fossils of the older post-Pliocene must often, by the process of sorting by water, have been mixed with those of the river, a circumstance which doubtless may explain an occasional difficulty. From Dawson's Story, page 288. End of footnote. That the river gravel and the peat mosses, the lake dwellings and the kitchen middens are all comparatively recent, that there was no real separation into stone, bronze, and iron ages, and indeed stone sometimes succeeded ages of higher civilization, but that the use of all was intermingled or coeval, partly so, and there is no vast antiquity for the Stone Ages. Passing by the hoaxing to which antiquaries have on this question been subjected, as in the case of the bones of an African elephant, which for half a century were palmed off as the skeleton of a genuine Columbian mastodon, a deception only revealed at last by a deathbed confession, it may be mentioned that sometimes the discovery of supposed evidence of antiquity is pitilessly upset by the further discovery, at one time in juxtaposition at another, at a lower level, of a Roman coin. On one occasion, a supposed ancient carving was determined, upon better examination, to be the gunwale of a modern boat. Indeed, the antiquaries who glory over what they consider to be precious finds must sometimes share the mortification of Jonathan Oldbuck as he smarted under the matter-of-fact explanations of Edie Ochiltree. Mr. Pengelly's beaming delight over the relics of Kent's Hole as affording proof of a hoary human antiquity far past the conceptions of that ancient and incredible historian Moses must, one would suppose, have been considerably dashed by the awkward revelations and observations of Drs. Southall and Dawson. But the subject is a very wide one, and can only thus be incidentally referred to. One or two further circumstances show that man is not only of recent origin, but that he has not lived upon earth for more than about 6,000 to 7,000 years. 1. Although a fossil state does by no means imply antiquity, and the dripping well of Knaresborough, Yorkshire, affords a curious example of the extreme rapidity with which things may be fossilized, there is apparently no evidence of man being found in that condition. Baron Cuvier, writing in 1812, states as matter of fact, quote, "It is quite undeniable that no human remains have been hitherto discovered among the extraneous fossils," end quote. And I have not discovered that any human bones truly fossil or of great antiquity have been discovered since. What have been called the fossil skeletons of Florida, of Guadalupe, of New Orleans, of Mentone, are either not fossil, or can be shown to belong to merely an early period of man's history, sometimes only to a few centuries back. 2. Dr. Southall shows that man appeared on earth not earlier than the later post-Pliocene period, and by various converging facts and corresponding calculations made by different men, that the glacial period terminated just about 6,000 years ago. Footnote. Lieutenant Colonel Drayson, who has devoted special attention to the subject of the glacial epoch, does not seem greatly to differ. Quote, "The period spoken of in geology as the glacial period would have occurred between the dates about 6,000 BC and about 22,000 BC. At the date midway between these two periods would have been the height of the cold or glacial period. Hence, from about 12,700 BC down to the present time, we have the interval during which the alluvium and surface soil formations took place, a space of time which probably some geologists may consider too brief, unless they bear in mind that far more powerful causes were then at work than there are at present." End quote. The Last Glacial Epoch in Geology by Lieutenant Colonel Drayson, page 167. At another place, page 159, where he has placed the height of the last glacial epoch at 13,700 BC, he tells us there would be an epoch of 8,000 years subsequently, quote, "during which masses of frozen snow and ice would be annually floating over the Earth's surface," end quote, bringing down the termination of the glacial period to 5,700 years BC. In dealing with the antiquity of man, the writer says, quote, "We may bring the mammoth period nearer our own time than those hundreds of thousands of years which have been assumed by some writers as absolutely necessary." End quote. Mr. Prestwick has also, from geological investigations, come to a similar conclusion, as shown in the following extract, quote, "Whilst abstaining from any general hypothesis in explanation of the phenomena, there is, however, one point to which I must refer before concluding, although I cannot at present venture beyond a few generalities respecting it. It might be supposed that in assigning to man an appearance at such a period, it would of necessity imply his existence during long ages beyond all exact calculations, for which we have been apt to place even the latest of our geological changes at a remote and to us unknown distance. The reasons on which such a view has been held have been mainly the great lapse of time considered requisite for the dying out of so many species of great mammals, the circumstance that many of the smaller valleys have been excavated since they lived, the presumed non-existence of man himself, and the great extent of the later and more modern accumulations. But we have, in this part of Europe, no succession of strata to record a gradual dying out of species, but much on the contrary which points to an abrupt end, and evidence only of relation, not of actual time. While the recent valley deposit, although often indicating considerable age, shows rates of growth which, though variable, appear on the whole to have been comparatively rapid. The evidence, in fact, as it at present stands, does not seem to me to necessitate the carrying of man back in past time so much as bringing forward of extinct animals towards our own time. My own previous opinion, founded on an independent study of the superficial drift or Pleistocene deposits, having likewise been certainly in favor of the latter view. There are numerous phenomena which I can only consider as evidence of a sudden change and of a rapid and transitory action and modification of the surface at a comparatively recent geological period, a period which, if the foregoing facts are truly interpreted, would seem nevertheless to have been marked before its end by the presence of man, on a land clothed with a vegetation apparently very similar to that now flourishing in like latitudes, and whose waters were inhabited by testacea, also of forms now living, while on the surface of that land there lived mammalia, of which some species are yet the associates of man, although accompanied by others, many of them of gigantic size and of forms now extinct. Page 248. End of footnote. 3. Man must have left his Creator's hands perfect, as perfect for his place as the leaf upon the tree, as perfect as any even of the very earliest and humblest of the animate creation was for the lowly purpose for which it was designed. His knowledge from experience would necessarily be at first nil, and for a time scanty, but his bodily frame would be faultless and finely formed, sound, strong, robustly healthy, his mental faculties correspondingly complete, vigorous, clear, and penetrating, nay, doubtless, to compensate deficiency of knowledge, endowed and quickened with an instinctive sagacity to which we have now no approach. The notion that the first man was savage is a strange theory and receives no support from the appearance of the earliest skulls which have been discovered, which, although evidently belonging to men who were driven to seek their sustenance in parts remote from the first seat of life, and among ferocious wild beasts, are yet, at least some of them, of a superior type, superior to those of their successors. When man became savage, it could only have been the result of degeneracy, and that this was so is abundantly accounted for on the reasons assigned by the Duke of Argyll. Footnote: Primeval Man, Part 4. The fact stated by Guizot, Earth and Man, that the races of the southern continents are inferior to those of the north, tends to corroborate his Grace's views, while the civilization implied in the works of the mound builders of America, mentioned in Wilson's Prehistoric Man, Volume 1, Chapter 10, shows that a civilized race may be succeeded by a savage one. End of footnote. 4. Hence we should expect to find that the first men, or the early races, were long-lived and powerful, that they followed peaceful occupations, were cunning workmen, made great advances in arts and sciences, and with this expectation history and investigation accord. We are told of the patriarchal longevity. Footnote: Mr. Dawson, referring to the skeletons, whether fossil or otherwise, discovered of primitive men, speaks of the indication, quote, "They seem to present of an extreme longevity, of a slow maturity and great length of life," end quote, also of great strength and of brain power. See Fossil Men, pages 181, 189, 198, and 202. End of footnote. Of giant size, of the immediate cultivation of the land and the tending of sheep and cattle, the building of cities, of the invention of musical instruments, of artificers in metals, of astronomical skill, and besides the remains of art dug out of the Assyrian mounds, we have standing to this day in Egypt not only the ruins of ancient temples, but pyramids and obelisks and masterly sculpture and other evidences of the power and skill of the early workers outrivaling the efforts of modern times. None of these can claim to be as much as 6,000 years old, though verging on them. Footnote: Since the above was written, a book has been published by N. Joly, professor at the Science Faculty of Toulouse, called Man Before Metals, in which the great antiquity of the human race is advocated. Singularly enough, M. Joly appears to be unacquainted with the writings of the Americans, at least makes no allusion to their works. In a section titled The Great Antiquity of Man Proved by Egyptian Monuments, this author, after referring to a statement by Alfred Maury that on the banks of the Nile art and civilization date from a time anterior to all history, says, quote, "The development of this idea, which strongly supports our own theory, forms the subject of a learned paper by this well-known academician, with which the readers of the Revue des Deux Mondes are doubtless acquainted. In order to dissipate any legitimate doubt as to the great antiquity of the Egyptian people and of their civilization and their arts, it is not necessary to cross the sea, to go to Karnak, and to penetrate into its temple, 4 times as large as Notre Dame in Paris, although it was reserved exclusively for the devotions of the king. It was enough to visit the little temple of Philae in the Champ de Mars, where the rich treasures of the Egyptian exhibition, 1867, were displayed to the eyes of all nations. Their artistic beauty and richness, and above all the art displayed in the adorning of the sepulchres, were very remarkable. This is due to the fact that the inhabitants of the Nile, ever preoccupied with the idea of a future life, looked upon the tombs, quote, as their true abodes throughout eternity, end quote. Alfred Maury. Here were exposed coffins in the form of mummies, entirely covered with symbolic figures whose colors have resisted the ravages of time, and 2 statues, the one of diorite, the other of green basalt, representing King Chafra, or Chephren, the 4th king of the 4th dynasty, and the builder of the 2nd of the Great Pyramids. Statues so well preserved, one of them especially, that they appear to be fresh from the hands of the able sculptor by whom they were carved more than 5,000 years ago. Quote, "Art does not attain at once to that grace of line and truth of expression of which the face of Pharaoh, son of Ra, the sun god, Chafra, offers us an example. Side by side with these statues of King Chefra, or Chafra, we may place the wooden statue of one named Ra-Mk, remarkable for its wonderful state of preservation, and also for its beauty as a work of art, unsurpassed by any of the Greeks, as we are told by a competent judge, Monsieur Lenormand. This Ra-Mk was the governor of a province during the 5th dynasty, that is to say, about a century later than King Chafra. Lastly, the door of the Great Pyramid of Saqqara, now one of the most precious treasures of the Berlin Museum, formed part of a monument which, if it were really built, as it is generally believed, under the 1st dynasty, has withstood for nearly 68 centuries the destroying hand of man and of time. Such figures terrify the imagination. 49 centuries before the birth of Christ is a great age for a work of human hands, and above all for a true work of art. Neither India, Asia, nor Assyria have any relics of a time which approaches so nearly to the origin of humanity. But that which is really overwhelming to the mind is to find at that date not savage tribes, but a powerfully constituted society, of which the formation must have required the lapse of centuries, a civilized people advanced in science and art, and in the knowledge of mechanics, capable of raising monuments of immense size and of indestructible solidity." End quote. Then, after referring to certain Egyptian jewels of unequaled finish and beauty of the time of Joseph, and of other articles prior to that of Abraham, and averring that, quote, "there can be no doubt that Egyptian art, so perfect under the reign of Chephren and his successors, began by equally rude attempts, and that no one can tell with certainty the number of centuries they must have passed through before attaining to so complex a civilization," he concludes by saying, "The whole history of Egypt confirms our belief in the immense antiquity of the human race." End quote. Man Before Metals, by N. Joly, 1883, pages 30 to 34. There are several circumstances in this statement which invite observation. Monsieur Joly tells us that no other nation than the Egyptian have relics of a period so near the origin of humanity, and this period, although it terrifies his imagination, he does not put farther back than 6,800 years ago. It required, however, a few centuries to attain so great a civilization, and from this he jumps to the conclusion that the antiquity of the human race is immense. Whatever observation may be made on the logic of this argument, it would appear that Monsieur Joly conceives that the Egyptians could only have attained to such perfection in art after a lapse, perhaps he means a great lapse, of time. But there is no proper foundation for such a conclusion. If man was, as we believe, created perfect, it would need no great lapse of time, especially during the times of patriarchal longevity, to attain through experience to great skill in art. Perhaps the skill then attained very soon far exceeded all that is now possessed. Indeed, the wonder is that after the long course of degradation to which in successive generations man has been subjected, man should now possess so much capacity as he now enjoys. It exhibits a wonderful recuperative power in nature. As regards the antiquity of the Egyptian nation, there is one passage in Exodus which strongly tells against the supposition. It is contained in the 24th verse of the 9th chapter, in which the plague of hail is incidentally mentioned as so grievous, quote, as there was none like it in all the land of Egypt since it became a nation, end quote. This is one of those little bits of indirect evidence which are sometimes as convincing as more direct testimony. End of footnote. 5. If man had lived for 100,000 years upon the earth would, long before historic times, have been filled with inhabitants. An old writer presents a table of the increase which would naturally result from generation to generation, and at the end of 933 years the result would be 805,306,368 as the number of those then alive. Darwin places it higher, for he says that in less than 1,000 years there would literally not be standing room for man's progeny. Many causes, however, concur to keep down population. It would never grow and be sustained in the extraordinary numbers which may be arrived at by arithmetical calculation. Still, it is obvious that only a few thousand years would have sufficed to people the world adequately. We should expect, therefore, had the earth been peopled for 100,000 years, or even, say, 20,000 years, whether upon the progressive theory or not, to find not merely well-authenticated histories of the race during these early ages, but everywhere evidences both of the existence of man, and that in masses, with extensive traces of his intelligent labor, it might be buried and to be dug up, but still there. Yet not only does it appear that the population, even of the most favored lands, was scanty, but out of certain central districts all that can be discovered only evidences a few early inhabitants roving, it may have been at first either adventurously or in search of food, from their former homes, without the means and appliances of their forefathers, and perhaps rapidly falling into a savage degeneracy. But nowhere are traces of intelligent operations to be found, save in those parts of the world of which Assyria and Egypt may be said to be centers. 6. And it was somewhere in these quarters that man originated, as stated by Souther. Quote, the best opinion among ethnologists is that the migrations of the human race, supposing one original center, commenced from Central or Western Asia. End quote. Here, then, we ought, if anywhere, to find traces of this vast antiquity. But it is not so. Not a vestige of the existence of man or his implements beyond a period of 5,000 or 6,000 years can there be found. 7. Lastly, we come to the only historical or only reliable historical record we possess, a record confirmed by external evidence at every turn, the Bible. And here it is incumbent to observe that while it is true that the Bible was not given to teach us scientific truths, yet we cannot discard it as a witness to historical facts, even although it may be found to be itself the real defendant in the cause. It may present itself as a foreign witness, wearing a foreign garb and speaking a foreign tongue, and requiring, it may be, a skilled interpreter. The interpreter may indeed mistake the meaning of the witness, and we require therefore to receive what he says with caution, the more particularly if the witness be speaking, and that very briefly and meagerly, to what he does not specially appear to prove. But here we have, in Genesis, the oldest book in the world, written by one who had been taught everything that was known to the most learned of early ancient nations, written, too, within a period not very far remote from those patriarchal times when men lived long. Footnote. Before the flood, men are said to have lived 500, 700, 900 years, and as a physiologist I can assert positively that there is no fact reached by science to contradict or render this impossible. From Longevity by John Gardner, M.D., page 150. End footnote. and could transmit the knowledge of pristine times to a posterity through whose generations Moses could count his descendant by recorded names. And if the interpreter be not mistaken as to the witness's meaning, we have here clear evidence of an antiquity for man which does not extend back from present times to more than 6,000 or 7,000 years. But for the purposes of the present question, it really is not of vital import whether man has lived 6,000 or 60,000 or 600,000 years upon the earth. The longest period which antiquity hunters could possibly name brings us to a time when man did not exist upon earth, and in the history of our planet, which is by many reckoned by hundreds of millions of years, to say nothing of the history of creation, that period at the longest is comparatively short. Still, it is right to think of it, as it truly ought to be thought, as not extending to 10,000 years, and really to a much shorter era, for it adds point to observation. Now, if any intelligence had visited this earth, say 10,000 years ago, he would not have found a single rational being existing on it. At that time, therefore, the analogy of this earth would have led to the conclusion that no rational being existed on any of the other planets, that the worlds indeed were not made for rational life. But this 10,000 years is a mere point in eternity, and because what may be represented as a speck or point in eternity has on our planet been blessed with rational life, is it to be inferred that other planetary bodies have been endowed with such life? Nor does it affect the consideration that for a long period, it might be millions, perhaps many millions of years previously, organic life which was not rational, whether as mammal or bird or reptile or fish, had dwelt on the earth or inhabited its waters. The fact only throws us, with the difference of excluding rational life, back a very little. Eternity remains unaffected. The speck is hardly bigger, if at all. Travel back to the time when the first vegetable form appeared, and the same observation applies. Now, this undoubted fact goes, I think, a long way, after all that has been already advanced, so long a way, that I think I am almost fairly entitled to say that no presumption whatever arises from analogy to reason for life elsewhere because of present life upon the earth. Such a view is rendered the more reasonable when it is considered what life, and especially rational life, is. Let us only look realizingly at it, and we shall be filled with amazement. How wonderful is vegetation! The insignificant seed cast into the ground germinates, bursts, sends down its root and sends up its shoot, and by an operation which we cannot comprehend or even watch, slowly adds to both, till the root enlarges, and piercing the ground draws from it nourishment, and the shoot swells and rises little by little in gradual invisible progress, and grows and expands in stalks and trunk and leaves, beautifully veined, to draw nutrition from the air. And so by imperceptible extension, addition after addition issues from the daily increasing stem, till the little shoot becomes a great tree, and the birds of the air lodge in its branches, while round and round, embosomed among the foliage, the flower unfolds, and in graceful form and enlivening color adorns the waving boughs, and having served its day and brightened its generation, withering, gives place to fruit, pleasant to the sight and good for food, both for man and beast, and to seed to reproduce its kind. But proceeding to the higher kingdom, and passing by the inferior animal world, with all its interest and mysterious arrangements and adaptations, think of man, who offers to consideration the most wonderful object of thought manifested in creation. For he is wonderful in very many different ways, wonderful in capacity to move about at will, wonderful in the faculty of perceiving, through material fleshly organs, surrounding nature and its accompaniments, wonderful in that harmonious and complete combination of beautiful contrivances for the support and delight of existence exhibited in his bodily frame, wonderful in ability, in accordance with his own desire, to exercise power over the external world, bending the forces of nature to aid him in his operations, wonderful in the possession of the emotional sensations, in the impulse to love and to fear and to hate, to rear, to invent, and to destroy, wonderful in the endowment of thought, the capacity to comprehend and mentally combine, to remember, to imagine, to reason, to deduce, to convince, wonderful in the gift of speech, whereby to communicate the thoughts passing within his own inner consciousness to the inner consciousness of other similar living beings, and not suggesting other traits calculated in like manner upon reflection to excite astonishment, and leaving out of view what does not appeal so vividly to the outer observation, that most mysterious and most amazing characteristic of all, the carrying about within him of a spirit upon which its great Maker has breathed immortality and adapted it to dwell with him forever. How wonderful is the gift, that lofty faculty which raises him so far above every other terrestrial creature, to know and the power to revere the being from whom he derived his life and soul. When we think of all, how forcibly do the psalmist's words strike conviction to our hearts. We are fearfully and wonderfully made. End of section 13, read by Czandra, near Montreal, 2025. Section 14 of the Heavenly Bodies, Their Nature and Habitability. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Heavenly Bodies, Their Nature and Habitability by William Miller. Life upon the Earth, Part 2. Now mere matter is not so endowed. There is no love or hate, there's no moral consciousness or consciousness of any kind. There's no intelligence, no knowledge, no power of recognizing and worshipping God in a stone or any inorganic thing, nor in any inanimate organic thing. It is only when life is superadded that these qualities are found, and when life is withdrawn, they disappear. The corpse, the skeleton of the dead, is as unconscious as the stone. Nor can man, of himself with all his bestowed powers, and still less can the inferior animals, impart to matter one of the properties or virtues named. Were it not that life is so common, so familiar to our experience, we should, if we can suppose the possibility of our looking upon the earth with merely spiritual eyes, be astonished beyond measure at its feeblest manifestation. But because we are so habituated to it in its many forms, are so conscious of it within ourselves, we ought not to reckon it the less an exceeding great, a mysterious marvel. It is, in short, when rightly considered, in one sense of the term, a miracle. It is such a miracle on this earth. What reason have we to suppose the miracle's been repeated elsewhere? Literally none. Ex nihilo nihil fit. The stone, the senseless atom, cannot communicate what it does not possess. Matter cannot of itself produce what is grander than itself. It has no life and cannot give life. Life must be imparted to it, directly or indirectly, by Him who is life, the great and only being who is the fountain of life. Therefore, the mere existence of other bodies precisely similar to the earth, if the similarity can be established, affords no sufficient reason to suppose that the miracle of life has been repeated in them. Unless the Creator has so willed, this miracle has not been produced. The difficulty of the introduction of life upon the earth without miracle has been in various ways attempted to be met. Sir William Thomson some years ago suggested that life might be brought to this world on the tail of a comet, which was treated as a piece of Scotch humour, which it probably was, or in meteors, and it has been thought that some of the aerolites show traces of organic matter abiding in them, but examination, see Postea, has disproved the supposition, and besides, it is most evident that any life which by possibility could have existed in these aerolites, whether animal or vegetable, would most effectually be burnt out upon entering the earth's atmosphere. The idea at one time entertained that life can be initiated by spontaneous generation. Experiment has disproved. Footnote. The Edinburgh Review of April 1867, in an article on spontaneous generation, places at its head the following works. 1. Sur les corpuscules organisés qui existent dans l'atmosphère, examen de la doctrine des générations spontanées, par M. L. Pasteur, Annales de chimie et de physique. 2. Traité de la génération spontanée, Pouchet, Paris, 1859. 3. Rapport fait à l'Académie des sciences sur les expériences relatives à la génération spontanée, Annales de chimie et de physique, 1865. 4. Further experiments on the production of organisms in closed vessels by George Child, M.D., Royal Society, 1865. This article reviews the position of the investigation as at its date, and stating the difficulty of proving a negative leans to the conclusions of M. Pasteur. 3 years later, Dr. Bastian experimented and thought he had made out a case of spontaneous generation, but was promptly met by other experimenters, and it was shown that his results had been obtained by failure to take due precautions. The whole subject has been discussed at considerable length by Walter Noel Hartley, demonstrator of chemistry, etc., King's College, London, in his work Air and its Relations to Life, 1875. Mr. Hartley, who himself experimented with the utmost care in a very interesting series of chapters, gives the history and state of the subject, confutes Dr. Bastian, and shows that the life supposed to be spontaneous is derived from germs floating in the air, and with which the air everywhere, except in higher regions, appears to be charged. End of footnote. M. Pasteur has shown it to be untenable, and the experiments of others subsequently have apparently set the matter now at rest. As little can the theory of evolution stand the test, and explain the production of life upon the earth, and especially the life of the rational being man, without miraculous intervention. Evolution is a popular conception of the present day, just as in times past we have had notions of philosophers, which, acquiring popularity, have lasted a transient existence, and notwithstanding the overbearing confidence of some naturalists in whom the wish may be father to the thought, this new notion possibly will not endure any longer, for it is a mere unsupported hypothesis, and in any view it is incapable of explaining the presence or origination of life in this world. Let us, however, see upon what basis it rests, and what bearing the subject, and the thoughts to which it gives rise, have on the conclusions to be reached in the present question. Evolution is not exactly a new doctrine. Lamarck in 1801 broached the dogma of progressive development by acts of volition on the part of the animals themselves, a phase of the theory now given up, for the phases seem to be always shifting, and the descent of all species from other species. Similar views were stated by others, although the subject was not brought into public notice until 1844, when the author of the Vestiges of Creation first published that remarkable work containing the idea that an original impulse was given to the forms of life, aided by the influence of external circumstances which advanced them through grades of organization. But Mr. Darwin, 15 years later, in treating of the origin of species, practically made the subject his own, so that Darwinism and evolution, though not coincident, are commonly held to be convertible terms. His great theory to account for the diversity of species was that it was due to what he termed natural selection, in stating which, or the survival of the fittest, as his own, he appears to have met with claims of earlier origination on the part of Mr. Owen and Mr. Wallace. His conclusion was that all animals and plants are merely varieties of other and former forms, and by the operation of chance influences existing in nature through a long course of ages, one individual acting on another, have all been developed from one common ancestor. Mr. Darwin has indeed with great candor confessed to many of the weighty difficulties which beset his theory, at the same time endeavoring with labored ingenuity to combat them by bringing natural selection to his aid, so that the impression is given throughout of a petitio principii, or of reasoning in a circle. His opinions were assailed by many, and among others, very shortly after the issue of the book, by Dr. Bree, in a work now perhaps not so much known, called Species Not Transmutable, nor the Result of Secondary Causes, where many telling facts and circumstances are adduced to show that Darwin's positions are untenable, Dr. Bree's declared object being to show that Mr. Darwin's case is not proved, and that consequently it cannot supersede that theory of special creation of which we have the most convincing proof. An attack in some respects more formidable, inasmuch as it was more systematic, and that it emanated from a friend and believer in evolution, was afterwards made by Mr. St. George Mivart in his Genesis of Species. Mr. Mivart took up successively the different positions maintained by Mr. Darwin and showed conclusively their error. But after demolishing Mr. Darwin, Mr. Mivart failed in making out his own view, which is that species have, in sudden and considerable changes, been evolved by ordinary laws, for the most part unknown, aided by the subordinate action of natural selection, and in a loose way adding, "There is nothing in physical science which forbids them," his readers, "to regard these natural laws as acting with a divine concurrence, and in obedience to a creative fiat originally imposed on the primeval cosmos in the beginning by its creator, its upholder, and its lord." Or, as Mr. Mivart elsewhere expresses it, "Throughout the whole process of physical evolution, supernatural action is not to be looked for," so that the distinct issue raised by evolution, so far as the present question is concerned, seems to be, are the separate forms of life the result of miracle? That is, are they produced under the immediate act or direction of God? I do not pretend to have read the multifarious writings which have been published on evolution, and in dealing with it in this incidental way I have, availing myself in part of some of the observations made by other writers, taken my own method. Others have taken different methods. But one thing is noticeable, that evolutionists are very anxious that it should not be supposed that their doctrine militates against religion. Yet no one can intelligently read the works of evolutionists without observing how carefully many, if they do not openly seek to eliminate the action of the Creator, evade acknowledging it, and when anything is reluctantly said on the subject, the impression is conveyed that it is so said, as it were, to gain the suffrages of religious people, or not altogether to shock them. Principal Dawson thus expresses himself, Story of Earth and Man, page 317, "This evolutionist doctrine is itself one of the strangest phenomena of humanity. It existed, and most naturally, in the oldest philosophy and poetry, in connection with the crudest and most uncritical attempts of the human mind to grasp the system of nature. But that in our day a system destitute of any shadow of proof, and supported merely by vague analogies and figures of speech, and by the arbitrary and artificial coherence of its own parts, should be accepted as a philosophy, and should find able adherents to spring upon its thread of hypotheses, our vast and weighty stores of knowledge, is surpassingly strange. It seems to indicate that the accumulated facts of our age have gone altogether beyond its capacity for generalization, and, but for the vigor one sees everywhere, it might be taken as an indication that the human mind has fallen into a state of senility, and in its dotage mistakes for science the imaginations which were the dreams of its youth. In many respects these speculations are important and worthy of the attention of thinking men. They seek to revolutionize the religious beliefs of the world, and, if accepted, would destroy most of the existing theology and philosophy. They indicate tendencies among scientific thinkers which, though probably temporary, must, before they disappear, descend to lower strata and reproduce themselves in grosser forms and with most serious effects on the whole structure of society." On the other hand, Mr. George St. Clair, who seems to have given himself over, body and soul, to the evolutionists, and, if I have not mistaken his meaning, to contend for the vestigious doctrine of original fiat, out of which everything has sprung, has written a book, Darwinism and Design, or Creation by Evolution, 1873, bearing that his endeavor is to, "show that if evolution be true, all is not lost, but on the contrary something is gained. The design argument remains unshaken, and the wisdom and beneficence of God receive new illustration." But obviously it is a truism to say that if evolution be true, it has been the result of design. The antecedent question must first be answered: is it true? Is it satisfactorily proved? There is no escape from this position. If it were true, it would clearly form part of the Creator's plan. But to attribute to Almighty design seems no part of the Darwinian doctrine. Dr. Charles Hodge, in a work called Darwinism and its Relation to the Truths of Natural and Revealed Religion, enters at some length into the theology of the question, and may be consulted as stating the views of many writers, and thus expresses himself, page 173, "The conclusion of the whole matter is, that the denial of design in nature is virtually the denial of God. Mr. Darwin's theory does deny all design in nature, therefore his theory is virtually atheistical. His theory, not he himself. He believes in a creator." How far does this accord with his lately published letter? "But when that creator, millions and millions of ages ago, did something, called matter and a living germ, into existence, and then abandoned the universe to itself to be controlled by chance and necessity without any purpose on his part as to the result, or any intervention or guidance, then he is virtually consigned, so far as we're concerned, to non-existence. It has already been said that the most extreme of Mr. Darwin's admirers adopt and laud his theory for the special reason that it banishes God from the world, that it enables them to account for design without referring it to the purpose or agency of God. This is done expressly by Buchner, Haeckel, Vogt, and Strauss. The opponents of Darwinism direct their objections principally against this element of the doctrine. This, as was stated by the Rev. Dr. Peabody, was the main ground of the earnest opposition of Agassiz to the theory. America's great botanist, Dr. Asa Gray, avows himself to be an evolutionist, but he's not a Darwinian. Of that point we have the clearest possible proof." End footnote. Evidenced by their being accomplished either by the use of means in an extraordinary manner, or without apparent means by the exercise of divine will, the manner of the accomplishment being here immaterial. First, then, with regard to the Darwinian theory upon which these observations, among others, occur. 1. It is at once conceded that species are, under the divine concurrence, subject to variation, in some cases, to a pretty wide degree, and no doubt this is a susceptibility which has been implanted by the Creator not merely to manifest his own wonderful power and to gratify his own grand love of multiplied diversity, but for various good ends, and especially the better adaptation of animals to changed and surrounding circumstances, and above all, both the better to minister to the wants of man, to whom the whole inferior creation was subjected, and the more to stimulate his energies and quicken his intelligence. 2. But this susceptibility, which may be regarded as part of the divine mandate, be fruitful and multiply, has its limits. According to Mr. Darwin's doctrine, the lion and the lamb, the crocodile and the ape, the elephant and the animalcule, the spider and the whale, the sparrow and the shark, the centipede and the man, the owl and the ass, the goose and the gull, have all sprung from one common ancestor, all arriving at their respective forms by minute, gradual, successive changes. This is a community of origin which obviously cannot claim for itself the smallest shadow of probability. But what are the facts? 1. The different races of animals keep themselves apart. They herd together, they pair together. We see no disposition on the part of two different kinds of animals to form unions with each other. There may be, and when it does happen, it is only noticeable for its singularity, an affection springing up between two animals of different genera, but it is purely platonic. 2. Even animals which may be regarded as kin to each other seldom pair. It happens among domestic animals, or animals which are directly useful to man and have been brought under his mastery, and therefore conceivably created with this special power of adaptation, but it has only been observed while in a state of domesticity, and therefore under the control and guidance of man, and it would almost seem to be admitted by the evolutionists that among wild animals, or animals in a state of nature, it does not happen, or if it does happen, that it can only be in the rarest cases. 3. There is, it seems, as stated by Darwin himself, corroborated by Mivart, a tendency to revert in time after passing through the change of variation to the original typical form. 4. When pairing takes place between animals of different genera, the offspring is, as a rule, sterile. The conditions under which absolute sterility does not follow may be regarded as exceptions proving the rule. 5. There appears to be an increasing difficulty found in producing by ever such careful selection any further extreme in some change already carried very far, such as the tail of the fan-tailed pigeon or the crop of the pouter. 6. There are some animals, such as the goose, the peacock, and the guinea fowl, which are almost incapable of variation, and others which have remained unvaried since the time of their creation. In short, every circumstance goes to show what Mr. Mivart calls the stability of species, and even Mr. Darwin seems to admit that in the great divisions of the animal kingdom it is impossible that the one can become the other. Mammals and fish hardly come into competition with each other. The advancement of the whole class of mammals, or of certain members in their class to the highest grade, would not lead to their taking the place of fishes." In fact, it is not that the various branches of the animal kingdom have obeyed the original divine order. Let the earth bring forth the living creature after his kind, cattle and creeping thing and beast of the earth after his kind, and it was so." And so beautifully separated into kinds by distinguishing characteristics are they, that while naturalists have arranged the whole according to peculiarities into scientific systems, in which the animals are classified into distinct genera, which again are subdivided into various species, the partitions, in at least their greater divisions, are so marked as to be palpable to every eye, from that of our great progenitor who called each kind by its individual name as it passed before him, to that of the tiniest nursery child of the present day. 3. There are many facts in natural history adduced by naturalists which are irreconcilable with Mr. Darwin's theory, as for example the existence of the same freshwater fish in freshwater lakes in different regions of the earth, and the possession of perfect eyes and ears in animals living in the earliest times, organs which could never have been produced by insignificant beginnings. And of another kind, the fact mentioned by the Duke of Argyll in regard to the specific variation in the hummingbirds, "that every variety which is to take its place as a new species must be born, male and female, because it is one of the facts of specific variation in the hummingbirds, that although the male and female plumage is generally entirely different, yet the female of each species is as distinct from the female of every other as the male is from the male of every other, with which the further fact has to be coupled that there is no hybridism between any two species, however nearly allied." 4. The apparently rapid succession of races or species in geologic times is opposed to the Darwinian theory. Discussing the succession of life upon the globe and in dealing with evolution, Dr. Nicholson says, "On the other hand, there are facts which point clearly to the existence of some law other than that of evolution, and probably of a deeper and more far-reaching character. Upon no theory of evolution can we find a satisfactory explanation for the constant introduction throughout geological time of new forms of life, which do not appear to have been preceded by pre-existent allied types. The graptolites and trilobites have no known predecessors, and leave no known successors. The insects appear suddenly in the Devonian, and arachnids and myriapods in the Carboniferous, under well-differentiated and highly specialized types. The debranchiate cephalopods appear with equal apparent suddenness on the older Mesozoic deposits, and no known type of the Paleozoic period can be pointed to as a possible ancestor. The Hippuritidae of the Cretaceous burst into a varied life to all appearance almost immediately after their first introduction into existence. The wonderful dicotyledonous flora of the Upper Cretaceous period similarly surprises us without any prophetic annunciation from the older Jurassic. 5. Evolution from a mere sentient existence cannot explain the possession of passions such as love or hate, or moral feelings such as the sense of right and wrong, nor can it explain in man what is absent in the brute, the conception and reverence of God, and, without putting it higher, his hope of immortality. 6. Mr. Darwin admits as a serious difficulty started by Sir W. Thomson, probably one of the gravest yet advanced, that the lapse of time since our planet was consolidated is not sufficient for the amount of organic change to be produced, according to his theory, by minute succession and favorable variations, a difficulty in which Professor Huxley seems to participate. For according to estimates formed on the principles of inquiry followed by Sir W. Thomson, life on the earth must be limited within some such period of time as 100 million years, whereas according to computations founded on the Darwinian theory it would require 2,500 millions of years for the complete development of the whole animal kingdom to its present state, even were such development by natural selection possible. These are calculations which, supposing the theory well-founded, are necessarily speculative, and both of them might be largely either too great or too small. But the least reflection will show that upon the Darwinian supposition of the formation of animals of the most opposite kinds, say of the megatherium and the ammonite of the early world, or the elephant and the lark of the present time, or of the giant whale and the animalcule 1,000,000 to the bulk of a grain of sand, all from the Eozoan, or whatever was the first created animal form, and that, by minute successive changes accidentally happening and long in maturing, would, were it possible, require an inconceivable length of time. 7. It is found that existing animals have lived on Earth back to the glacial period without change. It seems that 98 species of mammalia inhabited Europe in the post-glacial period, of which 57 still exist, not one of which has been modified into a new form. Principal Dawson, in mentioning this fact, adds that he had examined about 200 species of mollusks and other marine animals, some of which lived back to the Tertiary period, and he had arrived at the conclusion that they are absolutely unchanged. 8. But a more tangible and formidable, nay, insuperable objection is to be found in the admitted fact that there is an entire absence of all proof, where proof ought to have been abundant, of the theory. It would indeed, if well-founded, have been a matter of everyday observation, yet we neither see such changes happening before our eyes, nor do we read of them in the history of the past, while there is not a trace of them, such as is requisite to be found in the geological records, where, had the race of animals now or formerly existing been produced by the development supposed, there must necessarily have been preserved to us specimens of animals in all the intermediate or transitional stages. Mr. Darwin admits that the number of these, quote, intermediate varieties which have formerly existed must be truly enormous, and that geology assuredly does not reveal any such finely graduated organic change, and this perhaps is the most serious and obvious objection which can be urged against the theory. The explanation, he adds, lies, as I believe, in the extreme imperfection of the geological record, end quote. But this is an explanation of a fact so strongly against him which cannot be taken. The simple answer to it is, to use Mr. Mivar's words, that the absence, not in one, but in all cases of such connecting links, is a phenomenon which remains to be accounted for. But is it not conclusively adverse to the theory? The more recent evolutionists, it is true, have taken courage from finding not indeed an enormous number of intermediate varieties, but a few isolated individuals, affording what they consider to be examples of the links of which they are in quest. Some of them, if they are to be assumed the results of evolution, would no doubt be cases of that development of which, as already stated, species are or may be susceptible. Others are thought to typify a class, exemplifying connection between different races or genera, and of these, the Archaeopteryx is paraded with triumph as furnishing probatio probata of the Darwinian theory. This singular animal, which united the feathers and certain limbs of the bird to the structure of the reptile, and has therefore been set up to constitute a link by evolution between the reptile and the bird, may doubtless be regarded as a product of a period of transition between two geological epochs, the epoch which was favorable to reptilia, and that newer epoch in which the atmosphere became suitable for the bird. And no doubt it was created in that particular form, as well for its own preservation, as for the purpose of enabling it the better to pursue its peculiar prey, and otherwise fulfill its place in creation. We may rest assured that such an animal was needed, and that the special form of this, to us seeming lusus naturae, was what was best adapted for the purpose for which it was introduced. But dealing with the matter as a scientific question, a far stronger reason, and one applicable to links of all kinds, is this, that even could it be established that they were related in time, it must also be established that they were the product of evolution. The mere fact of correspondence or similarity is obviously insufficient. The one must be proved to be the parent of the other, and this ought to be demonstrated by evidence, either direct or circumstantial, though sure and relevant. Now it may be admitted that in the circumstances neither is possible. The question therefore can only be determined, if at all, by reasoning from analogy. From the known and visible facts of the present we may reason back to the unknown and hidden secrets of the past. But so far from finding the known and visible to afford evidence in favor of the theory, we have already seen that all the facts are opposed to the hypothesis. Hence it finds as little support from analogy as from evidence. There exists, therefore, abundant reason for putting aside the Darwinian theory, and we may now turn to the other supposition propounded by Mivar, and which receives no countenance from the views of Darwin. Footnote. Quote, It may be doubted whether sudden and considerable deviations of structure, such as we occasionally see in our domestic productions, more especially with plants, are ever permanently propagated in a state of nature. Almost every part of every organic being is so beautifully related to its complex conditions of life that it seems as improbable that any part should have been suddenly produced perfect as that a complex machine should have been invented by man in a perfect state." End quote. Origin of Species, page 33. End of footnote. And see whether it be any better that the changes have been sudden and considerable, and have been evolved by natural laws for the most part unknown, aided by the subordinate action of natural selection. Mr. Mivart, like all evolutionists, proceeds on the footing that similarity of parts is evidence of affinity, and his position is that the production of this similarity, or what has been termed the homologies of the limbs, is the result of an internal force or tendency, without excluding the contributing action or effects of external conditions, but excluding all supernatural action of the Creator. On looking, however, for the proofs, it will be found that the whole rests on an assumption of the doctrine of affinity, because of resemblance of parts or members, or in other words, of evolution, which is nothing more than a complete begging of the question, and basing his remarks on this footing, that it is inconceivable that indefinite variation with survival of the fittest can ever have built up these serial, bilateral, and vertical homologies, "without the action of some innate power or tendency so to build up, possessed by the organism itself in each case." This is clearly a method of argument which is false, and true proofs of this theory there are none. Indeed, he himself is forced to rest on assertion, and to admit that the balancing which results in the given phenomena must be due to an internal cause, which at present science is utterly incompetent to explain. End of section 14, read by Sandra near Montreal in 2025. Section 15 of the Heavenly Bodies, Their Nature and Habitability. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Heavenly Bodies, Their Nature and Habitability by William Miller. Life upon the Earth, Part 3. Now we know that the Creator usually works by means or instrumentalities, and therefore it is not at all incredible that he should implant in his creatures a power which, acted upon by him, and intensified by him, and directed by his infinite knowledge for his own purposes, would result in a rapid change of form, or a change of form in descendants. But while this method may have been adopted by him in some cases, although there is nothing to show that it has been adopted, we cannot suppose it to have happened in any case unless he had directly so willed and ordained, and had given the impetus to produce in this way and in the specific forms. But this assuredly would have been a miracle in the sense of being that supernatural interposition of God in the affairs of this world, which every devout reader of his Bible is accustomed to contemplate and to believe without difficulty. But if a miracle be needed, it can be exerted by the Creator in any way he sees proper. His purpose may be effected by the exercise simply of his will. It may be brought about in a way we know not, by animating the dust, for, he can animate the dust as easily as make the dust itself, or as he did at the first, he can create out of nothing. People forget when they speak of a miracle that everything around us is not only marvelous, but incomprehensible. The rain that falls to the ground mounts by a wonderful process into the vine, and becomes the juice of the grape, which, subjected by man, employing the forces imparted to matter by the Creator, to certain processes, becomes wine. But attentively considered, this result is not in reality a whit less wonderful than our Saviour's exerting his almighty power, and at once and by the exercise of his will, without the means which the forces of nature had derived originally from his power, turning the water into wine. These forces of nature came from him. They were nowhere till he implanted them, and he who could originate and implant them, and was thus above them and could control them as he pleased, could surely accomplish the same end without their aid or instrumentality, by the exercise of the same power which brought these means and forces out of nothing and implanted them in matter. The action of man, the creature, who derives all his finite powers from the Creator, and who can only use the means which the Creator has provided, but who can even influence by a look, is admitted, and yet the action of God, whose power is infinite, is excluded from the world he has himself framed. Man can alter the face of nature, man can do many things in exercise of his will, but surely what can be done by man can be done, and much more abundantly, by the Almighty, and that by ways and means which to man are unknown. I have put it as if the creation of the animal world was accomplished by the mere exercise of will, for it is well to keep in view that the Creator can so act. Quote, that God is not limited to ordinary law in the production of results, that he can and that he does produce events without the ordinary instruments of nature is, says Henry Ward Beecher, the very spirit of the whole Bible. End quote. But it by no means follows that the creation was, at least in all its parts, accomplished without what we call means. It may have been that there are special laws of creation of which we know nothing, or special modes of operation, upon known forces which produce creation. But then, this special law, or these special forces, in the very nature of the case, will never be brought into operation until the divine being will and direct, and the evidence of such direction lies in the beautiful marks of design manifested everywhere in creation. Footnote. The evidences of design would fill volumes. Take, for example, the elephant's trunk. Cuvier found that in it the number of distinct muscles, each having its separate action, is not far short of 40,000. Or take the beautiful, the marvelous, and minutely exact adjustments everywhere manifested in the solar system. End of footnote. The adaptations we see everywhere around us, the exquisite contrivances, so well exemplified by the noble Duke in the wing of a bird, indicate in the plainest manner design and the hand of a designer. And they are not fashioned in an iron and rigid form, are not turned out of a common mold with that identity of construction which a machine, subject to no control, put in motion would produce, but are manifestly obedient to a guidance which shapes them to the immediate requirement, and when they obey external influences, these are influences which have only derived their power from the Creator himself. The evolutionists have found it necessary to their doctrine to carry it the length of including man. Now it might have been that the inferior creation was, at least to a large extent, derived from other of the subordinate forms, and yet it would not follow that man so specially made the subject of the divine decree, quote, "Let us make man in our image," end quote, was evolved from a brute. That man was descended from the brute creation is, however, so much a dogma of Darwin that in his Descent of Man we are favored with the exact description of the human ancestry. Quote, "The early progenitors of man were no doubt once covered with hair, both sexes having beards. Their ears were pointed and capable of movement, and their bodies were provided with the tail having the proper muscles. The foot was prehensile, and our progenitors were, no doubt, arboreal in their habits." End quote. And as, according to the evolution theory, who must have sprung from the lowest form of life, he tells us, quote, "At a still earlier period, the progenitors of man must have been aquatic in their habits." End quote. And as if the art of sinking could go no farther, quote, "These early predecessors of man must have been as lowly organized as the lancelet or amphioxus, or even still more lowly organized." End quote. It is to the monkey evolutionists proximately ascribe their descent. Footnote. So recently as at a meeting of the British Association held at Southampton in September 1882, this view was contended for by Mr. Stuart Duncan in a paper read to the Association. However, it is somewhat satisfactory to know from the newspaper report that, quote, some members tried to throw over the ape theory, although it is added, Mr. Duncan held that if it could be shown man walked on all fours and was otherwise very low in the scale, then practically man was an ape, end quote. End of footnote. But in so contending, there is one staggering fact which is ignored by most of them, perhaps is not known to many. Professor Owen, who considers the gorilla to be the most anthropoid ape known, and it will be borne in mind it is a habitant of equatorial Africa, far removed from the received birthplace of the human race, has collected the differences which distinguish the species of monkey from man, amounting in all to 44 separate peculiarities, leading him to the conclusion that man forms one species. Footnote. See also Dawson's Story of Earth and Man, page 363 and following. Principal Dawson shows not only distinctive differences between them and the lower animals, but that man was truly a new and isolated creation, a new type of life having been produced in him. I have not thought it necessary to advert to the discussion which has arisen as to the place man should hold in the zoological order. This seems to turn upon the structure of the brain and other anatomical considerations which, in the view I take, do not affect the question. See Lyell's Antiquity of Man, chapter 24. End of footnote. But the mass of differences would, according to the Darwinian theory, contrary to the simplicity characterizing the divine modes, have involved innumerable transitions and enormous time for its development from one to the other till they culminated in man. Yet not a trace of these transitional forms can be discovered. The author of the Vestiges gave it up. Quote, it might now be desirable, he said, to trace the connections of that order in the upward progress towards the highest of animated beings, but here such obscurity prevails that I must be content to leave the task to other inquirers. End quote. Darwin himself, in his work expressly treating of the descent of man, is forced to speak of, quote, the great break in the organic chain between man and his nearest allies, which cannot be bridged over by any extinct or living species, end quote. And all he can urge in favor is that many forms have become extinct, a position altogether inadmissible in the face of the present state of historical and geological knowledge. Footnote. Mr. Huxley, who was at least a conditional Darwinian, writes to much the same effect, quote, every bone of a gorilla bears marks by which it might be distinguished from the corresponding bone of a man, and in the present creation, at any rate, no intermediate limb bridges over the gap between Homo and troglodytes. End quote. Man's Place in Nature, page 104. M. Paul de Chailloux, whose remarkable adventures among the gorillas at the time he published his famous book were much canvassed, but who probably has become better acquainted with that animal than anyone before or since, discussing the physiological resemblances and differences between the gorilla and man at full length, observes, quote, though there is a great dissimilarity between the bony frame of man and that of the gorilla, there is also an awful likeness, which in the gorilla resembles an exaggerated caricature of a human being. While I resided among the tribes found on the mountains near the banks of the Ovenga River, where the gorilla is rather more common than anywhere else, I searched in vain if an intermediate race, or rather several intermediate races or links, between the natives and the gorillas could be found, and I must say here I made those inquiries conscientiously, with the sole view of bringing before science the facts which I might collect. But I have searched in vain. I found not a single being, young or old, who could show an intermediate link between man and the gorilla, which would certainly be found if man had come from the ape. I suppose from these facts we must come to the conclusion that man belongs to a distinct family from that of the ape, the first belonging to the order Bimana, and the latter to the other Quadrumanous series. End quote. Explorations and Adventures in Equatorial Africa by Paul B. du Chailloux, page 378, John Murray, 1865. End footnote. It might indeed be sufficient to remark, why do we not now at the present day observe apes becoming or giving birth to a human being or any intermediate form? But what has always appeared to me as lying at the root of the evolution fallacy is in imagining that resemblance of body or limb or embryo denotes affinity. This idea pervades the whole system and is present with every writer. Look, for example, at Huxley's book, Man's Place in Nature, with its grotesque skeleton procession, a book written to establish the resemblance of man to the monkey, and our descent from that animal because of such resemblance. Eliminate this element, and evolution is nowhere. Now, when we see several buildings all marked by the same general pattern, or having one pervading caste, in ascribing to them a common designer, we infer that it is his ideal, rightly or wrongly conceived, of the best or most perfect form for structure of the particular style or class to which it belongs, in building which he does not necessarily employ the same workmen or extract the material from the same quarry. And so, though infinitely more, when we find in nature a large number of forms of life of a similar kind, having structural resemblance in common, the true inference is that they all have proceeded from the hand of the one great designer, and that he, in the perfection of his wisdom, has chosen that general form which is the most completely adapted for the purpose in creation which each animal of the kind was designed to subserve, and which was best calculated to sustain or otherwise minister to its existence, so that it could not be said that any other would be as perfect, and therefore to have employed any other would not have been in accordance with divine wisdom. When one animal proceeds from another, it is because of the divine power which has been communicated, for without the divine power the forces used would have been as inefficient as dead matter. But the resemblance of any two species does not necessarily establish that the one proceeds from the other, and really evolutionists must think people extremely credulous or extremely illogical when they adduce their so-called links to verify their theory. All that resemblance certainly proves is not that the one proceeded from the other, but that the similar creatures have been originated by the one great being, and that being designs and fashions in that particular form which is the most perfectly adapted in the time and place for their subservient purpose. Applying this view to man, we find him formed and endowed according to the most perfect model, and if in any part or member its form resembles that of the inferior animals, it is simply because the form is that which the great architect and designer considered to be, and which unquestionably is found to be, best adapted for both man and beast, to attain the end which the particular part was intended to fulfill. And so clearly was the introduction of man the effect of design, that he and woman, differing in many ways from each other, but the one being the true complement of the other, the male and female of the human family, were approximately coeval in their creation, without which contemporary formation the race could not have been perpetuated, unless by continually renewed miracle. It was also, or must have been, the same with the male and female of every other creature. Mr. Wallace, notwithstanding he is a pronounced evolutionist and a strong advocate of natural selection, albeit his own statement of the striking adaptation of animals in form and color to enable them to elude their enemies is a strong argument against his theory of survival of the fittest, has found the facts for the separation of man to be so conclusive that, regarding specially the size of his brain, the absence of hairy covering on the back, the structure of the hands and feet, his mental faculties, and the possession of the moral sense, he is driven to the conclusion, apparently, that man cannot be the product of natural selection, and although he cannot shake himself free of the theory of development as the instrumentality, that a superior intelligence has guided the development of man in a definite direction and for a special purpose, just as man guides the development of many animal and vegetable forms. An admission which he unhappily mars by adding, I must confess that this theory has the disadvantage of requiring the intervention of some distinct intelligence to aid in the production. One would have thought that, so far from a disadvantage, it afforded the simplest method to solve a difficulty which can never otherwise be solved. But it implies supernatural intervention in the case of man, and the admission of miracle in the case of man, although he is the highest in rank of all, necessarily gives room for the intervention of miracle in other, or in all cases. Leaving, therefore, naturalists to do battle over details which they alone are competent to discuss. Footnote. For this reason I have taken no note of one of the latest works on the subject, Dr. Andrew Wilson's Chapters on Evolution, which is a book for the naturalist to discuss. I am afraid were I to attempt to enter upon it, I should make as awkward a mistake as he has himself done in venturing into the domains of law to explain a law term, which has not without advantage been imported into logic, or rather into argument, the taking an objection to the relevancy. This he expounds to mean, quote, showing that certain parts of the statement of facts made by the opposing side involve items which may be absolutely untrue or incorrect, and which therefore require to be expunged from the list of matters involving litigation, end quote. Now, on the contrary, an objection to relevancy assumes the truth of the averment, but denies that on this assumption it affects or warrants the conclusion, just as if we were admitting all Dr. Wilson's statements of fact to be true, but saying they do not infer demonstration of the proposition he maintains. It would be well, indeed, if in all cases the relevancy or adequacy of statements to infer conclusions were duly considered. End of footnote. And to account for a desire which some of them have to trace their origin to the ape and to still lower orders, rather than rise to the nobler thought coming to us from a higher source and a superior authority, that the genealogy of man stopped short at Adam, who was the Son of God, and dealing with the matter on the broad principles which can be applied to a doctrine which is only at best a hypothesis which must yield to facts, in place of our trying to bend the facts to it, there is in reality nothing to warrant our regarding the unsupported theory as affording any explanation of the production of life upon the earth by a process of development. On the contrary, examination of the subject shows that all life, and above all the existence of rational man, is due to the exercise of miraculous agency. Indeed, the cessation of new production is both an evidence of miracle in the past and a miracle in itself, were there any truth in evolution. After all, evolution does not explain the origin of life. As one of its advocates says, quote, the history of development but environs the puzzles connected with life and its nature. It leads us to the beginnings of life, it is true, but it leaves these beginnings unaccounted for and as mysterious as before. End quote. The author of the Vestiges perceived the length to which he must carry his theory if he maintained it at all, for the tracing back to one original form of life left the production of that form unexplained, and so he was driven to the doctrine of spontaneous generation, and in the sequel to his work he presented the inconclusive experiments of Mr. Weeks. But better investigation than that of Mr. Weeks, and more careful experiment, have entirely disproved the supposition, and it may clinch the argument to say that if all life and seeds of life on earth were to be now destroyed, say by the precipitation of a planet into the sun, or by our planet being brought into close proximity to the sun, so that every vestige of life should be burnt out, just as if, could it possibly have previously existed, it must have been burnt out in the primeval fires. Life would not return. A miracle would be needed to replenish and repeople the earth. We thus start with this most important consideration, that life on earth does not necessarily or spontaneously spring up. It is produced in all its manifestations, no matter how, for the manner of origination is immaterial, by the will and miraculous intervention of the Creator. But we do not stop short here, for we find that the earth has been peculiarly fitted for life, so that a reason existed for its receiving life. Placed at a medium distance from the great source of light and heat in the planetary system, the light and heat are of that exact degree which favor existence. They neither scorch nor chill. Vegetation adapted to support animal life receives the exact measure which conduces to its growth. It possesses an atmosphere composed of the needful elements, in the precise combination which is calculated to maintain life, both animal and vegetable. It is supplied with water of a quality exactly suited to nourish and maintain life. Its surface is so planned and laid out in mountain, valley, river, and sea as to promote in the best manner these operations, by cloud and frost and wind and everything else without which earth would be uninhabitable. It has been so adjusted in distance from the sun and moon, in the extent and form of its oceans, and in the bounds set by the shore, that the tides do not rise to inundate the land, and the proud wave carrying salubrity in its swell is shut up within doors and told, "Hitherto shall thou come, and no farther." Furthermore, the earth was not left as a mere locality for life. All nature was put in operation to prepare it specially for man. After the great nebular gaseous globe of which it at first consisted had in the course of incalculable ages cooled down and contracted to its present dimensions, and the hot enveloping mist had broken up and cleared away, and changed into an aqueous covering, and the volcanic forces within had upheaved the great mountains, millions of years of preparation were needed to bring it, by successive operations and succeeding races of animal and vegetable life, exactly suited to their time and place, into fitness for man. And from the minutest organism, from the earliest known form of animated existence, from the Eozoon, discovered far down in the geologic depths, which multiplied and extended till it filled whole seas, and produced enormous tracts of rocks of chalk, to the gigantic monsters, the unwieldy megatheria, the huge mastodons and mammoths, which were fitted to grapple with the luxuriant tropical forests, equally gigantic, all were set to work to make earth a suitable and pleasant habitation for man. And having made it so, the monsters were caused to disappear, and evidencing the grand preparation planned, there were in their stead, along with man, or shortly before introduced, several mammalian species not known in the Pliocene period, and some of which, as the sheep, the goat, the ox, and the dog, have ever since been his companions and humble allies." And thus it is we find coal formed and stored in the far back ages for man to burn in the present age. But no other animal uses fire or digs for coal, and stone is found fashioned and in deposits slowly laid at the bottom of the ocean in remote epochs, and then elevated within man's reach by volcanic force, to afford to man the materials with which to build and embellish. But no other animal builds or embellishes with stone. And the rare and valued jewel is found sometimes in the depths of earth and sometimes washed up by the sea. But no other animal knows or appreciates its charms, searches for it, cuts and polishes and sets in costly gold, or adorns its person with the sparkling brilliant, the finished gem. And metals are in due measure found streaking the earth in veins and lodes, and have been given to man to aid his industry, augment his powers and resources, and to increase his knowledge. But no other animal sinks a shaft, raises the ore, eliminates the metal, forms it into shape, or uses a tool. And animal life has been given that he may use it in a way that he alone can use it. The furry skin, the soft wool, the silken cocoon, the tough hide, for clothing and other purposes, the horse, the ass, the camel to ride or to draw, or to bear his burdens, while the vegetable world is also largely laid under contribution to meet the wants of man alone. Flax and cotton grow that man may, by the aid of invented machinery, manufacture dress, but no other animal invents machinery or spins or weaves or requires or uses clothing. Wheat, corn, and the other cereals, which, if not coeval with man, were apparently at least the result of man's cultivation, and would disappear if man ceased to cherish them, are the staple support of the human race, and sometimes also of the domesticated animals dependent on man. But no other animal sows or tends or reaps. Other vegetable as well as mineral substances afford medicines for disease, but no other animal can detect the cause of disorder, can extract the drug, prescribe the remedy, or effect the cure. Others present the pigment wherewith man can paint a scene or decorate a dwelling, but no other animal uses a brush or comprehends its power, or is gratified by its product. Nay, the very landscape in all its beauty, the sky in all its splendor, the flower in all its loveliness have no charms for the inferior creature. To their unconsciousness they are as a sealed book. For man alone, of all the creatures on earth, were this beauty and splendor and loveliness provided, that, made in the Creator's image, he might share the Creator's joy when he beheld what he had made and pronounced it to be good. But indeed it would be impossible to show that everything on earth is contrived to contribute directly or indirectly to the benefit of man, that even the noxious animals and the poisonous plants and minerals have ends in this way to subserve. And if this be so, and who can doubt it, do we not find here that life on earth has one special end, that of ministering to the rational being, man, who, unless the earth had been so prepared for him, could not have existed upon it, or have existed upon it as a rational being? So that, in other words, the earth was not only specially adapted, but specially made for man, again proving the miraculous intervention of the Supreme Being. And if so, what reason can there be for presuming life on other globes? Presumption for it thus disappears and leaves little further to be said. Yet the matter by no means rests here, or is altogether dependent on these views, for we must now proceed to examine the whole solar system, the only planetary system of which we with certainty know, or which can at present be brought, if any other exist, within our ken, and see whether what we can learn regarding the condition of the other planetary bodies warrants the assumption of resemblance to the earth, or gives any countenance to the idea that they can be inhabited. If it do not, then a still stronger argument arises against life in other systems. For if even the displacement of a single planet from being a life-bearing body be a fatal blow to the plurality thought, how much more conclusive will the fact be if there be found reason sufficient to displace them all. End of section 15. Read by Czandra, near Montreal, 2025. Section 16 of the Heavenly Bodies, Their Nature and Habitability. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Heavenly Bodies, Their Nature and Habitability by William Miller. The Moon. And naturally we begin with the Moon, for it is similarly distant from the Sun, and being the body nearest by far to us, we have greater facilities for its examination than we possess in regard to any other of the members of the solar system. And it is well also to keep in view its close affinity, for upon the principle of the formation of the planetary bodies, according to the nebular hypothesis, the Moon must have been formed either out of a ring separated from the Earth, the most probable supposition, or from the same zone out of which the Earth was formed. Consequently, and especially if regarded as the offspring of the earth, there ought to be a close resemblance or family likeness between the two bodies, a parity of condition far beyond what might be expected to be found subsisting between the earth and any other planet of our system. Sir William Herschel lent the authority of his name to the supposition that the moon is inhabited. In a passage quoted by Sir David Brewster, who clung to his skirts in this matter, Sir William said, "I believe the analogies that have been mentioned sufficient to establish the high probability of the moon's being inhabited like the earth." And Sir David sets himself assiduously to assign reasons, of which the main one was rested on imagined discovery of volcanoes in the moon, as doubtless inferring the presence of a supporting atmosphere, though fire and smoke are not very friendly to life, for a similar opinion, but winds up by asserting that, quote, "independent of these considerations, we maintain that every planet and satellite in the solar system must have an atmosphere," end quote. The matter, however, is not one to be decided on authority, but upon fact and deduction from fact, upon observation and scientific consideration. And the first remark which falls to be made is the extraordinary appearance which the moon presents to view when examined by a powerful telescope, for it is studded all over with mountains rising to a great height and of peculiar shape, and rugged, bare, and terrifying. Dr. Dick, who furnishes a pretty full description, classes them into 1. Insulated mountains rising from level plains like a sugar loaf, 30 of which are from 2 to 5 miles in perpendicular height; 2. Ranges of mountains extending in length 200 or 300 miles, in some places 4 miles in perpendicular altitude; 3. Circular ranges from 1/5 of a mile to 3½ miles high, and enclosing plains from 40 to 50 miles in diameter; 4. Central mountains in the midst of circular plains. There are likewise, he mentions, numerous caverns whose depth below the surface of the moon varies from 1/3 of a mile to 3.5 miles. Quote, 12 of these cavities, as measured by Schroeter, are found to be above 2 miles in perpendicular depth. These cavities constitute a peculiar feature in the scenery of the moon and in her physical constitution, which bears scarcely any analogy to what we observe in the physical arrangements of our globe. End quote. Rambosson says that the circular mountainous enclosures have diameters of 130 or 140 miles, so immensely larger than the craters of our volcanic mountains as to suggest forces of terrific grandeur sadly inimical to life. These are thought to be volcanic mountains, but Sir John Herschel mentions that there are here and there chains of mountains whose appearance suggests no suspicion of volcanic origin. Although Sir John also says that there are large regions perfectly level and apparently of a decided alluvial character, it would strike one that, apart from other considerations to be immediately averted to, a world so formed, to say nothing as to whether it would or would not ever be adapted for the growth of plants and trees, to which water as well as air are necessary, would not offer any attractions as a residence for a being like man. It would be dismal, horrible, and unfit for intelligent beings. Nor is there, upon examination of the lunar surface, any trace visible either of vegetation or of intelligent life. There are no patches of green, such as might indicate forests or grassy fields, no cities or extensive works to indicate the operations of rational beings. Professor Nichols tells us that the moon, quote, shines with most various colors. In the Mare Serenitatis, for example, large districts shine with the most beautiful green, intermingled with gray portions and several other tints. These varieties seem constant, and therefore indicate differences on the moon's soil or surface, suggesting the different aspects of light reflected from a desert of Sahara, a golden savanna in the New World, or a field of luxuriant and freshening fern. End quote. But this statement requires to be taken along with that made by Mr. Proctor, that, quote, although there are varieties, there has never yet been detected any variation of color. Nothing has been seen which could be ascribed with any appearance of probability to the effects of seasonal change. End quote. So that vegetation evidently does not exist. And as for changes resulting from the action of beings like man, Mr. Proctor, stating that we could only see edifices far greater than those yet constructed by man, which is surely much overstating the case, but that from the less force of gravity at the moon's surface, it would both be needful and in the power of inhabitants to build to much greater size than we do, concludes by saying that though such structures might be visible in our largest telescopes, quote, no object that could with the slightest appearance of probability be ascribed to the labors of intelligent creatures has ever been detected on the moon's surface. End quote. Dr. Whewell, mentioning that Professor Phillips had stated at the meeting of the British Association in 1853 that astronomers could discern the shape of a spot on the moon's surface of a few hundred feet in breadth, and that such changes as have occurred upon the earth would be visible through telescopes in the moon, remarks that we should see like changes if they're going on upon the face of the moon. Quote, yet no such changes, he says, have ever been noticed, nor even have such changes been remarked as might occur in a mere brute mass without life, the formation of new streams of lava, new craters, new crevices, new elevations. The moon exhibits strong evidences which strike all telescopic observers of an action resembling in many respects volcanic action by which its present surface has been formed. But if it have been produced by such internal fires, the fires seem to be extinguished, the volcanoes to be burnt out. It is a mere cinder, a collection of sheets of rigid slag and inactive craters. And if the moon and the earth were both at first in a condition in which igneous eruptions from their interior produce the ridges and cones which roughen their surfaces, the earth has had this state succeeded by a series of states of life in innumerable forms, till at last it has become the dwelling place of man, while the moon, smaller in dimensions, has at an earlier period completely cooled down, as to its exterior at least, without ever being judged fit or worthy by its Creator of being the seat of life, and remains hung in the sky as an object on which man may gaze, and perhaps from which he may learn something of the constitution of the universe, and among other lessons this, that he must not take for granted that all the other globes of the solar system are tenanted, like that on which he has his appointed place." End quote. Still, we have been dealing hitherto only with negative considerations. We must now look to the reasons which exist for a positive exclusion of life. And the first of these is the absence in the moon of the slightest trace of water or of cloud. Upon this all astronomers are agreed. Thus Professor Nickel, referring to a map of the moon prepared by Messrs. Bayer and Mädler of Berlin, says, quote, "On the face of that map there may be seen a number of comparatively dark and untroubled spots, visible in general to the naked eye, and which were at first thought to be seas, whence their present names. Not a drop of water, however, or of any fluid akin to it, is now in the moon, for when the line of light in the crescent luminary passes through these so-called seas, its edge, instead of following a fine and unbroken course, is quite irregular, proving that these flats are land, although comparatively unbroken and undisturbed. Probably they are in some cases the subsided parts of the outer shell or bed of that globe. Besides, there are no clouds, and as the moon has a small atmosphere, this alone is decisive, for otherwise vapors would float there, and the purity of the disk appear variable." End quote. Dr. Deck also observes that the so-thought seas are simply extensive plains, diversified with gentle elevations and depressions, and consisting of substances calculated to reflect the light of the sun with a less degree of intensity than the other parts of the lunar surface. Professor George Wilson says, "The moon has no clouds or rain, nor dew, nor lakes, nor rivers, nor seas." Mr. Proctor says, quote, "There are no seas or oceans in the moon. Were there any large tracts of water, the tremendous heat to which the moon is subjected during the course of the long lunar day, lasting a fortnight of our time, would certainly cause enormous quantities of water to evaporate, and not only would the effects of this process be distinctly recognizable by our telescopists, but the spectroscope would exhibit in an unmistakable manner the presence of the aqueous vapor thus formed." End quote. A supposition has indeed been made that at one time the moon possessed seas, but that the water has been drawn to the interior by the force of gravity or of pressure, and that the same process is proceeding or has proceeded upon the Earth and other planets. But I am not aware that this theory rests on any reliable evidence or data, and it is opposed by many objections, the more especially if it be assumed as necessary to its maintenance that the moon is older than the Earth, and the interior planets are older than the exterior, which would seem to be in opposition to the views obtained from the nebular hypothesis. Supposing, however, that water had at one time existed and was now so withdrawn from the moon, would not the influence of the Earth's attraction, exerted upon it with a force more than tenfold the power which the moon exerts upon our seas, together with the, to us, horrible nature of the moon's surface, have rendered our satellite entirely unfit for the abode of rational beings? The likelihood, indeed, rather, is that the moon, as the smaller body, cooled down while the Earth was still in its original nebular glow, and perhaps extended far out towards the moon itself, and it may be attracted to it every particle of moisture which could form into the shape of water. Leaving this theory, which remains to be substantiated, and if true, would not necessarily infer life of any kind while the fluid lasted, it is clear that no seas do exist in the moon. Footnote. Supposing this theory maintainable as regards the other planets, it would not suffice to have made them habitable, and does not meet the positions with regard to them which have already been and will be stated. End of footnote. Equally important is it that there does not exist in the moon an atmosphere. On this philosophers are all but agreed, and even those who suppose that any atmosphere exists believe it to be very scanty and finely attenuated. Nor does it at all follow that if there were any it would be life-supporting. This is a circumstance never sufficiently regarded, and which I cannot press too strongly. However, there seems no room to hold that an atmosphere of any kind encircles the moon. At one time, the luminous corona of the sun, seen during an eclipse to surround the moon, was believed to be due to a lunar atmosphere, but this idea has long since been disproved and abandoned. Sir John Herschel says that were there any atmosphere, it would not fail to be perceived in the occultations of stars and the phenomena of solar eclipses, as well as a great variety of other phenomena, and concludes, quote, the non-existence of any atmosphere at the moon's edge dense enough to cause a refraction of 1 second, that is, having 1/1980th part of the density of the Earth's atmosphere. Mr. Grant, in his History of Physical Astronomy, discusses the subject carefully. From the uniform appearance presented by the lunar spots, he says, it is reasonably supposed that they are not occasionally obscured by clouds, and hence the moon cannot be like the Earth, encompassed by a gaseous fluid. Again, he points to the fact of there being no sensible change of color and diminution of luster on stars passing into occultation as another evidence, and the very rare cases in which the contrary has been observed not being general, cannot establish the existence of a lunar atmosphere. In like manner, he disposes of individual cases where, when a star has come up to the moon, it has been observed to hang on the margin of its disk for 3 or 4 seconds previous to disappearance, a circumstance sufficiently disposed of by the observation of Mr. Proctor after mentioned. Another reason is that, were there an atmosphere, its refraction would cause the star to be visible for a short time previous to disappearance, and for a like period prior to its emergence. But calculation shows there is no such refraction. He adduces in further evidence of there being no atmosphere to cause refraction the circumstance that planets do not, in coming in contact with the limb of the moon, suffer distortion of figure. He also refers to certain investigations of Du Séjour, a French astronomer, upon supposed refraction exhibited during solar eclipses, which, if well founded, would give a lunar atmosphere 1,400 times rarer than common atmospheric air, and consequently exceeding the most perfect vacuum which had been hitherto formed by means of the air pump. Lastly, astronomers had failed to discover any twilight, though Schroeter had at length succeeded in observing such an appearance which, if correct, would give a small amount of atmosphere. It would appear, however, that Schroeter must, for the reasons assigned by Mr. Proctor, have been mistaken, and that in reality there is no twilight, and hence no atmosphere. Mr. Proctor, in his work on the moon, shows that, supposing the moon had an atmosphere equal to our own, it would, under the small attractive power of the body, extend to a height of 22 miles, and would be so attenuated that men would perish if placed in it. It will be readily seen that if instead of being equal to our own, it is so minute in quantity, as is supposed by these philosophers, life would be altogether impossible. A heavier gas, Mr. Proctor proceeds to show, would produce the effect of refraction, and even were the atmosphere possessed of only a 1/4 part of the refractive power of our own, a star in reality behind the moon's disk would appear as a ring of light, the light from the star being increased as by an enormous lens. Mr. Proctor further states that sometimes a star has been observed to diminish just before disappearance, which may be attributable to the star being a close binary or a multiple star, or perhaps a nebulous star, and that, on the other hand, a star has seemed to advance for some distance on the moon's disk before vanishing, which may be attributed to its chancing to cross the moon's limb, where a valley or ravine has caused a notch or depression which is too small to be indicated by any ordinary method of observation. He adds that the evidence thus obtained is strengthened by spectroscopic evidence, Mr. Huggins finding that the spectrum of a star disappears as instantaneously as the star itself. But the strongest evidence in Mr. Proctor's view that the moon has no atmosphere, or so little that she may be regarded as practically airless, is that in a solar eclipse the sun would not disappear at all, even at the moment of central eclipse, because if there were a lunar atmosphere, it would act as a lens, and reveal the sun as a ring of blazing luster, as really sunlight as the light of our setting sun. A very shallow lunar atmosphere would suffice. It was at one time thought, as already mentioned, that the existence of active volcanoes had been discovered in the moon, and that this, as indicating fire, would prove an atmosphere. As soon, says Professor Leach, as the telescope, unveiled a world so like our own in its general aspect, the popular imagination peopled it with living forms, and astronomers strove with one another to gratify the popular wish. On the dark surface, active volcanoes were discovered. The flames were seen to burst forth with great fierceness and then slowly expire, showing that there was air to sustain the combustion. Planets and fixed stars were seen to linger on the moon's edge before they passed behind its disk, just as they ought to do if there was an atmosphere. All these observations are now discredited, and the inexorable decision of scientific research is that there is no valid argument for the existence of an atmosphere." End quote. That astronomers, however, and men like Sir William Herschel have fancied they had perceived volcanoes is true, and Sir David Brewster, observing in his usual positive manner, quote, "that volcanoes or burning regions have been observed in the dark portion of the moon's disk cannot be doubted," end quote, adduces the supposed instances. But Schroeter and others, even including Dr. Dick, prone as he is, like Sir David Brewster, to contend for the habitability of the orbs, ascribe the appearances to light reflected from the earth. Mr. Proctor, in his Moon, discusses the supposed instances, showing how unreliable were the observations, although changes such as have been supposed might probably arise from other causes than fire, and concludes, quote, "The inference would seem to be that the supposed changes have been merely optical." End quote. Perhaps the most conclusive evidence of all, however, is afforded by spectrum analysis. Mr. Proctor alludes to this, remarking that, quote, "when the spectrum of the lunar light has been observed, by Dr. Huggins first and later by others, it has been found to be absolutely similar to the solar spectrum. That is, there is no trace whatever of absorptive action exerted by a lunar atmosphere upon the solar rays which are reflected by her to the earth." This evidence is, of course, not demonstrative of the absolute want of air of any sort in the moon, because a very rare and shallow atmosphere would produce no appreciable absorptive effect, but it confirms the other evidence, showing that any lunar atmosphere must not only be extremely shallow, but extremely rare. An atmosphere sufficient in quantity to give traces of its presence in lunar shallows, but not extending higher than the summits of the lunar mountains, must be of a specific gravity so greatly exceeding, under the same conditions, that of common air, or indeed of any gas known to us on earth, that we are justified in regarding the theory of its existence as altogether unsupported by evidence. The conclusion to which we seem forced by all the obtainable evidence is that either the moon has no atmosphere at all, which seems scarcely possible, or that her atmosphere is of such extreme tenuity as not to be perceptible by any means of observation we can apply." End quote. This slender atmosphere, if it exists, is not, as we have already seen, capable of sustaining life. But the spectroscopists state the same thing, and even more unqualifiedly. Mr. Roscoe, referring to the observations of Dr. Huggins and Dr. Miller, says, quote, "The conclusion must be drawn that the moon is devoid of any appreciable atmosphere." And Schellen, quote, "The observations of Fraunhofer, 1823, Brewster and Gladstone, 1860, Huggins and Miller, as well as Jensen, agree in establishing the complete accordance of the lunar spectrum with that of the sun. In all the various portions of the moon's disk brought under observation, no difference could be perceived on the dark lines of the spectrum, either in respect of their number or relative intensity. From this entire absence of any special absorption lines, it must be concluded that there is no atmosphere in the moon, a conclusion previously arrived at from the circumstance that during an occultation no refraction is perceived on the moon's limb when a star disappears behind the disk. Moreover, a small telescope of only a few inches aperture suffices to show the spectrum of the moon very distinctly." End quote. But what for some time was regarded as a grand discovery, calculated to upset the notion that the moon is entirely uninhabitable, was made, or thought to be made, by M. Hansen. Professor Leach, introducing the matter with a great flourish of trumpets, tells us that the cause of an irregularity in the moon's path was solved by M. Hansen, finding the center of gravity and the center of the figure of the moon to be, quote, "distant about 37 miles from the other." Most momentous results flow from this. The one hemisphere must be lighter than the other. The application is very direct and startling. Suppose the sphere of the moon originally covered with water and enveloped in an atmosphere, both water and air would flow to the heavier side and leave the lighter side destitute of both, just as water and air leave the summits of our mountains and gravitate towards the valleys. They seek the lowest level, or in other words, the point least distant from the center of gravity. In the case of the moon, the side turned to us is virtually one enormous mountain, and the opposite side the corresponding valley. We could not expect to find traces of air on the summit of a terrestrial mountain 134 miles high. The conclusion, therefore, is that though the near hemisphere is a lifeless desert, having neither water nor air to sustain life, the hidden hemisphere may have a teeming population, rejoicing in all the comforts and amenities of life. The imagination is set free to picture broad oceans, bearing on their bosom the commerce of this new world, rivers fertilizing the valleys through which they flow, a luxuriant vegetation, and buildings of colossal size." End quote. Mr. Leach devotes a whole chapter to this discovery. Sir John Herschel adopted it as not improbable, and it was currently credited by others. One would have thought that the attraction of the earth would rather have drawn away air and water on the moon towards the side exposed to the influence, just as the moon, with a greatly less power, influences tides upon the earth, and failing water and air, that the attraction would be as suggested upon the body of the planet itself, causing it to bulge. The question has, however, been taken up by Mr. Proctor with his usual ability, and referring to examinations made by Mr. Gusso and others, he says, quote, "But pleasing though the idea may be that on the further hemisphere of the moon there may be oceans and an atmosphere, it appears to me impossible to accept this theory. In the first place, it has not been demonstrated, and is in fact not in accordance with the theoretical considerations, that the moon is egg-shaped or bispherical, according to Gusso's view. The further part may also project as the nearer part does, supposing Gusso's measurements and inferences to be trustworthy. But even if we assume the moon to have the figure assigned to it by Gusso, the invisible part is not that towards which the atmosphere would tend. The part of the surface opposite the center of the visible disk is in fact not the nearest to the center of gravity, but, assuming the unseen part spherical, and of the radius indicated by the visible disk, is 30 miles farther from the center of gravity than are points on the edge of the visible disk. The band or zone of the moon's surface lying on this edge is the region where oceans and an atmosphere should be collected, if water and air existed in appreciable quantity on the moon's surface." End quote. In a footnote, he quotes the argument presented in another form as contained in a paper contributed by him to the monthly notices of the Astronomical Society. In a later work, Expanse of Heaven, page 45, Mr. Proctor gives an additional reason against the existence of water and air on the farther side of the moon, in the fact that we see partly round it, the parts seen at one time amounting in all to 589 out of 1,000, the parts never seen amounting to only 411, and no signs of air or ocean detected on those revealed portions. Mr. Callie Miller, giving also a lively account of the supposed discovery resulting from the moon being observed on a certain occasion to have got no less than 3 seconds behind her proper calculation, assigns the shattering of the theory to Professor Adams, who, quote, "showed that the calculated 3 seconds discrepancy could be accounted for by more natural causes, proving that the moon's eccentricity was both unnecessary and untenable, and dealt a death blow to the Antipodean Selenites by cutting off their water supply and putting them under an air pump." End quote. Dismissing, therefore, the idea of an atmosphere on either hemisphere of the moon, some strange results follow, and are thus described by Flammarion. Quote, "On approaching the moon, nothing is seen of the physical causes which make the earth a vast laboratory, wherein 1,000 elements contend or unite with each other. There are none of those tumultuous tempests which sometimes sweep over our inundated plains, none of those hurricanes which descend in waterspouts to be swallowed up in the depths of the sea. No wind blows, no cloud rises to the heavens. There white trains of cloudy vapors are not seen, nor those leaden masses with heavy cohorts. The rain never falls, and neither snow nor hail, nor any of the meteorological phenomena are manifested there. But on the other hand, the magnificent tints which color our sky at sunrise and twilight, the radiations of the heated atmosphere, are never seen there. If winds and tempests never blow, neither is there the balmy breeze which descends upon our coasts. In this kingdom of sovereign immobility, the slightest zephyr never comes to caress the hilltops. The sky remains eternally asleep in a calm incomparably more complete than that of our hottest days, when not a leaf moves in the air. This is because on the surface of this strange world there is no atmosphere. From this privation results a state of things difficult to realize. In the first place, the absence of air implies also the absence of water and every liquid, for water and liquids can only exist under atmospheric pressure. If this pressure is taken away, they evaporate, and their beds are dried up. From the absence of air follows another very curious fact, the absence of sky. On the surface of the moon, when the looks are directed towards the sky, there is none to be seen. An immensity without depth is traversed by the sight without resting on any kind of form, and in the day as in the night are seen the stars, planets, comets, and all the bodies of our universe. The sun passes among them without extinguishing them, as it does to us. Not only does the moon not possess this perpetual diversity which the movements of the air produce in our world, but it has not the azure vault which covers the earth with such a magnificent dome, spaces of black, and a perpetually black abyss. Quote, "Whilst on high there reigns darkness, below there is silence. Not the least sound is ever heard. The sigh of the wind in the woods, the rustling of foliage, the song of the morning lark, or the sweet warbling of the nightingale never awakens the eternally dumb echoes of this world. No voice, no speech has ever disturbed the intense solitude with which it is overspread. Unchangeable silence reigns there in sovereignty." End quote. Similarly, Professor Leach says, quote, "Eternal silence must reign there. A huge rock may be precipitated from the lofty lunar cliffs, but no sound is heard. It falls noiselessly as a flock of wool. The inhabitants can converse only by signs. The musician in vain attempts to elicit sweet music from his stringed instrument. No note ever touches the ear. Armies in battle array do not hear the boom of the cannon, though rifled arms, from the low trajectory of the ball, must acquire a fatal precision and range. No moving thing can live aloft. The eagle flaps its wings against the rocks and in vain attempts to rise. The balloon, instead of raising the car, crushes it with the weight of its imprisoned gas." End quote. These are the descriptions of two advocates of plurality. It is evident that even were life possible in the moon, it could not be the abode in such circumstances of intelligent beings. But there is a still further fact now to be stated, a fact destructive of any life, and therefore, and in any view taken along with the absence of water and air, conclusive against the habitability of the moon. It lies in the enormous length of the lunar days and nights. In the words of Mr. Proctor, quote, "The lunar day lasts about a fortnight, and the lunar night is of course equally long. Were this all, the inconvenience of the arrangement would be unbearable by beings like ourselves, but far more serious consequences must result from the combination of the arrangement with the want of an atmosphere, for whereas during the lunar day the surface of the moon is exposed to an inconceivably intense direct heat, undoubtedly sufficient to heat that surface far above the boiling point, during the lunar night the heat is radiated rapidly away into space, no atmosphere checking the process, and an intensity of cold must prevail, of which we can form but imperfect conceptions." End quote. With this agree the statements of Rambosson, page 191, Herschel, Leach, and others. Professor Leach says, quote, "The inhabitants, having no atmosphere to shelter them from the sun and store up its heat, must recoil with terror from its fierce rays. During the long lunar day the ground must become as burning marl, from which the scorched feet shrink with pain. During the equally long night it must be colder than frozen mercury. No fuel will burn to mitigate the rigor of the cold, and none but the electric light can avail to dispel the darkness." End quote. It has been calculated, says Cooley, quote, "that the side of the moon facing the Earth has a few days after full moon a maximum temperature of 750 degrees Fahrenheit, 400 degrees centigrade, and again soon after new moon sinks to 187 degrees Fahrenheit, minus 122 centigrade." Lord Rosse was enabled to estimate the difference of temperature to be more than 500 degrees, so that probably when the sun was not shining on it, the temperature would be 200 or 300 degrees below zero, which under the vertical sun it would be as much above zero or hotter than boiling water. Vegetation and life of all kinds could not abide exposure to such scorching heat or to such inconceivable cold. The sudden and constant alternation from a far less extent of either would also of itself be equally fatal. We are therefore shut up to the conclusion that the moon, a body so large as to contain a surface of 14,600,000 square miles, is incapable of life, and in this opinion all or nearly all are now agreed. But the fact has a most telling bearing upon the present inquiry. It is not the mere displacement of one solitary body from the world of life. It breaks the argument for all. Among the writers on plurality I have only noticed one, Dr. Whewell, who has perceived the deduction to which this momentous fact inevitably leads. He thus forcibly puts it, quote, "If it appear by strong evidence that the moon is not inhabited, then there is an end of the general principle that all the bodies of the solar system are inhabited, and that we must begin our speculations about each with this assumption. If the moon be not inhabited, then it would seem the belief that each special body in the system is inhabited must depend upon reasons specially belonging to that body, and cannot be taken for granted without such reasons. Of the two bodies of the solar system which alone we can examine closely, so as to know anything about them, the Earth and the Moon, if the one be inhabited and the other blank of inhabitants, we have then no right to assume at once that any other body in the solar system belongs to the former of these classes rather than to the latter. If even under terrestrial conditions of light and heat we have a total absence of the phenomenon of life known to us only as a terrestrial phenomenon, we are surely not entitled to assume that when these conditions fail we have still the phenomenon of life. We are not entitled to assume it. However, it may be capable of being afterwards proved in any special case by special reasons, a question afterwards to be discussed." End quote. At the time Dr. Whewell wrote, it will be kept in view further that spectrum analysis had not been employed to the extent it has now been in the investigation of the stars. End of section 16. Read by Sandra near Montreal, 2025.